Data analysis with Python 0 to Pandas is a practical, beginner-friendly and coding-focused introduction to data analysis. This is a live online course and you can earn a verified certificate of accomplishment by completing this course. If you're interested in learning data science with Python but don't know where to start, then this course is designed just for you. You can learn more and register at 0topandas.com. By the end of this course, you will be able to confidently use the Python programming language and its amazing ecosystem of data science libraries, like Numpy for mathematical and statistical computing, Pandas for data processing and analysis, Matplotlib for creating beautiful visualizations, and much more. You will get a chance to practice and improve your skills with weekly assignments, and you will also work on an end-to-end course project where you will perform data analysis on a large real-world dataset. This is a beginner-friendly course, so you don't need to have any prior knowledge of Python or data science. Some basic programming knowledge will be helpful, but don't worry if you don't know programming. You can learn these concepts with a little extra effort. You will also get access to the course community forum where you can ask questions, join a study group, and share what you're working on during the course. This course is created by Jovian.ml, a sharing and collaboration platform for data science with a worldwide community of tens of thousands of users from more than 150 countries. So register now and invite your friends to join the course at 0topandas.com. I'll see you in the first lecture. I'm your instructor. My name is Akash. I'm the co-founder and CEO of Jovian.ml. And before this, I've worked as a software engineer at Twitter, where I've worked in data engineering and software development. I hold a degree in computer science from IIT Bombay. And in the past, I've also been a world finalist at the ACM ICPC. I have been using Python for the last 12 years. You can find me on Twitter on @Akshanis. Now, a quick overview of the course before we get into it. 0 to Pandas is a coding first introduction to data analysis using Python. We will be talking about data analysis. We will write code, and through code, we will learn whatever mathematical concepts we need. All the material will be available to you, so you can try it out. You will also get some assignments where you can practice these concepts. And if you complete all the assignments and exercises, then you will earn a certificate of accomplishment. So this is what the certificate looks like, the certificate offered by Jovian.ml. Now let's take a look at the course curriculum. Today we are going to talk about Introduction to Programming with Python. We will cover the parts that are necessary to start doing some data analysis. Then we will move on to the Numpy library. Numpy is used for numerical computation in Python. We will see how to perform statistics with Numpy. Next, we will analyze tabular data using Pandas. You can think of it like working with spreadsheets, but instead of the user interface, you will write some code, just a few lines of code, and it is far more powerful than spreadsheets. Then the lecture is dedicated to data visualization with Matplotlib and Seaborn. These are two great libraries for visualization. You can draw different types of graphs, line graphs, bar graphs, heat maps. We will also learn how to use it, when to use it, which type of graph to use. And finally, we will bring all this together to do exploratory data analysis of a real world data set. We will first learn to ask the right questions about the data. We will identify the right tools for the job. Then we will also learn, after doing your analysis, how do you present it? So storytelling and presentation is a very important component that is often overlooked. So we will focus on that. There's a lot of material we will cover, and we will cover it gradually. So don't worry, even if you're at a beginner level, if you just know a little bit of programming, you should still be able to catch up. And there will be weekly assignments. Here you will get to practice your skills and learn by doing. You will also be able to get help from the community. And then there is a course project at the end, something that brings everything together, where you will get to work on an end-to-end project involving a real-world dataset that is picked by you. You will get a chance to apply all the tools and techniques that you have learned in this course. The goal of this course project and this entire course is to create something that you can proudly showcase as your own original work on your professional profile. You have to submit all the weekly assignments, you have to complete the course project, and you have to follow the academic honesty policy, which essentially is no plagiarism. That is, do not take somebody else's work and claim credit for it. Let's get started then. Now the course page is 0topandas.com. This course page contains all the information about the course. You can go through the details here. There are some links here. There's a link to the course community discussion forum. There's a link to frequently asked questions. And then we have the lessons and the assignments. So let's open up lecture 1. So here you will be able to see the video. You can see the code used with this lecture. You can just scroll down and see it, or you can see each mini tutorial on its own page by clicking on these links. So I'm just going to open up the first link. So now what you're looking at is a tutorial, a Jupyter notebook, and we'll cover what that means. Now we need to be able to run the code. So I am going to run the code. So while that starts, when we click run, we take the same code and explanations and everything, and then open it up on an online platform which allows us to execute this code. While that starts, on the lesson page, you will find a link to a discussion forum. So you can just click this link, and that will open up the discussion forum. And this is the place where you can ask questions. So that's how you ask questions. Moving along, I click the run button, and that opened up an interface like this. What you're looking at right now is called the Jupyter interface. So a place where you can write some code, a place where you can execute some code. Jupyter is an IDE, or integrated development environment, and it runs completely on your browser. That's the great thing about it. Because if I zoom out here for a bit, I am looking at this Jupyter notebook running on my browser, but the actual execution of all the code will happen somewhere on this server called hub.mybinder.org. So right now what I'm looking at is the files associated with my project. And the file that you want to open up is called First Steps with Python. Just click the First Steps with Python file, and that will open up for you to see. So the first thing that I'm going to do is to click on the kernel menu and click restart and clear output. What this will do is I've written some code and I've executed it, and there are a lot of outputs of the code. I just want to remove them so that we can execute the code from scratch. I will also just hide the header so that we have a little more space to see things. Now we're ready to go. This is our first step with Python and Jupyter. This will be like a quick Python tutorial, but we will pick up all the important topics that we need to start doing data analysis. While I go through this material, I will leave out some of the things as exercises for you to try out. But there's a lot of detail, there's a lot of explanation here. There's an explanation on how to run the code. So we are running it online. So we use the run button, but you can also run it on your computer locally, and there are some instructions here. The setup is a little bit advanced, so I would recommend skipping it if you are just getting started. Now coming to Jupyter notebooks themselves, this document that we are looking at, it is made up of cells. It is like a stream of cells. So you have cell after cell, and cells can contain explanations. So here I have written some explanation in a cell, or cell can contain some code or some programs written in Python. Now cells can be executed and their outputs can be viewed right within the notebook, which makes it a really powerful platform for experimentation. You just type something and you run that code and see its output, then you change it and try it again, and then you add some explanation using a text cell. So it's great, and we really love Jupyter notebooks. That's why we've built so many things around it. So the first thing that we will do is to start using Python as a calculator. That's the simplest way to use it. And what you can do is you can simply write and execute Python code by adding a code cell within Jupyter. So how do you add a code cell? There are a couple of ways to do it. By the way, what you're looking at here is a code cell, but I'll show you how to create a code cell. So you can click on a cell, so select a particular cell, and this one is a text cell. So then you go insert and insert cell below. So when you do insert cell below, that automatically adds a code cell for you. You can also change the type of this cell. You can change from code to markdown. So markdown is text basically, and then you can type some text. And then what we are going to do is we are going to start running some code cells. So I already have a code cell here. I'm not going to add more. And here are some simple arithmetic expressions that I've written out, 2 plus 3 plus 9. And now to execute this code, what I need to do is to click the run button. So there's a run button here that you can click. You can also click cell run cells, or there's a nice keyboard shortcut here, which is shift plus enter, and that will execute and give you the output. So that's great. Now we are able to add numbers with Python. Here's a subtraction. Here is a multiplication. For multiplication, we use the star sign. Here is a division, 100 divided by 7. Python automatically converts that into a decimal number, even though these are integers. and you can see that it's about 14.28. Now, if you just want to get the quotient without the decimal part of it, just get an integer, then you use a double division sign here, 100 by 7. And if you want to see the remainder, then you use this percentage or ampersand operator. This gives you the remainder. So the remainder is 2 and the quotient is 14. And we can verify that. We can just take the remainder 2 and we can add it to 14 times 7 and we get 100. So you can combine them as well. Another operator that you might want to learn about is the exponential operator. So this simply does 5 to the power of 3. You can try 5 to the power of 5 and so on. So as you might expect, this is really simple to get started. You write a code cell, you put some code into a code cell and then you execute it and it works. And that is valid Python code. So that's great. And as you might expect, these operators have certain precedence by default, but you can also combine them and you can specify the order in which they need to be evaluated by specifying brackets. For instance, here I've put 2 plus 5 in a bracket. So that gets executed first, then this, and then these two get multiplied. Then that gets divided by 4 to the power of 3. And that's the output. So that's basic arithmetic with Python. These are the operators that are supported: addition, subtraction, multiplication, division, and exponent. And what you can do as an exercise, if you're new to Python, if you're new to programming, is just open up some word problems. I've given a link to some simple word problems and try to solve them by adding some formulas here and just getting the outputs. So let's now solve a multi-step problem. So here we have a grocery store that sells a bag of ice for $1.25 and makes a 20% profit on each bag. If it sells 500 bags of ice, how much total profit does it make? Okay, a simple arithmetic problem. You may have seen this in school, probably primary school. So how we go about it is we lay out all the information. So the cost of ice bag is 1.25. The profit margin is 20%. That is 20 by 100, 0.2. So the profit per bag is the profit margin times the cost of the ice bag. So then we have this expression, and then the number of bags is 500. And then the total profit then is number of bags times the profit per bag. So finally we end up with this expression. This is the point where you would pick up a calculator, and here we are going to use Python to do it. So the grocery store makes a profit of $125 total. Now this is an okay way to use it, but this is not using the full power of Python. And it's not clear by looking at the code what these numbers represent. So what we can do is we can actually give names to each of these numbers by creating variables. And variables are an interesting concept in a programming language where you can take information and put them into these boxes or containers and then give them a name. These boxes are called variables, and the information stored in them is called the variable's value. So here we are now going to create 3 variables. So the cost of ice bag is the first variable. It has the value $1.25. Then we have the profit margin, another variable. It has the value 0.2. And finally, we have the number of bags. This is 500. Now, one thing to keep in mind is that I have used underscores because variables need to be a single word, and you can break out words using underscores in Python. If you do not have this, then you will get an error. So now we have the cost of ice bag. That's great. We have the profit margin. We have the number of bags. Now in the arithmetic operations, we can start using these. By the way, this is called declaring a variable. So you put a variable name and then you put an equal to sign and then you put the value. So now the variable has that value. To check that value, you just type the name of the variable out and then you can see the value. Now we have the profit per bag. Now this is a new variable I'm creating. And to create this variable, I'm actually going to use an expression that depends on other variables. And this is a nice thing where you can start combining these things together and collect a lot of information. So now you have the cost of ice bag. So that's 1.25 times the profit margin. So that becomes our profit per bag. Then we have the total profit. So the total profit is the number of bags times the profit per bag. And now we can check the total profit. It is 125. So already this is much nicer where you go through these few lines and you understand what's really happening here. And the other good thing is now if you change the number of bags, like if you have on a different day, you have a different number of bags, you can simply reuse the values of these variables. You do not have to note them down somewhere else. That's a great thing about programming. One minor thing here, a variable has to first be defined using this assignment operation. if it is not defined yet, for instance, I've not defined a variable called net profit, and you try to access it, then you will get an error. And now don't worry if you get an error in Python, in Jupyter, because normally in a lot of programming languages, when you get an error, you have to stop. But in Jupyter, you do not need to stop. You can actually just go ahead and change something. Let's say the net profit, I just want to assign it a value of 100 and run it again, and everything will work fine. So that's a great way to just fix things, try out different ideas, break things, and then the more you break, the more you learn. So this is good. Now we are able to display the total profit, $125, but it would be nice to show this as a message. And that's what we can do using the print function. Now what's a function? Now a function is a reusable set of instructions. Just as we are writing some code, we are writing some programs here. A lot of programs have already been written for the common things that you might want to do. And Python provides a lot of built-in functions. The print function is what we're going to see. And it also allows us to define our own functions. So here now we have the print function. And the way to use a function is to type the name of the function, then open a bracket and then give it some inputs. So here we are giving it a first input. This is some text in English that we want it to print. One important thing to note here is that when we're giving it some text in English anywhere in Python, we need to use quotations, because otherwise Python tries to interpret this as code. But obviously there is nothing inbuilt in Python called glossary. So this will give you an error. And that is why we have quotations around anything written in English. That's the first input to print. So we're saying that print this, and then we give it a comma, and then we also print the value inside the total profit variable. All right. And that's the print function. So now that prints out the grocery store makes a total profit of $125. So great. We made good progress already. We've started using variables. We've started using the print function. Now, one thing that you can do here, because all of these code cells so far, we've just been writing a single line. It can get a little bit tedious and also a little bit confusing when you have all these different code cells. So Jupyter allows you to write multiple lines of code within a code cell. So what you can do is you can rewrite the solution to the problem that we saw above, and we can use just a single code cell here. So here we are saying that the cost of the ice pack is 1.25, the profit margin is 0.2, and then we are performing the calculation, and then we are displaying the result. And if I run this, you will see that it prints the exact same result. Now, one interesting thing here to note is that I've actually written some words in English, and I said use quotations, but I've not used quotations. That's because this is a comment. So here, what happens is the moment you enter the pound or the hash character, and then maybe give a space after it. So when you enter the hash character inside a code cell, that becomes a comment. That is where you can write something that will be ignored by the Python interpreter. So Python will not evaluate it, but this is information that you want to share with somebody who is going to read the code. For instance, I have shared this notebook with you, and you can now understand by reading this comment what this block of code does. Similarly, blank lines are ignored, and then this comment is ignored as well. This is called documentation. Comments are a great way to just document what you are doing. And there are a couple of ways to define comments. So comments can live at the end of a code statement. Comment can have its own line, or comments can also span multiple lines. And you can try these out. This is an exercise for you to try out. I will not go over it in a lot of detail. The next thing that I want to cover is evaluating conditions in Python. So here I have a few variables, and if I want to check that it has a certain value or not, let's say I want to check if my favorite number is actually equal to 1, then Python has the equal to operator. This is called the equality check. So here you give it something on the left and then something on the right, and it compares the two and returns true, the value true, if they are equal. On the other hand, if the two values are not equal, for instance, my favorite number and my least favorite number are not equal, it returns false. Okay, so there's the equal to operator. And then there are a few of these. So there is the not equal to operator. So this is read as not equals. Then there is the greater than operator. And then there is less than operator. For instance, here is the less than operator. My favorite number less than 10. That's true. And my least favorite number, which is 3, less than my favorite number, which is 1. That is false. Okay. Then we also have a greater than equal to operator and a less than equal to operator. The key thing to note is that they return true or false, which are special keywords in Python. So that's operators. And just like arithmetic operations, the result of a comparison operation can also be stored in a variable. So for instance, here I have the cost of the ice bag is 1.25. And if I check if the cost of the ice bag is greater than 10, I can put that result into is ice bag expensive? And then I can simply print out that result. So you can see that the ice bag is actually not expensive since the value is false. Conditions can be combined. There are three logical operations to combine conditions. One is the AND operation. So A and B holds true only if both A and B are true. Otherwise it's false. Then we have the OR operation. The OR operation A or B holds true if either one or both of A or B are true. And finally you have the NOT operation. So NOT simply takes a condition and then reverses the condition. For instance, my neutral number has the value 3. So this condition is true. And then when you say not, so not true becomes false. So you can play around with this. And what I would suggest, the way you try this out is to just go to File and then go to New Notebook, open up a new Python 3 notebook. Now take that and put that into one half of your screen. And then take the existing notebook and put that into the other half of the screen. And especially if you're new to Python, if you're new to Jupyter, what you should be doing is you should be looking at the code and typing it out yourself. And this is a great way to learn for beginners. Just type out everything. Do not just do a shift enter so that you just run through everything in 20 minutes and you're done. Now take the time to type things out. Take the time to try out experiments. Now you can break things. What happens if you do this? And I've not defined this. This is really the best way to just experience what it is like to write this code. This is how I recommend working on all the notebooks. Start with a blank notebook and just type out the code line by line. All right. So one last thing that I want to cover is that so far I've been typing some code into these code cells and then I've been writing some text here. You can actually edit this text as well. Maybe you need to add some more explanation for yourself. Maybe you want to take notes. So to edit this text, just double click on the text and then you can start editing it. For instance, I just do this as an edit and then I do shift enter again and that changes this text. One of the nice things about the way text is written in Jupyter is that it uses a formatting style called Markdown. So you can see here, this text actually is a header. And then below here, I have a bunch of different headers and then I have a bulleted list and I have a numbered list. So there's a lot of interesting stuff going on here. And it's really easy to create this style like this. Just to organize your notebooks a little better, you can use Markdown. And how do you use that? If I just double click, you can see that all I need to do to make my text bigger is to add a couple of pound characters and a space in a Markdown cell. And that will make my text big. So if you had 1 pound character, that will make a header, and then you can try different sizes of headers with different pound characters. To create a bulleted list, all you need to do is leave a space, line space, and then use the star character and then just write the items that will get converted into a bullet. You can also create a numbered list. You can also create links. This is a way to create a link. You can also include images. This is a way to include an image. And in fact, you can include code examples as well. Now these code examples that are inside the Markdown cells will not be executed. They cannot be executed. So it's more for an explanation or documentation purpose. Let me just run that and show you. So here's an image and here's the code. So Markdown is very simple. It takes 20 minutes to learn it and it's a really nice way to write pretty text. So you can learn the full syntax of Markdown. Here I've linked to a tutorial. So that brings us pretty much to the end of our first Jupyter notebook. So we've learned some Python here, basic arithmetic, logic, conditions. We've learned a little bit about the Jupyter interface. Now, as I said, this notebook is running online on a free service. It's just a website that lets you run Jupyter notebooks online for free. But since it's a free service, it's going to shut down after some time. So your notebooks, if you leave the tab, if you go away from it for 10 minutes or something, then this notebook will shut down. So what you can do is, whether you're running this notebook online or on your local machine, you can save your work from time to your jovian.ml account. So the same account that you used for logging in. All you need to do is run pip install Jovian. This is a command that will install a Jovian Python module, a Python library. It is what we will need to actually send our notebook, this notebook, to your Jovian account. Then we do import Jovian. Well, that actually imports the library and tells Python that we are now ready to use the library. And finally, there is a function called jovian.commit. So just as the print function, we've written a commit function that will take your notebook and that will put it on your Jovian account so that you don't need to do any other steps. So you just say jovian.commit and then you give it a project name. So you just type project equals, and here I'm just going to say first steps with Python demo. So now we have jovian.commit and project. And when you run this, it will ask you for an API key. So to get the API key, just go to jovian.ml. If you're not logged in, if you're on the website, you can just click sign up or sign in and sign in with Google or GitHub. But once you're logged in, you will see your profile, and on your profile, you will see an API key. So you can copy this API key, just click the button and it will get copied to your clipboard. And then let's come back here and let us just enter the API key. So it'll just show you a bunch of stars. It is hidden. I do not want you to see my API key. But once you press enter, this is then going to take this notebook and then put it online. Now I can just open up this link, the final link that it gives me, and I can shut this down. So there you go, right? Now I'm leaving this site and I'm shutting this down. And now I end up with this page, similar to the page that we started out with. We have the same Jupyter notebook here, and you can actually take this link and then share it online with other people, just as I did with you. And you can see that the notebook is here. You have all of these options. If you want to continue running, you can click run on binder and continue running. So this is how we use Jovian. And you will be using Jovian to actually work on the assignments and things like that. So that's a quick intro for you. Okay, so we've covered our first steps with Python. Now we're ready to move on to variables and data types. So just click the variables and data types link. Now this is yet another Jupyter notebook. Once again, click the run button, go to run and click run on binder. Okay, so now we are once again back on Jupyter. Once again, this is running online somewhere, and we can now open up the second notebook, Python variables and data types. Let's just give it a moment to load. There it is. And the first thing you need to do once again is go to kernel, restart and clear output. Okay, you need to do this only if you want to clear out all the outputs that are already calculated. So I just want to restart and clear all the outputs out. And let me just hide the toolbar so that you can see it better. Okay, so variables, and we know already what variables are. They are containers for storing informations, for storing data. And the data stored in a variable is called a value. And this is how you create and access the value of a variable. So you set my favorite color and then you access my favorite color. And a variable is created using this assignment statement that we've already seen. And note that this assignment statement is actually different from the equality comparison operator, which is the equal to operator, which operates on two things on the left and returns to you a value true or false. So this is a common mistake that we often do when we are starting out with programming, unfortunately. You can also define multiple variables on a single line like this, comma separated. So there you see they have the three values, and you can assign the same value to multiple variables by chaining an assignment operation. So for instance, if I write color 6 equals magenta, then I can say color 5 equals that, and then I can say color 4 equals that. So that chains these operations and each of them gets the same value. So that's how you create variables. Now in Python, you can change the value stored in a variable simply by assigning a new value to it. Now if I redefine or reassign the value red to my favorite color, you can see that the value blue has gone away. The value blue is lost and no longer accessible. And now the value has become red. So this is important, that when you reassign a variable, the old value is lost, gone. So be careful. What you can also do is that while reassigning a new value, you can use the old value of the variable as an input to the expression which is used to assign the value. For instance, counter equals 10. And then we are saying counter equals counter plus 1. Now, normally in math, you would cancel these out and this would end up with 0 equals 1. This is not what we can do here because this is assignment. So counter plus 1 becomes 10 plus 1, and that gets put into counter. So counter has the value 11, right? And since this is such a common pattern, whenever you're doing variable equals variable and then operator something, you can also write it like this. So counter equals 10, and now we do counter plus equals 4. That's the same as counter equals counter plus 4. So this is how you create variables. Now, a quick note on naming variables. Variable names can be short, like a single character A, X, Y, or they can be long, like my favorite color, profit margin, the Three Musketeers. But there are a few rules you have to follow while naming Python variables. A variable's name has to start with a letter or the underscore character. It cannot start with a number. A variable name can only contain lowercase and uppercase letters. So A to Z, lowercase or uppercase. It can contain digits except at the first position, and it can contain underscore characters. And then finally, variable names are case sensitive. So a variable with all lowercase is different from a variable with A and V in uppercase, and that is different from a variable. So these are all different variables with different values. Just be aware of that while creating variables. So here are some valid legal variable names. And below, what you can see here, these are some invalid variables that I've created. So here we have a space that causes a problem. Here we have a special character that causes a problem. Here we have the hyphen. Python actually reads this as a minus. It tries to subtract these three variables, but they don't exist, and that's why there's an issue. And finally, here we are trying to use a number as the starting. You cannot start a variable with a number. So that's all we wanted to talk about variables. It's a very simple concept. Python makes it really easy to use them. And at this point, what we'll do from now on is after every section, just record our work. So I'm just installing the Jovian library and I'm running jovian.commit. So that's committed now. Any data that you store inside a Python variable has a type. So far we've been working mainly with numbers, but there is a lot of different types of data that you can store within a Python variable. And a variable's type can be checked using the type function. For instance, a variable has the value 23 and its type, if you use the type function, its type is int. Int stands for integer. Similarly, is today Saturday? It's false. Its type is bool. It stands for boolean. My favorite car is some text and its type is str, which stands for string. And finally, the Three Musketeers, it looked like it was like a list of three strings. So it has the type list. And Python has several built-in data types for storing different types of information into variables. What we will look at are some of the most commonly used data types. Now there are a few primitive data types: integers, floats, booleans, none, and string. And then you have these other types like list, tuple, dictionary, and then you have sets and classes and so on. These are called data structures or containers because they hold multiple pieces of data together. And each piece of data then has its own type. That's a key distinction. So let's start by looking at integers then. We've been working with them. We know what they are. They represent positive or negative whole numbers. So from negative infinity to infinity. Only thing to note is that they should not include any decimal points. So here's an integer and it has the type int, as we've already seen. Now, unlike other programming languages like C+ and Java, where you may have different types of integers, there is no such limitations on what is the lowest or highest value an integer can hold. In Python, all integers are arbitrarily large, right? So here you see a large negative number. It is quite arbitrarily large and it still has the type int, and that's integers, pretty straightforward. Then we have floats or floating point numbers. So these are basically numbers with a decimal point. Again, there is no limit on the value of the float, although what will happen is some kind of approximation might happen depending on how many decimals you put in. So they are a little bit limited compared to integers for sure. So here I'm looking at the value of pi, the mathematical constant. I put in 3.14 and so on, and then I can check its value. And you can see here that it actually truncated the value around 15 or 20 decimals. So there is a limitation in floats there. And then if you check the type of pi, that turns out to be a float. And one important distinction here that we often tend to miss is that even a whole number is treated as a float if it is written with a decimal point. For instance, here we have a number which I've written as 3.0. That's a float because there's a decimal there. And similarly, even if I do not have something after the decimal, even if there's just a decimal, that is also treated as a float. So just know that sometimes that trips people up a little bit. And then there's another way to write floating point numbers. Let's say you have a very small number with 0.5 zeros and then a 1. The way you can write that, let's say if you want to do 0.00001, you do 1e minus 5. So that e minus 5 basically gets converted to 10 raised to the power minus 5, and that gets multiplied with this number. But I'll just do 1e minus 2, and you can see it has the value 0.01. Here's another one. Here I'm using a positive exponent. So here this is the Avogadro number. So here 6.022 times 10 to the power 23. And there you go. So that is the Avogadro number. That's pretty much it about floats. Again, pretty straightforward. And floats can be converted to integers and vice versa. So the way to do it is using the float and int functions. So the types that we see, these are actually functions that you can use. So the float function, if you pass it an integer, let's say float current year, or it had the value 2020. So now that becomes 2020.0, or float times a large negative number. Let's see what that value is. So what I'm doing here is I am actually going to insert a code cell. The way I could do it is say insert and insert cell below, or I can simply just press escape plus B and that will insert a code cell. Okay. So let's just type the name of a variable. And again, what you saw here was that I simply typed a_l, and then I press the tab character, the tab key, and that automatically completes to a variable name. So that's one nice thing about Jupyter. So you see here, it's a large negative number. We can convert it into a float. So when you convert it into a float, some precision is lost, but now you can see that it's written in scientific notation. Similarly, we can convert the value pi to integer. So pi was 3.14. When you convert a float into an integer, the part after the decimal gets removed. So even if you're at 1.99 and you convert it to int, that gives you back 1. So that can be a little unexpected sometimes. And finally, here we are taking the Avogadro number and converting it into integer. When we perform arithmetic operations, what happens is if all the operations are integers, generally speaking, the result is also an integer. But if any of the numbers that you're operating upon is a float, then the result gets converted into a float. So for instance, 45 times 3.0 is a float, but 45 times 3 is an int. Now one exception is the division operator. The division operator always returns a float because there's no way to know in advance whether there is going to be a decimal point or not. So just to be consistent, it always returns a float, whether it's 3.33 or whether it's 5.0. And if you want to get back an integer, you simply use the double division. This is also called the integer division operator, and that returns an integer. Okay, so that's floats, pretty straightforward. Then we have booleans. We've already seen these. Booleans are the results of conditions. Essentially, the boolean type has exactly two values, true and false. There's no other value there. Floats, there are unlimited. Integers, there are unlimited. But booleans are just these. And booleans have the type bool. So here I'm setting is today Sunday to true. Then I just check the type. This should say is today Sunday. Yeah. Just check the type of is today Sunday, and that turns out to be a bool. That's how you declare a boolean. It could also have been a condition. So let's say this could have been 2 less than 3, and it is still true. Let me revert that. And booleans are generally returned as a result of a comparison operator. So for instance, here I have the cost of an ice bag is 1.25, and I have the comparison whether it's greater than 10. So now the result, the variable is ice bag expensive, is holding a boolean value. You can check that with the type. And an interesting thing is that booleans are automatically converted to integers when they are used in arithmetic operations. True gets converted to 1 and false gets converted to 0. So it's useful that if you have a bunch of booleans and then you want to just add them together to just see how many trues there are or how many falses there are, you can simply add them as integers. So if I do 5 plus false, 5 gets converted into the integer 0. So we end up with 5. And if I do 3 plus true, and here I'm doing 3 dot. So first true gets converted to the integer 1. Then since you're adding an integer and a float, that gets converted into a float, and you end up with a float 4.0. So that's something to keep in mind. Another very useful thing is that any value in Python can be converted to a boolean using the bool function. So you just use the bool function, put in anything that you write in Python, any value or any expression, technically speaking. that expression will get converted into a Boolean. Now, when it gets converted into a Boolean, how does Python decide whether it should be a true or a false? There is only a limited number of things that become false. So the value false itself is false, and then all the empty states of the different data types, they get converted to false as well. So you have the integer 0 that gets converted to false. You have the float 0.0 is false. Then the empty value none, we will see it, that gets converted to false. The empty text, the empty list, the empty tuple, empty dictionary, empty set in range. So all of these get converted to false automatically. And we will see how this is useful later when we learn about if statements. These are some examples of false, and then here these are other examples of values that are converted to true. So these are called, the values that become false are often called falsy values, and the values that become true are often called truthy values. So it's also called falsiness of those values. So that's Booleans. Next we have the none type. The none type has a single value called none, and it is used to indicate the absence of a value, right? If you want to declare a variable, let's say, which may be assigned some value later on, or because of some reason you want to indicate that a value is missing, but you still have to, let's say, set a variable, then you can simply set it to none. And this is nice to have that type so that you don't have to use 0 as a fill-in or use false as a fill-in, which you have to do in other languages. So you just say variable name equals none, and that sets it to none, and it has the type. Nothing much going on there. Finally, the last primitive data type is a string. So a string is used to represent text in Python. Why is it called string? You can think of it like a string of characters tied together with a string, a sequence of characters. And strings in Python must be surrounded using quotations, and you can use either the single quote or the double quote. And strings have the type string, string. So here let's create a string today, and it has the type str. Oops, I guess this is an error. This should just say str. You can use either single quotes or double quotes to create a string. What might happen is that the text that you want to write itself may have single or double quotes, so just be careful about that. Now, if you're creating a string with a single quote and there is a single quote inside, for instance, one flew over the cuckoo's nest. Now what happens here is the string ends here, and then Python starts to execute this as proper Python code, and then it's going to show you an error. Okay, it says invalid syntax. So this is where what you might want to do. One technique is to just add a slash. This is the other slash that is above your enter or return key. So just add a slash. What it does is this escapes the next character so that it is not treated as a closing quotation mark. Okay, and the slash won't show up when you actually print it. That is one way to check it. So you can see here it says one flew over the cuckoo's nest. So we have escaped the quote. The other way is to simply use double quotations when you have single quotations in your string, and single quotations when you have double quotations in your string. And there are some more examples here. I will let you play with these. Now you may have a lot of questions. What happens if I have both double and single quotes? What happens if I have to break my string into multiple lines? I can't fit it on a line. All these things, Jupyter is a great way to try them out. The way you should try it is first try something, try what you think might be the solution and run it, and then get an error, and then maybe look up online, or maybe just take the error and Google it, or maybe just post that error on the forum, and then somebody answers it, and then you will learn how to actually do it. And once you do that, you will retain it better. So there are some examples of different types of strings. You can also create strings that span multiple lines. So for instance, here, this is a string that goes over 4 or 5 lines. The way to do that is to use 3 quotations. 3 quotations is a special marker in Python. That's our multi-line string, and you can experiment with these parts. I'm going to leave it up to you. But what's interesting is now already with string, even though it's a primary data type, it actually does contain a bunch of characters. So it's a container as well. You can actually check the length of a string using the len function. You can check how many characters it contains. For instance, length of my favorite movie, One Flew Over the Cuckoo's Nest, is 31. And then there are some special characters. So for instance, the /n character represents a new line. And then there are escaped characters. So these special characters or escaped characters are actually counted as a single character. So for instance, here I have a multi-line string where I start the string, then I have a, and then I have a enter. So now this enter is actually a character in Python, because Python stores the enter or the new line as a character, This is the /n character. Then we have B. So in total, there are 3 characters here. And you can see that sometimes it gets printed like this. So we have A, and then we have /n, and then we have B. And if you check the length, that turns out to be 3. So that's good. We know how to check the length of a string. If you want to actually take the string and then convert it into a list, so a list is a different data type that we will see soon. If you want to convert it into a list, you can just pass it into the list function. And now that gives you a list of all the characters, all treated separately. If you want to access individual characters in a string, you can do that as well. So today I have set to Saturday, and the way to access characters is to type the name of the variable and then type a square bracket, and inside the square bracket use an index. So the characters are indexed from 0 to n-1, where n is the length of the string. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or I think this goes up to 7. So 0 is S, today 3 is 0, 1, 2, 3, U, and then today 7 is the last character. And you can also access a part of the string by providing a start index and an end index. So for instance, we are saying 5 to 8 here. So we go from 0, 1, 2, 3, 4, 5. So that's D, 6, 7. And then the last index is actually not taken. So we do not use the last index. So we go from 5, 6, 7 and skip 8. That's just how ranges work in Python. That's how you get something out of a string. You can also check whether something is in a string. You can check whether a string contains something using the in operator. We can check day in today, that's true. We can check sun in today, that's false because today it says Saturday. So that's how you check whether a string contains a piece of text or not. Then you can join strings or concatenate them using the plus operator. So for instance, here we have a full name, Derek O'Brien, and then we have a greeting. So if you do greeting plus full name, these 2 strings will get joined. And this is a very common thing we do. We spend a lot of time working with strings in Python and combining strings to format different messages. Now, one common thing that you might miss is that if you forget to give a space, because Derek O'Brien ends with an N and then here it starts with a hello. So if you just use a plus symbol, then here you might run into issues where this becomes a single long word called hello Derek, and you probably don't want that. So that's why what you want to do is you want to have a string here in between, which is a space. Then you have the full name. And then if you want to add something at the end, you might do that as well. So you can add many strings together. Strings in Python have many built-in methods, and these methods can be used to manipulate these strings. So we've looked at certain functions. So there's something called the print function, and then we looked at functions associated with data types. So similar to functions, there are these methods which are also functions, but they are associated with specific data types, and they are accessed using the dot notation. So any methods that are associated with strings can be accessed by taking the variable name of the string or taking an actual string and then using a dot and then calling the method. So in some sense, what this does is that lower is no longer a function that is globally defined. Only certain data types have the lower method. In fact, only strings have the lower method. So on strings, you can call the lower method by calling today.lower, and this lower method automatically gets access to the string that you are calling it on. So it has access to the value of today, and it performs a certain operation, and in a lot of cases it can return a certain result. So for instance, when we do today.lower, what happens is today was Saturday with a capital S, that becomes Saturday with a lowercase s. So we looked at the lowercase method, which takes the string and converts it into lowercase. Then we have an uppercase method. So we do Saturday.upper, and that takes a string and converts it into uppercase. And then there is another function called capitalize. This takes Monday and returns this. These are pretty simple methods, but there are also some really powerful methods that we use all the time. So one is the replace method. So in the replace method, what we're going to say is we're going to take Saturday, the string, and then we're going to call replace and then give it a couple of inputs. So we want to give it the input, what do we want to replace? So let's say we want to replace Saturday, and what do we want to replace it with? So let's say we want to replace it with Wednesday, and that makes Saturday Wednesday, right? So this is something that you might do from time to time within a string. But do note that any string methods, and this is unique to strings, any string methods will always return a new string. They will not modify the original string. So for instance, even though another day has the value Wednesday and today still has the value Saturday. And this is a key thing to watch out, whether methods modify the existing object or they return a new object. And we'll see with lists how that is different. Another one is a split method. I will let you check this out. The split method is pretty useful. There is one more called the strip method. The strip method can remove spaces from the beginning and the end of a string, not from the middle. That is also pretty useful. It can remove white space characters. It can remove new line characters. So these two are pretty useful when we are reading in data from a file, and we will see that over time. Then one very useful method is the format method, and the format method is used to combine the values of other data types with strings. Let's look at an example here. So here we have a few variables. We have the cost of an ice bag, and then we have a profit margin, and then we have a number of bags. As such, they are just three variables that we have initialized, and they have different data types. And then we want to output a certain message. We want to say that if a grocery store sells ice bags at a certain rate per bag with a profit margin of a certain percent, then the total profit it makes by selling a certain number of ice bags is such and such. Let's say we want to do this for many different combinations of price, profit margin, and number of bags. What you can do is you can create this string and you can leave out gaps. So wherever you want to fill in a value later on, you can simply put in these braces, and you can see that we have created a string. And the string has a bunch of braces inside it. And now what we can do is on this string, which we have called output template, on the string, we invoke the format method. What I've done here is first I have done some calculation. So I have multiplied the cost of the ice bag, which is some commodity we are selling, with the profit margin, with the number of bags, and that gives us a total profit. Now with the total profit, we want to insert all of these numbers. So these three variables and the total profit, we want to insert it into the output template. So we say output template dot format, and then after saying dot format, we give a list of variables. So these can be variables. These can actually be some expressions. So for instance, here I'm multiplying the profit margin, which is 0.2 by 100 to convert it into a percentage, and then the number of bags and the total profit. And then what happens is when you use the format method, that gives a new string back, and that new string has the variable values inserted inside it. So now you can see it says the grocery store sells a bag at $1.25 per bag with a such and such profit margin, and by selling 500 ice bags, the total profit is $125. So this is something that we will use all the time. Do get used to the format method, just play around with it. Instead of formatting, you can also use the string concatenation operator to achieve this. But you might get issues when you're trying to concatenate or you're trying to add strings with numbers or other data types. And the way to actually solve for that is to take each of these variables which you are doing concatenation with and convert them into a string using the str function. So you see here we get an error here, but here we can use the str function. But the key idea here is that strings have methods. You can call these methods, you can give them some inputs, and often these methods return new results. So as you experiment with these notebooks, try out these string methods and then try out some other string methods as well. Just like other data types, you have the str function, which can take any data type and convert it into a string. Another minor thing is that you can actually compare strings. So here I have declared a string. So you see the single equal to here. This is an assignment operator. So I've declared a string first name with the value John. And then I can compare the first name with another string using the double equal to operator. So the comparison results false with Doe, and the comparison returns true with John. So we have the equality operator, and then we also have the not equal operator, which is in our case first name not equal to Jane, which returns true. That's it about strings. So let's move on to lists. A list in Python is what you can probably tell, it's an ordered collection of values, and lists can hold values of different data types within them. So you may be familiar with arrays or lists in other languages like C or C++. If you're not, that's fine. But if you are, then you might know that sometimes these lists can only contain a specific type of value. But in Python, there is no such requirement. Lists can contain different types of values as well. So this is how we create a list. So I'm saying fruits equals apple, banana, and cherry. That is a list. And if you check the type of fruits, you will get back the list as the type. Now here is another list. This has a bunch of different kinds of values. It has a number, it has a string, it has the none object, it has 3.14, the value of pi, it has fruits, another list as an element or a member of the list. And it has an expression which resolves to true. So that's nice, that list can contain all of these different things. And then a list can also be empty. And to create an empty list, you just open these brackets with nothing. So to create a list, you need to open a square bracket and close a square bracket. Now, just like strings, you can check how many elements there are in a list using the len function. So the fruits had 3 members, and you can also then take that and use that in string messages using the print function or using the string formatting function and so on. So the other list had 6 members, and then the other list had 0. That's how you check the length of a list. Then if you want to access an element that is present inside a list, you need to use the list indexing notation, which basically means the variable name followed by a square bracket followed by an index. So in Python, numbers are elements are indexed from 0. So now you have the 0th element, the first element, and the second element. So I like to say 0th element because that makes it easier for me to type these things out. You might call apple the first element, but if you start thinking of it or just mentally calling it the 0th element, you will make fewer mistakes while accessing specific elements from lists. So here's the 0th element, and here's the first one, and here's the second. One interesting thing about lists is that you can put in any number here, and if you put in a number that is larger than the size of the list or even equal to, because the size of the list is 3, but the only valid indices are 0, 1, and 2. So if you put in a value that is bigger, then Python will give you an index error. And you might expect that if you want to access a list and you're accessing a value that does not exist, you get an error. But if you put in a negative value, so specifically if you put in -1, then this is what you get back. You get back cherry, which seems to be the last element of the list. So lists also support negative indexing. And when you're doing negative indexing, it starts from the end. So this is -1. This is -2, and this is -3. And this is a very useful way when you don't know the length of the list, you still want to access the last element. So you can just put in -1 and get the element back. So that's something that you can try out. But again, if you go too far negative, you're going to get an error. Another thing that you can do is you can also access a whole range of values within a list. So for instance, here I have a list, and then this has 1, 2, 3, 4, 5, 6 elements. You can see here it has 6 elements, and one of the elements itself is another list. And now if I want to access the second element to the 5th element, I can simply put in 2:5, and that's going to give me a sub list of the list. So the result is also going to be a list. So let's just guess what the answer might look like. So we have the 0th element, we have the first element, and then we have the second element. So it starts at this. So you will get back none. This is the third element, 3.14. You will get back this. This is the fourth element, apple, banana, cherry, the fruits list. We should get back this as well. And then this is the 5th element. But here's the key thing: ranges in Python end one step before the last element that is given. So when you say 2 to 5, that actually means the indices 2, 3, and 4 only, not 5. And that is why you get back a list containing the 3 elements, none, 3.14, and the fruits list. You can play around with ranges. There are a few exercises that you should try out. Try setting indices to a range that is higher or lower than the size of the list, like 2 to 10 or 2 to 5 or 2 to 7. Just see what happens. Try leaving out the start index or the end index and see what happens. It works. Can you figure out what it does? Try using ranges with negative indices. So I have left a few blank code cells for you to try this out. Just accessing lists, there are a lot of different powerful ways to do it, and ranges is probably one of the easiest ways that you should get a hang of. So now we've looked at what lists are. We have looked at how to check the length of a list, how to get elements out of a list. But what you can also do is you can modify the list. So lists in Python can be modified. And the way to do it is, if you want to change the element at a particular index, you simply access that index and then use the assignment operator to put in the element. So what that does is now banana gets changed to blueberry. So that's good. Now we are modifying a list. Another way to modify a list is to add something at the end. And to add something at the end, we use the append method. So we use the append method here. Another thing that you can do is you can insert an element at a specific index. This is the 0th position, so this is going to be the first position. So just before this element, something is going to get inserted. So you can see here that banana got inserted before blueberry. And then you can remove a particular element from a list as well. So just try remove as well. And then there is another method called pop. So remove takes a value and removes that value from the list, and then pop takes an index and removes the value at that index. I'll let you try those out. I'll leave those as exercises for you. Then similar to strings, you can check whether a certain element is a part of a list or not. So if we check pineapple in fruits, here's a fruits list. So if we check pineapple in fruits, we get back false. But if we check cherry in fruits, we get back true, because cherry is in fact part of the list. Now note that you have to put in the entire element exactly to match. So if you put in just cherries, or if you just put in CHER share, that is not going to work. So the element has to match exactly, and then you will get back a true result. So that's how you check if something is part of a list. And then to combine 2 or more lists, again pretty straightforward. You simply take a list and then you say fruits, and then you use a plus symbol, and then you put in another list, and then you put in one more if you want to. You can concatenate or combine any number of lists. We have the combined list now. There are also certain methods that you can use on lists. So for instance, there is a copy method that is used to create a copy of a list. And then there is a remove method. And then there is a pop method. These are things that we have seen. So you can try out more of these methods, and I've provided a link here, and try to use these methods to answer these questions. Reversing the elements of a list is one. Adding elements from one list at the end of another list, sorting a list of strings in alphabetical order, and sorting a list of numbers in decreasing order. So just see if you can check out these references and you can do these exercises. And if you cannot, then a good place to discuss or post where you are getting stuck would be the lecture forum thread. There's a lot of activity going on there. So just post your question and somebody will answer your question. Now, similar to lists, there is another data structure called tuple. And the difference between lists and tuples is that tuples are immutable, which means they cannot be modified once they have been created. Here I'm creating a tuple, and the way to create a tuple is instead of a square bracket, you simply use a round bracket, parentheses. And they support very similar operations, like you can check the length. The length is 3. You can check an element with a positive index, with a negative index. You can check if a fruit contains an element. So the dates is a part of fruits. But what happens if you try to change an element? So if I try to set fruits 0 to avocado, that is going to give you an error. And you cannot append to a tuple, and you cannot remove elements from a tuple. Okay, so that's one of the key differences. So we use tuples when we want to make sure that a list of elements cannot get modified, and we use lists when we can allow modifications, when we want some flexibility. So that's about tuples. And then there is a little more that you can explore here about tuples, and you can convert tuples to lists and lists to tuples and back and forth. There is no difference here. And just like lists, tuples have some methods as well, but a fairly limited number of methods. And finally, I want to talk about dictionaries. A dictionary is an unordered collection of values. So there is no specific order to the values stored in a dictionary. Now, if you do not have order, how do you access these values? So what dictionaries have is that apart from values that you put into the dictionary, they also have keys. In a sense, it is a lookup table. So this is how you create a dictionary. You open a curly bracket or a brace, it's called, and then you close a brace, and between the brace, you create key value pairs. Typically, keys are strings. So you have a key here, and then that key points to a certain value. And the value can be of any data type. The key name points to the value John Doe, and the key sex points to the value male, and the key age points to the value 32, and the key married points to true. So this is a much nicer way of storing information, let's say about a person, rather than just putting all the values in a list, because then you would have to remember what the first element represents and what the second element represents and so on. But here we have encoded it into the dictionary itself. So I've created a dictionary here. And now if I do person1, you can see that all these keys and values are present in the dictionary. And then there's another way to create the dictionary using the dict function, which has more of a function invocation syntax, but it does the same thing. So here you can see that just like person1, we have created a person2 with a different name, sex, age, and married keys. But the type of each of these is a dict. So there you go. Now, when you want to access a value from a dictionary, you do it by providing the key. So you need to know what keys you want to access. If I want to access the name of person1, I use the same indexing notation, which is the square bracket, and then I simply put in the key. So here I put in the key name, and when I run it, I get back John Doe. Similarly, when you do person1 married, you get back true, and then person2 name, you are getting back Jane Judy. And if a key isn't present in the dictionary, you get a key error. Okay. Now, if you want to avoid a key error, you can use the get method. So again, from person2, if I try to get the address key, which does not exist, I can use a get method and I can provide a default value that can be returned if the dictionary does not contain that key. You can check whether a key is present in the dictionary. So this is checking keys, not values. So whether a key is present in the dictionary using the in operator. So name exists in person1, but address does not exist in person1. So that's how you get values out of a dictionary. Then next, you can also change the values associated with a key using the assignment operator. So here I'm using the assignment operator to set married for person2 from false to true. And the assignment operator can also be used to just add new key value pair. So person1 does not have an address. They have a name, sex, age, and married. But if I set person1's address to 1 Penny Lane, now you can see that the address shows up here as well. And then dictionaries have certain methods. So dictionaries provide methods to access just the keys using dictionary.keys and access just the values or access the entire key value pairs. And then there are many other methods that dictionaries provide, which you can try out. And we will use many of these in the future. Here are some experiments that you should try out with dictionaries. So what happens if you use the same key multiple times? How do you create a copy of a dictionary? How can you change the value associated with a key? Can you change it to be a dictionary itself? Can you have this kind of a hierarchical structure? And there are a couple more experiments. So do try these out. Again, I've left you some blank spaces to try these out. And then I've also linked to the Python documentation and then certain other tutorials where you can learn more about data types in Python. So with that, the last thing that we should do, since our notebook is running on an online platform, is we should import the Jovian library and then run jovian.commit with a project name. So I'm going to set my project name to variables live and this just running jovian.commit. And now that is going to ask me for an API key, which I can get from my profile. So I just copy the API key. So once I'm logged into jovian.ml, I copy the API key and paste it back here. And what that does is that takes the notebook that we were just looking at and it captures a snapshot of that notebook and then it puts it onto your Jovian ML profile. So now we can close this and then this is then now going to go away, this binder instance. But my Jupyter notebook is here for me to view whenever I need to. And I can go back and I can run it using the run button. So that's what we do. We run these notebooks on Binder, we make some changes, we bring them back on Jovian, and then we keep making changes. And that's how we start collecting different versions of the notebook. So all the updates that you make over time get recorded. So with that, we've completed our discussion of variables and data types. Let us move on to the next topic, which is branching and loops. We are going to continue working on the basics of Python. So let's get started. Where you should go is the course page 02pandas.com. We are doing lesson 2. So let's open up lesson 2. So lesson 2 page, you can open up conditional statements and loops. Once again, I'm just going to click the run button to run this on Binder. So here we go. Now we have the new notebook. I'm going to do kernel restart and clear output. And I am going to hide the toolbar and we're ready to get started. So one of the really powerful features of programming languages is branching, and branching is the ability to make decisions and execute a different set of statements based on whether a condition is true. And what does that mean? I want to show you with an example. So here, the simplest way to introduce a branch in your code is to use the if statement, and which is written like this. So you say if, and then you put a condition after the if, and then you put in a colon. So this is to indicate that there is something below it. And now you can then put in a bunch of statements, and all of these statements, you have to give them a little bit of a space. So just give them 4 characters of space before the statement. So here there are 4 characters before statement, and then we have the statement itself. Then we have another statement, and all of these statements which are indented. So these 4 characters of space before a statement are called indentation. So all of these statements that are indented belong to an if block. And these statements get executed only when this condition is true. Okay, so let's look at an example of that. So here I have a number, and this number has the value 34. And now I'm writing an if statement followed by a block of code. So here I'm saying if a number which is 34, and this is the modulus operator which returns the remainder. So the remainder when 34 is divided by 2, so which will be 0 because 34 is even. If that remainder equals 0, so this entire condition, this entire expression returns true. So since this expression is true, then these statements get executed. So the statement we are inside an if block, and the statement print the given number, which is 34, is even. And notice that we are using string formatting here. So if I execute this, you will see that these statements get executed. Very simple, but a very powerful idea, and you will be doing this a lot. This is the bread and butter of programming, really, branching and looping. Let's try another example here. Now we have 33, and then with 33 we are once again checking if this condition is true. And if this condition is true, then we are going to try and print something. But you can see here nothing gets printed because this condition does not hold true. That is basically the if statement. And what you might want though is you might want to do one thing if the condition is true, and you might want to do another thing if the condition is false. And that is where the else statement comes into picture. So what you can do is you can have a if statement, and you can have a block of code after the if statement, and then you can write else and give a colon and have another block of code. So if the condition holds true, then the first set of statements is executed. And if the condition is false, then the second set of statements is executed. Okay, so let's check it out here. So we have a number, and we say that if a number divided by 2 leaves a remainder of 0, then we say that it is odd. Otherwise we say that it is even. So here, since 34 is even, this gets printed. And then similarly, since 33 is odd, the second statement that the number is odd gets printed. Here is another example. So you can build these conditions in any way. So it does not just have to be arithmetic. Here is another example. I have a tuple, the 3 musketeers, and then I have a candidate. So what we do is we check whether a candidate is in the tuple, and that makes Python is so readable that you can just read this and understand what's going on here. So if a candidate in the 3 musketeers, then print that the candidate is a musketeer, otherwise print that the candidate is not. All right, so you can build these conditions and combine them in all sorts of complex ways, and that gives you a lot of power. Now one other statement, which is, you may or may not use this a lot, but there is an elif statement that you can use. So when you want to check not just one condition but a series of conditions, you can use the elif statement. So I'll just show you with an example what it does very quickly. So what we do is here is we say that if today is Sunday, then we print something about Sunday. Else, so else if, so elif is short for else if. So if this condition fails, then we check this condition and print something. And if that condition fails, then we check this condition. So as conditions keep failing, we keep checking the next condition. But if at any point a condition becomes true, so for instance, at today equals Wednesday, the condition becomes true, then we simply execute the code inside that block, and then we ignore all of these. All right. So that is the elif statement. Keep checking conditions until the condition is true. When the condition is true, execute the statements inside that block and then ignore the rest. Okay. And There are a few details here about elif and how it is different from simply using a bunch of chained if statements. So I will leave that for you as an exercise. So here we have tried the same thing with if elif, and then we've tried the same thing with just a bunch of if statements. So I'll let you try that out. And finally, you can use if, elif and else together. So here I have the number 49. So what we do is we try to check if it is divisible by 2, and then we print it is divisible by 2. We check if it is divisible by 3, and we print that. We check if it is divisible by 5, and we print that. If none of these conditions hold true, then we go into the else block. So you can do a chain of if, elif and else statements. Okay. And then finally, what you can also do, as I've mentioned before, is within an if statement, you can take this number and you can have a check on that number, and then you can do an AND. So you can combine two conditions. So you have a number divisible by remainder with 3 equals 0, and a number remainder with 5 equals 0. And then only if both these conditions are true, you are going to go and execute this print statement that the number is divisible by 3 and 5. Okay. So that is the if else statement. Now, one other thing is that these conditions do not necessarily have to be conditions. In fact, they can be any value, and they can be any value in Python. For instance, it can be a string, it can be a dictionary, it can be none, it can be a number. And what happens is that Python automatically, whenever you put in a value that is not a Boolean, Python automatically calls the bool function on that value. And we've discussed this the last time in the last lecture, so you can look it up there. When you call the bool function, empty values like 0 or the empty string or empty dictionary or empty list get converted to false, and all other values get converted to true. So there are a certain set of falsy values, and there are a bunch of true values. Okay. And this is pretty useful because if you want to do a certain operation only if a particular list is not empty, then you can simply say if my list, and if my list is true, then you print something, else you print something else. So this is a very simple way to just check whether something is empty or not. And then again, a very minor thing, and you can try this out, is that you can have if statements inside if statements. So here is an if block. So we are checking if a number is divisible by 2 or not. And then inside the block, we have another if statement where we check whether the number is also divisible by 3 or not. And then what you have to do is this if statement itself has to be indented, and then the block inside it will require 2 levels of indentation because it is indented from an if statement which is already indented by 4 spaces. Okay. So check this out, try this out. First read this out line by line and try to predict what will happen as you put in a number here, which path it will follow. And as you change the number, try to see if you can get all of these print statements to show up in different cases. Okay. Now, one small piece of advice here is avoid nesting statements, if statements wherever possible. So if inside if is very confusing. So the maximum you should go is maybe 1 level of nesting, and try to keep your code as simple to understand as possible. Okay. So that is the if. Those are all the variations of the if statement. And then there is also something called a shorthand if expression. This is not something that we are going to cover in the lecture, but again, this is here in the notebook. So if you're going through the notebook, you can try this out. Essentially what it offers is it offers a way to put the entire if condition statement, else statement, all of that into a single line, especially when you want to calculate a new value out of the if statement. Okay. So I will skip ahead for now. So I'm just going to save my notebook here because this is something that you should just do from time to time. Keep saving your notebooks. So here I just take my API key and paste it in here, and that uploads the notebook to Jovian. Okay. We've gotten a lot of comments about people losing their work on Binder because they left the tab open for a long time or left their computer for a while. So just keep running jovian.commit from time to time on Binder so that you do not have to deal with that problem. Okay. All right. So now we've looked at conditions. The next thing that we're going to look at is iteration. And iteration is an extension of condition or an extension of branching in a sense. So what it allows you to do is it allows you to run one statement or a set of statements multiple times. So we have something called the while loop in Python, which works like this. So you say while, and then you put in a condition, and then as long as that condition is true, so let's say you're checking the value of a variable, whether it's even or not, as long as that condition is true, the statements inside the while loop keep executing over and over again. And what you might normally do is that within one of these statements, you might change a variable, which might later cause the condition to become false. Okay. And that is when the while loop will end and we will continue with the execution of the program as normal. So let's take an example. You might be familiar with the concept of factorials. So what we will do is we will try to, the factorial of the number n is simply the product of all the numbers from 1 to n. So the factorial of 10 is 1, 2, 3, 4, 5, 6, all the way up to 10 multiplied and so on. So we will write a while loop to calculate the factorial of the number, or a factorial of the number 100. Okay. And so the way we're going to do this, we are going to create a variable called result. This is what will get back the final result of the factorial. And then we are going to create a variable called I, which is, you can call it index, or you can call it like a counter. So I has the value 1. And then we create a while loop. So we say while I is less than or equal to 100. So initially, since I is 1, this condition is going to be true. So then these statements are going to get executed. So first we do result equals result times I. So since I is 1 right now, then result will continue to remain 1. And then we do I equals I plus 1. So I plus 1 is 2. So now we change the value of the variable I to I plus 1, which is 2. So now I has the value 2. So now we come back here. The statement, the condition is executed again. This condition is currently still true. So then we multiply the result with 2. So the result becomes 2. And then I now becomes 3. Then we check the condition again. And then we multiply result by 3. So result becomes 1 times 2 times 3. And 1 into 2 into 3. And then we have I gets increased to 4. And now you get the idea, right? We keep repeating this over and over till this condition becomes false. That is, till I becomes 101. And when I becomes 101, at that point, this condition is false. So at that point, we break out of this loop. So it's called breaking out of the loop. And then we can go on executing the program with the statements that follow it. Okay. So let's run this. So you can see we ran this and it took hardly an instant, and it gave us the factorial of 100. And you can check whether this is actually the factorial if you want to. You can look it up online. But that's basically how this code works. And the real powerful thing here is that just with these 4-5 lines of code, we have been able to calculate the factorial of 100. But if you want to go from 100 to 1000 or even 100,000, all we have to do is change this. And that is what makes computers really powerful, that with a few lines of code and with their real speed of arithmetic operations, they can compute a lot of different things very quickly. So here we have, for instance, here we are trying to calculate the factorial of 1000, and I've added this special command called %time. So this %time is simply going to tell us how long it took to execute this cell. So yeah, I run this cell and I get back 1000 factorial, which is this huge number, pretty huge. And it took only a total of 2 milliseconds, which is like a thousandth of a second almost, pretty much. So that's why loops are a really powerful thing in programming, because they let you process a lot of data really quickly with a few lines of code. So now here are some exercises that you can try out with the while loop. So with the while loop, here is a pattern that I've printed out. So I've just printed out this nice pattern using just asterisk characters. So that takes a couple of while loops to print this out. So try and see if you can understand what's going on here. See if you can make sense of this code, and then use that to maybe create a couple more patterns. So here is one more pattern. This is the mirror image of that pattern. And then here is like a diamond pattern or a rhombus, putting these two together. So try and see if you can write the code for these, especially this one. It can be a little bit tricky. So if you can figure this out, then you have really gotten a good hang of loops and iteration in Python. Okay. One other thing that you might want to keep track of is that sometimes you may make a mistake while writing your code. So here I am calculating factorial, but within my while loop, I may have forgotten to increment I. Okay. So when this happens, when you forget to increment, what happens is this condition remains true forever because I is not changing. And when you run this cell, now it's just going to keep on running continuously forever, and you will not be able to execute any other code in the notebook. So this is called an infinite loop because the program is stuck in the loop forever. And the way to come out of this is to interrupt this execution or to stop this execution. And there are a couple of ways to do that. So you can go kernel interrupt, and that's going to interrupt the loop, and then you can make the change and rerun the cell. And then the other option, and by the way, here is another example. Here what I've done is I am incrementing I. So again, we are calculating factorial, and I am incrementing I, but I put in the wrong condition here. So this condition, again, I can keep on going to 1 million or 2 million, but I greater than 0 will always continue to hold true. So this goes into an infinite loop as well. So the other way to stop it is if you have the toolbar open, next to the run button, you have a stop or an interrupt button. So you can simply press the interrupt button, and that is going to stop the execution. So those are the two ways that you can break out of these infinite loops. And don't worry, you can always go back and fix these things. So write your loops, and then if you see that it's going into an infinite loop, just interrupt and fix it and rerun it. Don't be afraid to get it right the first time. Now there is a couple more things within while loops. One is that there is a special statement called break. So what you can do with a break statement is, yes, you have this condition within a while loop, and this condition when the condition becomes false, you will break out of it. But sometimes you may want to, depending on a certain condition, depending on what values you are iterating upon, you may want to decide that, okay, I want to stop the execution of the loop somewhere in between. And that is when you use the if character. That is when you use the break statement. So for instance, here we have I equals 1, result equals 1, and then while I is less than equal to 100, we multiply I with the result. So this statement result star equals I is the same as result equals result star I. Okay. And then we have an if statement here, which checks that if I reaches the value 42, then we say that magic number 42 has been reached, and we are going to stop the execution, and then we are going to break out of the loop. So this break gets executed, and then we exit the loop completely, and then we execute these statements, right? So you can see here that I at the end of the while loop has the value 42, and the result is not nearly as close to the factorial of 100 that we initially had. In fact, it will be 42 factorial exactly. So that is a break statement. And then there is another statement, that is the continue statement. So the continue statement is slightly different from break. What it does is it completely breaks out of the loop. But what the continue statement does is the continue statement. So here let's look at an example. So again, we have I equals 1, result equals 1. And then while I is less than 20, we increment I. So we go from I goes from 1 to 2. And then we check if I is even. So if I is divisible by 2, the remainder of I with 2 if it is 0. Then we print that we are skipping I, or whatever that number is. And then we have the continue statement. So what the continue statement does is that when this gets executed, anything else, all the remaining statements in the loop are skipped. So this print statement is skipped, and this result multiplication statement is skipped. Okay. So let's try it out. Let's just run this. So you can see here we started out with I equals 1, and then we had I equals 2 in the first loop. So we skipped 2 because this if statement was true. And then we did, so there was no multiplication with 2, but then we did multiply with 3. Then we skipped 4, multiplied with 5, skipped 6, multiplied with 7, and so on. And the result that we get back ultimately is the product of all the odd numbers from 1 to 20. Okay, so that's the continue statement. So break and continue are, well, they're not very often used, but they're quite useful sometimes when you are stuck in a tricky loop where you want to somehow have something come out of the loop based on a certain condition. Okay. So those are loops, and I'm just going to run jovian.commit once again, just to save my work. So those are while loops. Another important kind of loop, in fact, something that you will probably be using the most often, is the for loop. Now, just as while loop is used to iterate while a condition is true, the for loop is used to iterate or loop over a sequence. For example, if you want to perform an operation for every element of a list or a tuple or a dictionary or every character in a string, that is when you use a for loop. And they have a very nice, simple, intuitive syntax. So what we say is for value in sequence, for value in sequence. So we have a sequence, and then we take, using the in operator, we take one by one each value from the sequence once we put it into this for statement, and then we can execute a bunch of statements repeatedly, a bunch of statements for each value from that sequence. Okay, and it'll become clear with an example. So here we have a list, and the list has Monday, Tuesday, Wednesday, Thursday, Friday. So it has these elements. These are all strings, and we say for day in days. So for day in days. So what happens is that every time for every element, Monday gets put into the variable day, and then you can print day. Then Tuesday gets put into the variable day, and then the statement gets executed. Then Wednesday gets put into the variable day, and then the statement gets executed, and so on. Okay. And you can see here, as you might expect, Monday, Tuesday, Wednesday, Thursday, Friday gets printed. And here are a couple more ways you can try this out. So we can actually loop over a string, and we can get back characters from the string. So for every character in the string, we print out the character. So here Monday becomes Monday. We can loop over a tuple or a list. This is more of a list than a tuple. So here we are going to loop over the list, apple, banana, guava, and then we are going to print it out saying here's a fruit. So here's a fruit, apple, banana, and guava. We can loop over a dictionary as well, which is again something that we will do a lot over the course of the next few lectures. So here we have a dictionary, and then we are going to use the name John Doe, sex male, age 32, married. And then when we loop over a dictionary, what we get back is just the keys. We do not get back actual values from the dictionary. So if you want to access the value, so here's what we do, right? So for key in person, and then we are going to print out the key. So the key is going to have the values name, sex, age, etc. And then if you want to get the actual value stored against that key, then you simply pass the key into the dictionary using the indexing operation, right? So the person key, when key is name, will give you the name, and so on. So let's run this. And so you can see here the key is name and the value is John Doe. When the key is sex, the value is male. The key is age, the value is 32. The key is married, the value is true. And that's all it is. If you do want to iterate over actual values, then you can just call the .values method on a dictionary. So person.values will now give you a list of values, and now you see we have just the values. Or if you want to get back both keys and values, then there is also something called .items, and then .items is going to give you both the key and the value. All right. So that's our for loop. With the for loop, we can iterate over a bunch of different containers, but sometimes you might want to iterate over simply a bunch of numbers, right? You might want to run something, you might want to run a loop from, let's say, numbers from 0 to 100 and then perform certain operations using those numbers. And that is where you can use the range operator, the range function. So here are a few examples. So if you just say for I in range 7, so when you say range 7, or any range n, that creates a sequence of numbers from 0 to n-1. So range 7 creates a sequence of numbers 0 to 6. You can see that here, if I print it out, that's going to create the range of numbers from 0 to 6. You can also specify a start index and an end index. So what you can do is you can say range of 3 to 10. So what that does is that starts with 3 and then goes all the way up to 10, but not including 10. So that becomes 3, 4, 5, 6, 7, 8, 9. So you can see 3 to 9 get printed here. And finally, you can also give a step. So here we start with 3 and we go all the way not equal to or greater than 14. So we can go all the way up to 13, but we take increments of 4. So we have 3 and then we have 7 and then we have 11, and then 11 plus 4 becomes 15, which is greater than or equal to our end index. So that is not printed, right? So this is pretty useful. A range is pretty useful when you also need access to, let's say you want to go over a list, but you also want to know within the for loop which element in the list you're accessing, right? The index of the element. So that is when a range is useful. That let's say if you're going over a list, here you have the list of days. What you can do is you can create a range with the length of the list, And then you have the index I that goes from 0 to the length of the list -1. So 0, 1, 2, 3, 4 are going to be the indexes. So you can then print that the value at a position 0 is Monday and the value at the position 1 is Tuesday, because we are formatting the string and we are putting in I, the value of the index, and then we are getting the element with that index out of the list. All right. So that is the range function. And similar to while loops, for loops also support break and continue statements. So anywhere within a for loop, if you feel like, okay, you should probably end this loop right now because maybe you found what you need of the loop. And similarly, here is the continue statement. So here you can see that beyond Wednesday, we do not process Thursday and Friday. But in the same way, if we were printing things out and we were simply doing a continue, then what happens is that when we reach Wednesday, this statement becomes true. So we print I don't work on Wednesdays, and then we say continue. So this print statement below gets ignored. All right. So here with continue instead of break, we say today is Monday, today is Tuesday. I don't work on Wednesday, but we still process Thursday and Friday. So those are the break and continue statements. And finally, this is not very common, but sometimes you may want to just create an empty loop, nothing inside a loop. So you just say for day in weekdays and then you say pass. So if you say pass, nothing happens. You simply go over all the elements, but nothing really happens. Now that's it about loops that we'll cover right now. You can nest for and while loops inside each other. So I leave that as an exercise for you to try out. You can nest for loops inside while loops. You can have if conditions inside for loops, inside while loops, and so on. But again, even just as with the conditions, if you nest too many loops, it can become difficult to read and understand. So you may not want to do more than 2 levels of nesting within a loop. Okay, that's all the discussion that we have about variables, data types, and branching and loops. And then I'm going to go back to lesson 2. And now we're going to look at a very interesting topic, something that is at the very core of programming. And that is the idea of functions and scope. Okay, so open up the notebook. Let me just click run on Binder. Wait for that to get started. All right, so let's just go full screen and let us hide the toolbar. So I'm just going to do kernel restart and clear output. Okay. So we've already seen some functions, right? We've seen the print function. We've seen the len function. We've seen the data types related functions, which can convert data types from one type to another. And then we've seen methods as well. But just to recap, a function is basically a reusable set of instructions. There is some logic which you think can be used again and again on different data, or needs to be, you do not want to write the same set of code each time you want to do that, perform that operation. So you convert it into a function, and a function takes one or more inputs, performs certain operations on those inputs, and then often returns an output as well. Okay. And Python provides many built-in functions like print, len, and so on, but you can also define your own functions. So this is a print function, pretty straightforward. We've seen this, but here are the inputs. Today is, and then today, that is an input as well, which becomes Saturday. And then the print function simply performs an operation which is displaying the input on the screen. It does not return anything. Okay. Python allows us to define our own functions as well. So what we can do is we can define a function, let's say called say hello. And now the say hello function can print hello there, and the say hello function will print how are you. So it's a pretty straightforward function. The way to do it is def space function name, and then you have these parentheses or these round brackets. Inside it you can put some inputs, but we're not doing that just yet. And don't forget this colon character. And then the body of the function needs to be indented by 4 spaces, just like the body of a for loop, or just like the body of a while loop or an if statement. Okay. So that's a function has been defined. But when you define a function, the statements inside the body are not actually executed. And that's why you do not see anything printed here. So once a function is defined, you need to invoke it, or you need to call it. So that's the same thing. You will hear invocation, you will hear function call, you will hear function execution. It all means the same thing. So the way to invoke a function is to call the function name. So just type the function name and then pass these brackets. So an open bracket and close bracket, that is used to invoke the function. And you can provide any inputs here as well, but our function does not take any inputs, so we're not going to do that. and then we just run say hello, and that is going to print out hello there and how are you. Let's try it again. So if I run it again, it once again prints hello there and how are you. And that is really the key benefit, that now I only had to write it once and now I can use it with a single line. I do not need to type out the code again. Okay. But just functions which do not take any inputs are not very interesting. So functions can also accept one or more values as inputs, and sometimes you will see them referred to as arguments or parameters. And there are some technical differences, but ultimately these words are used quite interchangeably. And so we'll go with the word arguments because that's the most common thing that you see used. So arguments to a function help us write flexible functions which can perform the same operation but on different values. Okay. So for instance, we'll create a very simple function and then we'll see this function that is already there. So here we have a function say hello, and we will let it accept a name, and then we will print hello, and we will do a string formatting, and we will pass in the name. Okay. So if we just say hello to John, that says hello John, and say hello to Jane, and that says hello Jane. So just taking that idea forward, here is an example of a function. It's called filter even. What it takes is that it takes a list of numbers, a number list as an input, and then it does certain things, and then it returns an output. Okay. So there's an input going on here, and then there's some operations being performed here, and then there is a return statement. So I'll tell you what this operation, what it does, and I'll not go over the code exactly, but what it does is it takes the list of numbers and it only keeps the numbers, it only retains the numbers that are even. All right. So the result list will contain simply the numbers out of list which are divisible by 2. And the way it does it is it loops over the number list and it checks whether that number is divisible by 2 or not. And if the number is divisible, it appends it to result list and then returns the result list. Okay. So let's try it out. So here, and by the way, a function returns, to return a value, you simply say return and then pass the variable or the value that you want to return. And what you can do now is we can invoke filter even with a list of values, and then we can take this output of filter even and put it, so use an assignment operator to assign the output of filter even to the variable even list. All right. So we have 1, 2, 3, 4, 5, 6, 7, and then we have the even list. So you can check that now the even list only contains 2, 4, and 6. Okay. And now you can take the same filter even function and then you can run it with a different array. Let's say 1, 3, 5, 7, 9. And this time when we run it, we get back the empty array or the empty list. I'm sorry. Okay. So those are functions, and then now we have functions with return values. So the next thing we want to look at is how to write great functions in Python, because as a programmer, you will be and you should be spending most of your time writing and using functions. The more functions you write, the better you get at programming, because you then learn to structure what you need to do into small functions that you can reuse in different ways. Okay. And we are going to explore how to write a great function and using many features that Python offers. And we'll do this by solving a problem. So let's see. So here is the problem that we'll try and solve. So Radha is planning to buy a house that costs $1.26 million. So $1,260,000. And when you buy a house that's so expensive, you have to probably get a loan. So she's considering two options to finance her purchase. So she has one option, which is to make an immediate down payment of 300,000. So she just pays 300,000 right now and then take a loan, an 8-year loan with an interest rate of 10%. So a loan has a duration. The duration is 8 years. You have to repay it in 8 years. And there is a certain interest that you pay. So there's a 10% per annum interest rate. So I should probably just put in per annum here. Okay. So there is a 10% per annum interest rate. And then there is a 10-year loan, which has an interest rate of 8% per annum. Okay. So she can either take out an 8-year loan for just the remaining amount if she pays 300,000 right now, or she can take out a 10-year loan with an interest rate of 8% for the entire amount. Now, both of these loans have to be paid back in equal monthly installments, also known as EMIs. So now what we want to figure out is which of these two loans is going to have a lower equal monthly installment. Okay, and this is the problem we'll solve, and then we'll build this function step by step. So we'll also see how to build a good function, and we'll use certain features of Python to make it very flexible and powerful. Okay, so the simplest thing that we can do is, since we have to compare EMIs, we need to calculate these EMIs or monthly installments for both of these loans. So it'll be helpful to define a function so that we do not have to type out the same logic for each of these loans. All right, so we're going to define a function called loan EMI. And to start with, we're going to simplify it a lot. We're just going to say that, okay, you just give us the amount, and we'll assume that there is no down payment, there is no interest, and the loan has to be paid back in exactly 1 year in monthly installments. Okay, so we simply take the amount and then we divide it by 12, and that gives us the EMI, and then we print out the EMI. Okay, using the print statement. So our loan EMI function just takes one input. So here we call loan EMI with 1.26 million as the input. So you can write it like this: 1,260,000, or you can also just say 1.26, which makes us 1.26 multiplied by 10 to the power of 6. So that is 1.26 million. Okay, so if you take out the entire amount you want to repay in 12 months, then this is the amount that you need to pay per month. Pretty simple, straightforward, that's fine. So now let's add a second argument. So apart from the amount, let us also include the duration of the loan in months. So after what time are you going to completely repay the loan? So you have the amount, and then you have the duration in months. So we put in the duration here, and all we need to do is divide the amount by the duration. And once again, we're just going to return the EMI. Okay, so we've just extended our function a little bit, and step by step, we're going to just make it better. Now, one thing I want to note here before we actually use this function is that you will see that I have actually created a variable called EMI here. Now, where does this variable live? Because if you try to access this variable, let's say I try to access EMI, it says the EMI variable is not defined. And it's not, if I call the function, it will become defined. Let's say if I just call loan EMI with 1.26 E6 and with a duration of 10 years. So that is 10 times 12. So we need the duration in months. So the function has been executed, but even now the EMI variable is not accessible. Not only the EMI variable, but even the amount and the duration. Okay, so even if you try to access these, they are not accessible. And that is because these are all local variables within the function, right? So a function, when you define a function, within the function, there is a scope, and all these variables which are used inside the function are only available within the function, and they are called local variables. So scope is basically the rules that define where a certain variable is visible. So if you have a variable that was defined outside in a separate code cell, that is a global variable. You can access it anywhere in your code. And then if you have a variable that is defined within a function, that is a local variable. Okay. And that's a very useful thing to have, because now you can define, let's say 5, 10, 15, 20, 100 functions. In each of these functions, you can use the same variable names without worrying about what you do with the variable in one function inside a function, affecting the value inside another function. So each of these will get initialized from scratch inside the function. So that's just a little note on scope. Okay. So now we can compare a 8-year loan with a 10-year loan. For the 8-year loan, we pass in 8 into 12, those many months. And for the 10-year loan, we pass in 120 months. We still are not considering the down payment. So you can see that the EMI obviously for the 10-year loan will be smaller than that for the 8-year loan, as you might expect. Okay. And now this is great. We can see visually that these values are different, but it would be nice to compare them as numbers. And maybe we want to calculate the difference and so on. And that is where we can actually use a return value. Let's modify our loan EMI function now. And this time what we are going to do is we're going to return the value of the EMI. So we're going to say EMI is amount divided by duration, and then return the EMI as a value, as an output. Now when we call loan EMI on 8 years, we can actually take the output and then put it into an EMI1 variable. And then we can then go for EMI2 and take the value of the 10-year loan and put it into EMI2. So now we get an EMI1, EMI2, and we can now take a difference of these two. and we can check, okay, there's a difference of $2,000 between the two EMIs. Again, right now we are not considering down payment or interest, but it's a good thing to see how things are evolving. Okay, so next up, let us add the down payment, the immediate down payment, the amount that you're going to pay right now that needs to be deducted, and the rest of the amount is what you need to take the loan for. Now, since the first loan has a down payment but the second one does not, what we can do is we can make this an optional argument with a default value of 0. So now we still have the amount, we have the duration, but we have the down payment, and the down payment has a value of 0. So now the loan amount becomes amount minus down payment. And now the EMI becomes the loan amount divided by the duration, and then we return the EMI. So here when we have an optional argument, we can invoke it just as a normal argument. So here we say we pass in the loan amount, we pass in the duration, and then we pass in the down payment. That's the first loan, the 8-year loan with a down payment of $300,000. And now we get back $10,000. We get back $10,000 EMI. But on the other hand, here what we have is we've just passed in the loan amount and we just passed in the amount and duration, and we've not passed in a third argument. So when we do not pass it in, Python takes and converts this. Python simply uses a default value, down payment equals 0. So the loan amount simply is the whole amount, and hence you get back the EMI for the second loan. Okay, so optional arguments, very useful to have, makes your functions very flexible and easy to use. Okay, so next, now let's add the interest into the calculation, and this is the part you may have been wondering, how are we going to calculate interest? How are we going to introduce that? And we're just going to use a formula here, and it's not a very difficult formula to derive. You have a little bit of math like arithmetic progressions and such, but I'm not going to go into the derivation of this formula. I have linked to a video if you're really interested in understanding how it works. But the idea here is to get the equal monthly installment, we take the loan amount, which is also called the principal, and then we multiply it with this expression. So we multiply it with the rate, and this rate needs to be the rate of interest per month. So note that the rates that we are given are in per annum. We multiply it with 1 plus r, so that's 1 plus the rate, raised to the number of months, right? The number of periods that we want to talk about. And then we divide the whole thing by 1 plus r to the power n minus 1. Okay. Again, it's just a mathematical formula, and we simply need to convert that into Python code. So let's do that. So now once again, we are going to introduce, we have the amount, we have the duration, we have the rate, and then we have the down payment. Now one thing to notice here is that all the required arguments in the function, the arguments that have to be specified, have to come before the optional arguments. Because what happens is, otherwise if you invoke loan EMI with 3 arguments, Python may get confused whether you're trying to refer to the down payment or you're trying to refer to the rate if down payment is before rate. So remember to keep all of your optional arguments at the end of the function definition. So once again, we take the loan amount, that is the amount minus the down payment. Then we have the EMI, which is the loan amount multiplied by the rate multiplied by 1 plus rate raised to the power of duration. And that's why we took the duration in months. And remember, the rate has to be monthly as well. And then we divide the whole thing by 1 plus rate raised to the power duration minus 1. All right. So that's our loan EMI function. And we are getting there. So now we have the down payment, now we have the EMI, now we have the rate of interest, and now we have the duration included as well. So now when we talk about the 8-year loan, we pass in the duration as 8 multiplied by 12. And then we pass in the rate. So the rate was 10% per annum, which is 0.1 and 0.1. So the monthly rate becomes 0.1 divided by 12. So that's what we've put in here. And this was the down payment. And that gives us back what the EMI looks like, around $1,456.7, $14,000 per month. And then similarly for the second option, we simply put in the amount and then the duration and the rate, no down payment, and then we get back the EMI value. Okay. So now this is good. And now we have already answered the question. So we can see that option 1 has the lower EMI. So that's good. Radha can now decide what to do. But if you look at this function call, it's not looking very pretty. It's not easy to tell what are all these numbers that you're putting in here. In fact, it would be really easy to make a mistake here. I could very easily, if I do not remember things correctly, I could just put in this here, and then that would still give me a result, but that would be a completely false result, right? This is completely wrong. So the way to avoid that is to use something called named arguments. Okay. So while invoking a function with many arguments, it can get confusing and there can be human errors. So what you can do is you can specify the name of the argument before the actual value that you pass in. So you can say loan EMI, and then I have written out each argument on a separate line, and you can do that. You can split the function invocation into separate lines, but you don't have to. You can write it all on the same line as well, as I've done for the second case. But the key idea here is you can type the name of the argument, then put in an equal to, and then put the value in. So this can be a value, this can be a variable, this can be an expression. Like here, this is an expression, 8 multiplied by 12. Here is the rate, and then here is the down payment. Okay. So that looks much nicer. Now and by the way, when you do that, you can actually change the order of arguments as well, because you're specifying the name. So you can actually put duration before, you can put duration before the amount and so on. So that's the EMI one. So that's about one, you get the same result, no change, even though I changed the order of the arguments. Then we have EMI 2. This is for the loan without the down payment, the 10-year loan, 8% rate of interest. And once again, we get back the same result. Okay. So this is fine. This is good. But if you see this, I don't like this whole 10 characters of 10 digits after the decimal, because normally you're going to, pay back whole dollars. So what we might want to do is we might want to round this up to full dollars. In just a second. Yeah. So we might want to round this up to full dollars. And what you can do is you can maybe write a function. You can write a function called round up. Okay. And that takes a number X, let's say, and then try to figure out what you can do here. So try to figure out what you can do here, round it up and return the result. And you can use this function inside the loan EMI function. So functions within functions, using functions within functions is a very powerful technique. You can try this out and it'll be a good exercise. But since this is such a common thing, rounding numbers up and down, Python provides a built-in function for it. Except that this built-in function is part of the Python standard library. So because there are a lot of, Python is a general purpose language that is applied to many different use cases in scientific computing, in data analysis, in software development. So it doesn't make sense to just put all these functions into the global namespace, because that is going to just put in tens of thousands of function names into our global namespace. And every time you try to declare a variable, it might collide with a function, or your known function names might collide with functions. So what Python does is it puts them into modules, right? So modules are nothing but files containing Python code. So they can contain variables. So these are files with a .py extension, and then they can contain variables, functions, classes. And what they do is they give you a way of organizing large Python projects into files and folders. And the key benefit that modules offer is namespaces. That is, when you want to use something from a module, and we'll see an example very quickly, you need to first import the module, and then all the methods, all the functions, everything inside a module will have to be accessed using the name of the module. So that makes sure that your global namespace that you're working with does not get affected. And that allows people, like if you have 20 people or 100 people working on a project, everybody can write their own modules and they can use the same variable names, they can use the same function names, and that will not cause problems when you want to use those modules together. Okay. So here's and by the way, you can write your own modules, but we are going to use some built-in modules from the Python standard library. Okay. So I'm going to import the math module that contains a lot of math related operations. And inside the math module, there is a function called ceil, C-E-I-L, which stands for ceiling, which basically takes a number and then rounds it up. So if I want to know what the ceiling function does, I can simply call help on ceiling. And here it says the ceiling of x as an integral is what it returns. It takes a single value x, and it is the smallest integer that is greater than or equal to x. So that's exactly what we want. So now to invoke this function, we say math.ceil, and that rounds up 1.2 to 2. Okay, so that's great. So now let's update our loan EMI function to, it is the same function as before: amount, duration, rate, down payment. Get the loan amount minus down payment, calculate the EMI using the formula, and then call math.ceil on EMI and then store the result back into EMI. So this is just going to do that rounding up. And now if we calculate the EMI, you can see that 14568 is the EMI for the first option and 1515288 for the second option. So we can compare these EMIs or equal monthly installments now, and then we can print a nice message which Radha can view. So you can imagine you're building this system where people can put in a bunch of loan options, and then they get back whichever is the best or whichever has the lowest EMI or whatever they want to optimize for. And yeah, and that's it. So that's one way of just using functions, and we've built this function step by step, and we've made it better over time to answer this problem. Okay, but apart from just answering this problem, what we have achieved here is actually we've created a fairly generic function that can be used to solve many other similar problems. And now we do not have to think of that entire logic. Like, we do not need to remember the formula. We do not need to figure out how to round things up and so on. So let's try a couple more problems and let's see how easily we can solve them using these functions. So here, Sean is currently paying back a home loan for a house he bought a few years ago. So Sean has a loan of $800,000. The loan has a duration. The duration was a 6-year duration, and the loan has a down payment of 25% of the cost. So which is 200,000, right? So there's a down payment of 200,000 on an $800,000 loan. Sorry, on an $800,000 house. So the rest of the amount is on a 6-year loan with an interest rate of 7% per annum. Okay. Now that's one loan that Sean has. Another option is another thing that Sean is doing is Sean is now buying a car worth $60,000, and he is going to finance this car using a 1-year loan with an interest rate of 12% per annum. Okay. And both loans are to be paid back in EMIs. So what is the total monthly payment that Sean has to make? Okay. Looks a little bit complicated, but if we break it down, there are just 2 loans going on here. So here is the first loan. Cost of house is such and such. The 6 years is the duration. 7% is the rate of interest, and 25% of 800,000 is the down payment. We simply put it into the loan EMI function, and we get back the EMI of the house as $10,230. Here is the second loan. So we have a $60,000 loan. The duration of the loan is 12 months. So 1 times 12. And the rate of the loan is 12% per annum. So we need to divide it by 12 to get the monthly rate. And then we put it into loan EMI. And that's it. That we get back the EMI for the car is $5,000 per month. And now we can display the total EMI that Sean makes a total monthly payment of the EMI of the house plus the EMI of the car towards loan repayments. Okay. So yeah, that's great. We've solved another problem using just these 1, 2, 3, 4, 5. This is technically just one line of code split across multiple lines. So 5 lines of code for the first loan and 4 or 5 lines of code for the second loan, and the problem is solved. Okay, let's try one more. This one is a little more interesting. So here what we have is, if you borrow $100,000 and you are on a 10-year loan and you have a rate of interest of 9% per annum. So what is the total amount that you end up paying as the interest? So over and above the principal, the $100,000, what is the additional amount that you end up paying? So there's one simple way to do this. And what we can do is we can assume that there are 2 loans, one with interest and one without interest. Okay. So here's the loan with interest. It has the value amount of 100,000. It has a duration of 10 years and it has a rate of interest 9% per annum. So that gives us 1267 is the EMI with interest. Okay. Now let's suppose that there was no interest on this. So what we can do is we can simply get the EMI for the loan without interest. And then if we subtract the 2 EMIs, we get to know how much interest we are paying per month. And then we simply take that over the entire duration. So that gives us the total interest, right? So that's one way of solving it. There are other ways too. So let's put in the amount 100,000. Let's put in the duration and let us put in the rate of interest as 0. Oops, but something seems to have gone wrong here. And let's see what went wrong. Now this will happen to you a lot before you get better. And even after 12 years of doing Python, I still get exceptions all the time. So don't worry if something goes wrong. Just where you want to start is look at the last line. So it seems like this is a 0 division error. So what happens is whenever you try something that causes something to break while the code is executing, Python throws an exception. By throws, what it means is wherever the error occurred, it is going to stop the execution of the program there. And then it is going to just print out this error message for you. So it seems like there was a 0 division error. We were trying to divide divide by 0. And float division is simply the normal single division. So we are trying to divide by 0. Where were we trying to divide by 0? That is where you now go up and see that, okay, within the loan EMI function, if you check the third line, this is where this arrow points. So in this formula, it seems like we are dividing by 0. And now you can probably guess, because the rate is 0, 1 plus rate becomes 0. And because 1 plus rate becomes 0, 1 plus rate becomes 1. So 1 plus rate to the power of duration becomes 1. And 1 minus 1 becomes 0. So this entire denominator is now 0. And that's a problem, because now dividing by 0 is not defined. And so the loan EMI returns an error. And that is why the EMI without interest, the code execution stops at this point and nothing gets printed. Okay. What do we do? So when an exception is thrown, when an exception is thrown by Python, you have a chance to actually handle that exception. And an exception, the way to handle it is using a try statement. Okay, so here's a small example. So what you do is you say try whenever you're writing some code which you think might cause certain errors. So you say try, and then here I'm going to print a statement saying computing the result, and then I'm going to divide 5 by 0. Bad idea. It's going to break here, and then I'm going to just say computation was completed successfully. So now, since I know that this might break, because maybe 0 came in as a function argument or something like in the previous function. So when I know that this is going to break, I can put in an except statement and put in the type of error that I might expect. So the except statement, and then the type of error is a 0 division error. So here what it is saying, that if you get a 0 division error while executing this code, then do this. So what we do is we print that we failed to compute the result because you were trying to divide by 0. And then we set the result to none. And then we simply print the result out. Okay. So you can see here, it says now computing the result. It tries to compute the result and it blows up. Now the print statement, this one does not get executed because we've broken out of the execution, but the except handles the error, and then these two statements get executed. So we say that you failed to compute the result, and result has the value none. This, on the other hand, if I were doing 5 divided by 2, so now this runs normally. So we never come into this error case, and we simply print out that the computation was completed successfully and the result has the value 2.5. Okay. And this is what you can do. You can actually have multiple except statements if you know that there can be multiple types of errors or exceptions that can be thrown. And Python has a lot of different exceptions. So you can actually check out, I've pointed to a link here. You can learn about more exceptions in Python. But what we want to do is we want to just take the loan EMI and add the try except inside it. Okay. So what we want to do is we want to try to calculate the EMI for the loan using the formula that we had. But if that returns an error, especially if it leads to a 0 division error, then we can say that if the 0 division error will occur only when the rate is 0. And when the rate is 0, you can simply divide the loan amount by the duration. So then we simply divide the loan amount by the duration. And that handles the error for us. Then we again round it up and then we return it. Okay, so that's great. So now we can use this updated loan EMI function. Once again, the question was you borrowed $100,000 using a 10-year loan with a rate of interest of 9%. What is the total amount you end up paying? So we calculate the EMI with interest, and then we calculate the EMI without interest. And this time it works even with the rate of 0. And then we can see that, okay, there's a difference, a significant difference with and without the EMI. So we do the EMI with interest minus the EMI without interest. And then we multiply it with the duration of the loan, which is about 10 years, right? So 10 times 12, those many months. So that gives us the total interest that is paid. And now we can display that the total interest paid is 51,960. Okay. And that's a good thing to know whenever you're taking a loan. What is the total interest you're going to end up paying? And are you okay with that versus just paying it? All right. So one last thing now, we can also add some documentation within our function using what is called a doc string. So this is what we saw the help method that we used with the seal math.seal. Okay. Now, how do you, if you want to add explanations within your own functions, and you should do that, the way to do that is to include a string as the first statement within a function. So here I'm using a multi-line string. So here I'm going to say that it calculates the equal monthly installment for a loan. So that is a description of the function. And by the way, you can just write that, and that should be good enough too for a lot of things. So you do not need this necessarily. But anyway, I'm going to use this too. I put in one line about the function, then I am just giving a space just to make it a little clearer. And then I'm saying, I'm going to just describe the arguments as well, that the amount is the total amount to be spent. So here I might want to specify that do not this should be the loan amount plus down payment that you're putting in. Then the duration is simply the duration of the loan, but in months. So that's an important detail to give. And then the rate is the rate of interest, but it's monthly. And then finally, the down payment is an optional argument. It is an optional initial payment deducted from the overall amount. Okay. So this is how you, this is how you document document a function. That is, explain what it does for the people who are going to use this function. And the rest of the body of the function is the same, right? So the rest of the things just go in the body. Now, when you have the documentation, you can simply call the help function, and you can see that the same documentation gets printed. This is very useful. It will be useful for you. It will be useful for others using your function. It will be useful for people reading your notebook as well. So whenever possible, write documentation for your functions. Okay. And now we can just save and upload our notebook. So again, since this is running on Binder, I don't want to lose my work. So I'll just grab my API key here and put it in. And as you keep committing notebooks to your profile, they will get added up here. So you can see here, I have a bunch of these notebooks, and you can always come back and run any of these. And then if you commit again, then they will get updated. So each of these notebooks, you can see how many versions they have and so on. And you can also share these notebook links online with your friends if you want to just say give a quick tutorial or answer a question. Specifically, even on the forum, if you want to answer a question, and you can quickly create a notebook to do it. So you just do new notebook, create a new notebook, run it on Binder, type out the solution, and then commit it back. So once you get a notebook on Jovian, you can commit it back, and then you can simply share the result on the forum. Another thing to do is, if you're getting stuck at some point, then just commit your notebook and take the notebook link and post that on the forum saying that this is what I've tried and this is how I failed. Unless you describe what you have tried, it's very hard for people to help you out. Generic questions like I'm not able to solve this problem is not very helpful, because people will not be able to help you. So the best way to get help is to offer as much description about what you've tried. And the best way to do that is to share the actual notebook that you have been using. Maybe just the piece of code that you are working with. Okay. So that's about functions, and there's a lot more to functions. So just a quick review of what we've covered, and I'll talk about an exercise for you. So we've talked about creating and using functions, and we've talked about creating functions with one or more arguments. And we've talked about local variables in scope and returning values using return, using default arguments, using named arguments while invoking a function, importing modules and using the library functions, reusing and improving functions to handle new use cases. So what we saw was we kept improving the loan EMI function over time. And this is something that you should do a lot, keep improving your functions. And we handled exceptions using try except. And then finally, we documented functions using docstring. So that's a lot of ground that we've covered in just 45 minutes. So I hope you've been able to follow. And if not, you have this notebook. So experiment with the notebook. So what you should be doing now, after the lecture, you should be going File, New Notebook, Python 3. Take this notebook, put it on one half of the screen. Take this other notebook, the existing notebook, and put it on the other half of the screen. Okay. And now what you should be doing is you should be actually typing out all of these things by yourself. So for instance, the loan EMI function, instead of just looking at the function and trying to understand it, you should be defining, you should be saying def loan EMI. And I'm just going to take the amount right now and return amount divided by 12. And then just try it out. Just try to break things. Just say, okay, what happens if I pass in loan EMI? I take a loan of $100. Okay, that seems to be the EMI. Now here you might get certain ideas. What if I pass in 2 arguments? What if I call it without any arguments? If you call it without any arguments, it says, oops, it's going to tell you that the loan EMI has one positional argument amount which you have not passed. You can try calling it with multiple arguments. That's going to give an error. So all of these questions that you might have, the more curious you are, the more you break things, the more you learn. And the best way to do that is to just type out the code yourself, because as you're typing, you will wonder, what can I change here? What can I break here? And the more you explore, the more you learn about Python, the better a programmer you will become. Okay. All right. So now we have an exercise for you. This is not an assignment or anything. This is just for you to understand. So here you're planning a leisure trip and you need to decide which city do you want to visit. So you've shortlisted 4 cities and you've identified what is the return flight cost and what is the hotel cost per day and what is the weekly car rental. Cars have to be rented for full weeks. So even if you want to use a car for 2 days, you still have to pay for the week, and hotels are rented per day or per night. And then you have the return flight, which is just a one-time cost. Okay. So using this data, and this is a real life example of, again, some analysis that you might have to do in real life. So using this data, if you're planning a 1 week long trip, which city should you visit to spend the least amount of money? Okay, so that's one question you can answer. And how does that answer change if you change the duration of the trip from 1 week to 4 days or maybe 10 days or 2 weeks? So it's a good thing to explore all these things. If your total budget is $1,000, then which city should you visit to maximize the duration of your trip? Or maybe you actually do not have a lot of time, but you'd have a good budget. So which city should you visit if you want to minimize the duration of your trip? So these things are something that you can figure out. And then you can change the budget, try $600, try $2,000, try $1,500, and all of these things. And to do this, it will be very useful for you to define a function like cost of trip, which will take in all the relevant inputs like the flight cost, hotel rate, car rental rate, and duration. And it will calculate the duration of the trip. All right. And calculate the cost of the trip. And then you can use that to answer all of these questions or any other questions that you may have. So do try this out. This is going to be a good exercise on functions. And what we will do next time is we will continue working on functions, but we will also see how to work with files. So we will process some files and then we will perform certain data analysis and certain operations from data read from these files. What should you do next? Try out the notebooks yourself. As I said, open up side by side and then type out the code. Start working on the assignment. So assignment 1, once again, just to repeat, you go on the lecture page 0topandas.com, click open here on assignment 1 and run the notebook, make some changes, commit it back to Jovian, take the Jovian link and submit it here. So we'll take your last submission and evaluate it, and based on that, we'll give you a pass or fail grade, and that will be done. Another very important thing to really learn things well is to ask and answer questions on the forum. So I would suggest make it a point to answer questions on the lecture forum thread, which you can access from here. So here's a discussion forum thread, or in general from the course page, you can just find the course community discussion forum. So you can click through to that link as well. And you can find all the discussions that are happening, lecture 2, assignment 1, lecture 1, and so on. And just try and at least ask 1 question per week and answer maybe 2 or 3 questions per week. The more you answer, the better your understanding becomes as well. So please do that. A lot of people are helping each other. So I just want to give a shout out to everybody who has been helping out. Talk to people on the forum, ask questions, try your own ideas, try to break the code. The more time you spend on this, the better you will get at it. So I will see you on the forums. We're looking at numerical computing with NumPy. So you can click the open link here and that will open up the lesson page. And on the lesson, you will be able to watch the video now and later. And you also have the option to watch the same video in Hindi. Now, if you have questions during this lecture, you can ask these questions on the discussion forum. So there is a link to the discussion forum. So this is the discussion forum and you can log into it with the same ID that you used to enroll for the course. And you can just ask questions here. You will see a big blue reply button here on the bottom. So just click the reply button and ask a question. So now I'm going to open up the first notebook. So the topic is numerical computing with NumPy, and this is a notebook you can open up. So here now I'm going to run the notebook. If you're joining us live, you need not run the notebook right now. Please don't, because there are thousands of us. So that may slow things down a little bit for everyone. So I'm just going to run it right now and you can run it later after the lecture. So we click run and then we click run on Binder to take this Jupyter notebook, which you're looking at here, and then run it online. So when you click the run button, it may take a couple of minutes to start up. This is because this is a free online service and it is provisioning some servers for you. Okay, so while it gets started, let us just go through some of the material. So this course is called Data Analysis with Python, and the data in data analysis typically refers to some numerical data. So things like stock prices, sales figures, sensor measurements, weather data, sports scores, database tables, and things like that. Now the NumPy library provides specialized data structures and functions and other tools for numerical computing in Python, that is working with numerical data. All right. The Jupyter Notebook is now opened up. So this is running on Binder on an online platform. You can also run this on your own computer, and there are instructions here to run this on your computer locally. So I'm just going to open up this Jupyter Notebook right now. The first thing I always like to do is go kernel and restart and clear output. This is to clear all the outputs from the previous execution so that we can see the outputs fresh. And I'm just going to hide the toolbar here so that you can see it better. All right. As I was saying, NumPy is a library that helps us work with numerical data in Python. So why we might need NumPy? Since Python itself also supports a lot of arithmetic operations and things like that. Let's look at that using an example. So let's say we want to use climate data, so things like temperature, rainfall, and humidity in a region to determine if the region is well suited for growing apples. Okay, so a really simple approach for doing this would be to formulate the relationship between the annual yield of apples. So let's say in tons per hectare. So whatever is the annual yield of apples in a region, we relate that to the climatic conditions like the average temperature, which would be probably in degrees Fahrenheit, the average rainfall in millimeters, and the average relative humidity, and formulate that as a linear equation. So we could assume that the yield of apples is some weight W1 times the temperature plus some weight W2 times the rainfall plus some weight W3 times the humidity. So we are expressing the yield of apples as a weighted sum of the climatic conditions. Now, obviously, this is an approximation because the actual relationship may not necessarily be linear because this is a linear equation, but a simple linear model like this often works really well in practice. And then what we might do is we might do some statistical analysis of the historical data. And based on that, we may be able to come up with a reasonable set of values for the weights W1, W2, and W3, right? So just based on looking at some historical data. So here is an example set of values. So now you have these weights W1, 2, 3. Now, given some climate data for a region, we can use these weights to predict what the yield of apples in the region might look like. So here we have the data for 5 regions. And let's say we want to identify what might be the approximate yield of apples in Kanto. So for that, what we can do is we can convert this information into variables. So the temperature, rainfall, and humidity, all of these become variables. And then we can substitute these variables into the linear equation, the formula, to predict the yield of apples in that region. So here the yield of apples in Kanto becomes the temperature times W1 plus the rainfall times W2 plus the humidity times W3. And once we do that, we get back the result 56.8, and we can print it out that the expected yield of apples in the Kanto region is 56.8 tons per hectare. Okay, so far it's a pretty simple calculation that we've done with a bunch of variables, but to make it slightly easier to perform the same computation for multiple regions, what we can do is we can represent the climate data for each region as a list of numbers, or what in mathematics is also called a vector. Because otherwise we might end up creating a lot of variables. For 5 regions, we end up creating 15 variables. For 50 regions, we end up creating 150 variables, and that's just a lot of code to write. So rather, what we are going to do here is we're going to say that the Kanto region is represented by this vector or this list of numbers. The first number represents the temperature, the second represents the rainfall, and the third represents the humidity. Then similarly, we represent all the other regions also using these vectors. And again, temperature, rainfall, humidity are the 3 elements of the vector. Further, the set of weights that we've used, W1, 2, 3, those can also be represented as a vector together. So now we have the region, each region is a vector, and the set of weights is a vector. So we can now write a function crop yield to calculate the yield of apples or any other crop for that matter, because you just have to change the weights for a different crop. So we can calculate the yield of apples given the climate data and the respective weights. Okay. So here we have a function which takes the crop, which takes the region, it takes a set of weights, and then it performs some calculation and returns the result. So let's observe what it does. So maybe let's just look at the Cantor region and let us look at the weights. So what we want to do is we want to multiply the first element 73 by the weight 0.3. Then we want to multiply 67 by 0.2 and we want to multiply 43 by 0.5. So in some sense, this is an element wise multiplication. And then we want to add up each of these products. So we get 3 products, so we add them up. So the way we do that is we set a result to 0 and then we use this zip function. So this zip built-in function returns pairs. So you can actually check what zip does. Let's see. So we say for item in zip, Cantor and weights, we simply print the item. So it turns out that it creates pairs out of the 2 lists. So it returns 73 and 0.3, 67 and 0.2, 43 and 0.5. So since these are pairs or what we call tuples in Python, so these tuples can be converted into variables. So I can pull out the variables x and w. So x would have the value 73 and then w would have the value 0.3. So here you go. And then that's repeated for each element. So now what we can do is we can simply multiply x times w. And that is what we have done here. We have multiplied x times w. So 73 times 0.3, 67.2 and 43 times 0.5. And we have added them into the result. So in effect, it has the exact same effect as what we had done earlier. So temperature multiplied by W1, rainfall multiplied by W2, humidity multiplied by W3, and then we return the result. All right. So that's our crop yield function. And we can verify that we call crop yield with the Cantor region and the same weights, and we get back the same result, 56.8 tons per hectare. And we can do the same thing for the Johto region and for the Unova region. So already we've simplified things a bit by writing this function. Now the calculation that we've performed, the element wise multiplication of 2 vectors and then followed by a sum of the results. This is also called the dot product of 2 vectors. And this is just a linear algebra term, and the dot product means exactly what I just said, an element wise multiplication of 2 vectors followed by a sum of the results. And you can learn more about dot products here on Khan Academy. It's a great resource if you just want to brush up linear algebra in general. But now the Numpy library, which is specialized for doing numerical computing and performing operations on numerical data, provides a built-in function to perform the dot product of 2 vectors, because this is such a common operation. But to do that, the lists that we have, the data that we have, must first be converted into a special data structure called Numpy arrays. And to create Numpy arrays, we first need to import the Numpy module. So I already have the Python library Numpy installed. This was done when we clicked the run button. So there was a set of requirements with the Jupyter notebook. But if you do not have Numpy installed, you can do pip install Numpy minus upgrade and minus quiet. And this is just to suppress the output, but pip install Numpy should do it. So you can run this to install Numpy, and don't forget the exclamation character. But now we import Numpy as NP. And now the Numpy arrays can be created using the np.array function. All right. So if you're seeing this part for the first time, so all we're doing here is we're saying that we want to import the Numpy module, but instead of calling it Numpy, we want to call it NP, so that when we want to use the array function from Numpy, instead of writing numpy.array, we can just write np.array. So this is also called aliasing. Okay. So now we create the Cantor region, the data we simply call numpy.array, and then we just pass in the same list of numbers that we had earlier. So nothing is really changed yet. And you can see here we print it out and we can just see that this is a Numpy array with the same list of numbers. Then we have the weights. So this is once again a Numpy array. It simply contains a list of numbers. But when you check the type, you will see that each of these has the type ND array, right? So this is no longer a Python list. This is now a special data type which is defined and offered by Numpy. Okay. And just lists, the Numpy arrays behave like lists in many ways. And one of the ways is just the indexing notation. So if you just use the indexing notation, you can get back the 0th element, which is 0.3 from weights, or the second element, which is 43 from Canto. But they also differ from Python lists in many important ways. And that is what we are going to see next. Okay. So now remember, we wanted to compute the dot product, which is the element wise multiplication followed by sum of the results. We can do that using the np.dot function. And a good way to see what the np.dot function does is just say help np.dot, and that's going to tell you what it does. So there's a lot of documentation here, and it gives you a lot of information about it. And then at the bottom, you will see a bunch of examples as well. So you can just see how to use this function. So now we call np.dot with Canto and weights, and we get back the same result, 56.8, except that now we just need to write the single line of code. If we can actually achieve the same result with even lower level operations. So NumPy arrays support arithmetic operators. So here, if we simply do Canto, let's just print out these arrays so that we see it. So remember when we talked about element wise multiplication. So if we just do Canto star weights and run that, so that actually performs an element wise multiplication of the two vectors. And then what we can do is we can take that, so that is a NumPy array, and then call dot sum on it. And now this dot sum operator, the dot sum method simply returns the sum of all the elements in a NumPy array. All right. So these are two convenient things that you could not do with Python lists. So these give us a very nice way to write the same expression without having to write a loop, without having to write a function, and so on. Okay. Yeah, and that's what we just looked at, the element wise multiplication and sum of two arrays. Okay. So before we move ahead, we're already starting to see some benefits of NumPy arrays. So there's one that we've already seen, which is the ease of use. Now, instead of having to define loops and custom functions like crop, you can write very small, concise and intuitive mathematical expressions like Canto star weights dot sum and get the same results. But another important reason to use NumPy is performance, because NumPy operations and functions are implemented internally using C++, and Python offers a way where you can write something in C++ and expose it, connect it with a Python function. So there's an interface available. So NumPy operations are written in C++, which is compiled down to assembly code. And what that basically means is it is machine code already. So the Python interpreter is not involved in the actual calculation, and that makes the calculation much faster. Sometimes we see, so that makes the calculation much faster. And whenever you want to have a claim like this, that something makes the calculation faster, the best way to do that is the best way to verify it is to just check by creating an example. Okay. Here's an example. Here we are going to create a million elements, a list containing a million elements. So here we have a list. This is a Python list. And then here we have another Python list. So there are a million elements here, 0 to 1 million minus 1. And then there are a million elements here, 1 million to 2 million minus 1. So two lists with the same size. And then we also convert those lists into NumPy arrays. So now we have two lists, and then we have two NumPy arrays with the same number of elements. Now we use this special time command. So this is something special to Jupyter. So you put in 2 percentage symbols and then time. And what this does is this calculates the time it takes to run this cell. Okay. So here we are doing the dot product using a for loop, similar to this what we did inside crop yield. So we just did a zip and then we got back the values and then we added them to a result. And to do that over two vectors of size 1 million, that took about 200 milliseconds. Now let's do the same thing, but this time let us use a NumPy array. So we have the same NumPy arrays and then we run it, just use np.dot, and that just takes 2.4 milliseconds. So that's where you can see we get the same result back, but the np.dot is 100 times faster than using a for loop. And this is what makes NumPy especially useful when you're working with really large data sets with tens of thousands or even millions of data points. All right, that's a benefit of NumPy. Now, before we go ahead, let us just save our work. So I'm just going to import the Jovian library and run jovian.commit. And this will ask us for an API key. So this is to capture a snapshot of your notebook. So you can go to your Jovian account. So just visit jovian.ml and log in and copy your API key and then paste it back here. Now, when you do that, what happens is this notebook gets captured, the entire snapshot, the inputs, the outputs, and that gets saved into your Jovian ML account. So you can view it here. And this binder instance, because it is running online, it's a temporary free service. So this might get shut down, but if you keep running jovian.commit from time to time, you will not lose your work. Okay. So moving right ahead, now we can actually go one step further and represent the entire climate data for all the regions together using a single 2-dimensional NumPy array. So here we can say the climate data is np.array. And here we pass in not a single list of numbers, but a list of lists. So we have a bunch of lists inside the outer list, and each list represents the data for a region. So this is the region data for Kanto, and this is the region data for Johto, and then all the other regions. And then each column here, so each element in the list represents a data point about the weather. So the first element always represents temperature, the second element represents rainfall, and the third humidity. And I've written it in this fashion, but you don't have to, you can write them all on the same line. But it helps to look at it like this, because this is what, if you've taken a linear algebra class in high school, you might recognize that this is what is called a matrix. Or if not, you can just look at it as a table of values. And it has 5 rows, one for each data point, and it has 3 columns, one for temperature, rainfall, and humidity each. Okay, so we create this array, and then we get back, once again, we get back this array object, but this time this is a 2-dimensional array, right? It is no longer a 1-dimensional array. And that is what makes NumPy arrays so flexible, that they can have any number of dimensions. So here is a 1-dimensional array. This is what we looked at, a vector. And then here is a 2-dimensional array. So here there are 2 rows. So just we have 5 rows here and 3 columns. Here there are 2 rows and 3 columns. And then this is a 3-dimensional array. So here you might have 1, 2, 3 in this direction. And then inside that you might have a list of, you might have 3 elements each. And each of those elements itself could be a list, right? So you can have 1D, 2D or 3D arrays in NumPy. And since these arrays, and you can actually have 4D and 5D and any number of dimensions, you just have to keep nesting lists inside lists inside lists. And since NumPy arrays can have any number of dimensions and different lengths along each dimension, what we can do is we can inspect the length along each dimension using the dot shape property of an array. So if we check climate data.shape, you get back the value 5,3. So let's see how we arrive at that value. So the way it works is you first look at the outermost bracket, and then from the outermost bracket, you see how many elements are there in the outermost list. So the outermost list has 1, 2, 3, 4, and 5 elements. And that's why you get 5. Then you go one step in. So you can just pick up the first value. So let's say 73, 67, 43, and see how many elements that has. So that has 3 elements, and hence you have 3. Now suppose each of these elements was also a list, then you could count how many elements were there inside each inner list, and that would give you the third dimension. So and we see an example of that. So here we have weights. This is a vector or a 1-dimensional array. So we can check the shape of weights, and the shape of weights is just the tuple containing 3. So the output of shape is a tuple. The number of elements is the number of dimensions, or also called the number of axes in NumPy. And the length along each direction is the number that is there at that position. So since this is a 1D array, you get back one number, and that number is 3 because it is a vector of size 3. Okay, so then moving forward, the next kind of array is a 3D array, and then you can have 4D and 5D. But for 3D, you can notice here, and this is a little difficult to show because we can only write in 2 dimensions. So you can see here that we have this 2D array or a matrix, and then we have another matrix. So this is, you can think of it as 2 matrices sitting side by side forming a cuboid. So this kind of a structure. And to guess the shape, let's try and guess the shape here. So we look at the outermost bracket and then we say, okay, in the outermost list, there are 2 elements. So the first element is 2. Then in every inner list, there are 2 elements again. So the second element is also 2. And then inside those elements, you have 3 elements, right? So then the third element is 3 for the shape. So hence the shape is 2 by 2 by 3. Okay. So now you might wonder what happens if I do not have the same number of elements. So you can do something like this and then try creating this array and try printing out the shape of this array. Try looking at the array and see if NumPy is actually creating a n-dimensional array or not. Okay, it's a good exercise to just try this out. So one other thing to keep in mind is that for the purpose of efficiency and performance, elements in a NumPy array all should have the same data type. And you can check the data type of an array using the dtype property. So for instance, the weights. So this is an array containing some floating point numbers. If you check dtype of weights, you will get back a dtype float 64. So this is again important that the NumPy data type, NumPy has its own data types different from the Python primitive data types. The reason for that is Python's primitive data types support a wide range of values, but NumPy limits its data types to certain set of values. So for instance, float 64 means that only 64 bits of space in the memory will be used for a floating point number. And similarly, if you check, let's say if you check climate data, this is of type int 64. So it can only take 64 bits of data to store an integer. And that's the reason NumPy has its own data types. But in general, there is a 1-to-1 correlation. If you're using floats, you might end up seeing float 64. And if you're using climate data, if you're using integers, then you might end up seeing int 64. Okay. One interesting result from this is that if an array contains even a single floating point number, then all the other elements are also converted to floats. So for instance, the way we defined array 3, let me just grab that once again. So here we just defined array 3 where all of these numbers are integers, but the last one is a floating point number. And if you check the dtype, that turns out to be float. And even when you print it out, you will notice that all these numbers have been converted into floats. Okay. So that's just a little bit about when you're dealing with different dimensional arrays, how do you understand what their dimensions are, how many axes there are, what is the length along each axis, and what is the data type contained in it. So coming back to our example though, we have the climate data is represented as, so there are 5 rows, one for each region, and then there is 3 columns for temperature, rainfall, and humidity. So now we can compute the predicted yield of apples in all the regions using a single matrix multiplication, right? And this is where you will need to know a little bit about matrix multiplications. And I've pointed to a resource. Once again, there are 3 or 4 videos that you can watch to understand this. But roughly how it works is this. So this is our matrix containing all the data. So when we multiply that with the vector containing the weights, what happens is we get back a vector as a result. And the vector will have, the first element of the vector will be 73 times W1 plus 67 times W12 plus 43 times W13. So basically the dot product of this row and this weights vector. And similarly, the second element will be the dot product of the second row and the weights vector, and so on. So use it, the matrix when multiplied with the weights will give back a vector, and each element of the vector will be the dot product of that specific row with that specific with the weights vector. Okay, and that is what we want. So now and the way to do that in NumPy is to use the mat_mul function. Once again, NumPy gives an inbuilt function for matrix multiplication. So this here, what we're doing is we're taking the climate data and we're taking the weights and we're doing a matrix multiplication. So this first element comes by multiplying, doing a dot product of this with this. And then the second element comes by doing a dot product of this with the whole vector. And the third element comes by doing the dot product of this with the whole vector, and so on. And another way to do the matrix multiplication overall is to simply use the @ character or the @ character. So the @ character represents matrix multiplication in NumPy. So we do the same thing, climate data @ weights, and we get back the same results. So now that's pretty convenient. We've taken all our data, all our operations, and then reduced them down to a single line of code for the entire data set. And that is what makes NumPy and libraries in general so powerful, because they offer all of these. Behind this single @ character, there is a lot of complexity that is being hidden from you, and you just have to think of it in terms of a matrix multiplication. All right. So let's take that one step further. Now, so far we've been working with 5 data points. Let's go a little bit further and try and work with a file. So what we'll do is we will download a file, climate.txt, which will contain 10,000 climate data points. So it'll look something like this: temperature, rainfall, and humidity. So the first row simply describes what information this file contains. And then each row or each line of the file will contain the information for one region. So this is the temperature, rainfall, and humidity in region 1, and for region 2, and for region 3. So in a sense, you can see here that this is like a table or a spreadsheet, but represented using plain text files. And it is separated, the data is separated by commas, and there is one data point or one what is called sample on each row or each line of the file. So this kind of a format is called the comma separated values format, obviously because these values are separated using commas. Okay. So we're first going to download the file, and the way to do that is to use the urllib library. So the urllib module in Python offers a lot of utilities for working with URLs, like making requests, downloading files. And specifically, we want to use the URL retrieve function, which is present inside a submodule of urllib. So we need to import urllib.request because that is what contains the URL retrieve function. And then we give it, so we call urllib.request.url retrieve, and then we give it the URL that needs to be downloaded and the file name or the path where we want it to be downloaded. So we just want to download it in the same directory as the Jupyter notebook. So I'm just going to give the file name climate.txt. So now the file should be downloaded, and you can check this by going File, Open, and you should be able to see here that you have climate.txt here. If you click on climate.txt, here you will find that this is as I mentioned, this is the header. It describes what each column contains, and these are all the data points. And there are about 10,000, you can verify it. But a better way is to just load it up as a NumPy array. So when a CSV file contains all numbers, it's very easy to load it up as a NumPy array. So the way to do that is using the gen from txt function. So np.gen from txt. And once again, you can use the help function on np.gen from txt to see what it does, or just look it up online on the documentation. But we just need to use 3 of these arguments. It supports many more. So the first argument that we give it is the file name or the full path of the file. In our case, it's just climate.txt in the current folder. Then we need to provide what the delimiter is. So what is the separator between the data? So in our case, the data points are separated by commas, but sometimes these are separated by colons. Sometimes these are separated by the tab character. So we just want them to be separated by commas. And finally, we want to skip the header row, right? So because the header row, this is not numbers, this is just some metadata or some information about the data. So we can skip that by providing the number of header rows to skip. So we just do that. And then let's print it out. And there you go. You have the climate data. And because there are so many elements here, NumPy just truncates it by printing dot. But if you check the shape, you will find that there are 10,000 rows, and each row contains 3 elements. So temperature, rainfall, and humidity. So we can now use a matrix multiplication operator to predict the yield of apples for the entire data set using a given set of weights. So let's take these weights, 0.3, 0.2, 0.5, the same weights that we had earlier, and let us just multiply it. So we do climate data at weights, that performs a matrix multiplication, and that will, in just one line of code, give us back the entire results. So these are all the yields. So you can see that this is the yield for the first region, this is the yield for the second region, and so on. and that gives us back all, and you can see that there are 10,000 results here. Okay. And then what we might want to do is we might want to take the yields that we have and add that as a new column inside the climate data array. So just as we have temperature, rainfall, humidity, we might want to just add another element here that will represent the yield. And then we can write it back to a file, right? So this is the common flow, that you get some data file, you pull it in, you perform some analysis, you perform some operations, you get some results, and then you take those results, create some output and write it back to a file. So to do that, now to add the yields back to the climate data as a fourth column, so we are going to use the numpy.concatenate function. Okay, so I'm going to call numpy.concatenate. This is used for joining two arrays, and then you need to give it a tuple containing the arrays that you want to join. So we give it the climate data and the yields. Ignore this reshape for a moment. And then you need to give it the axis or the direction along which you want to join them. So for example, what we want to do is we do not want to add more rows to the data, right? We want to add more columns. So if we wanted to add more rows, that means we were adding things into the outermost list. So that would be the 0th dimension or the 0th axis. So by default, the axis will be 0, but we want to add it inside. So to add it inside, we are going to mention that we want to concatenate along the first dimension. And that is why we have set axis equal to 1. So we pass in the climate data and we pass in the yield, and then I will let you figure out why this dot reshape is required. You can try running this line of code without it, and then you can try looking up the documentation for reshape, and I'll let you figure out. And if you're not able to figure it out, you can ask on the forum and then we'll answer it there. Okay. But all said and done, what this does is this concatenates the result. So you can now see that we have a new array called climate results, which contains three columns from the original data, and then the fourth column is from the yields that we have just calculated. Okay. So here is the visual explanation of concatenate. So what we had here, let's say this was the yield, this was the data for the regions, so temperature, rainfall, humidity. And in our example, we only had one row of output. So we only had one column of output, so you can ignore these two. So we simply had the yield of apples and the yield of apples here. So when we call concatenate with axis 1, so these get attached along the columns. If you call them with axis 0, they would get attached below. All right. So you can experiment here. So the best way to actually understand what a numpy function does is to just experiment with it and then read the documentation using the help function. And for most numpy functions, you will actually find some examples at the bottom of the documentation itself. Okay. So use these cells, these empty cells, to experiment with np.concatenate and np.reshape. All right. So now let us take the results that we have and let us write them back to a file using np.savetxt. So I think you're getting the idea here that for pretty much everything that you want to do, there is a function in NumPy. And I'll tell you in some time how to find the right function. But here we are just going to take the NumPy function, the savetxt function, give it the climate results, and say we want to write it to climate results.txt. So just these two are enough. But then I have included some other things here just to make it a little bit nicer. So by default, NumPy will write almost 10 decimal points for each number. We don't want that. We can just put in 2 decimal points. So I've just put in this formatting string to just put in 2 decimal points. And then we have this header. So if you want to include a header at the top saying that this represents a temperature, rainfall, humidity, and yield of apples. So that's why we can use the header argument. And finally, there's a comments argument. In this one, I will let you figure out what this comments argument does. So you can simply remove this argument and then try and running it and see what the difference is. Okay. So we run savetxt, and that writes the data results back to climate results.txt in this format. Okay. And once again, you can open the file and check that it has the expected output. All right. So As I just mentioned, NumPy provides hundreds of functions for performing these operations on arrays. And here are some common functions. So for mathematics, you will find numpy.sum. So you can not only sum the entire array, but you can also sum just along a particular dimension or along one or more dimensions. Then you have numpy.exponent, numpy.round. So for rounding numbers, for array manipulation, you have concatenate, you have split, you have stack. Then you have matrix multiplications, dot products, transpose, eigenvalues, and you also have some statistical functions like mean, median, standard deviation, and things like that. So how to find the function that you need? You do not need to remember all of these functions, and it can sometimes be hard to find exactly what you need. So the easiest way to find the right function is to do a web search. So just do a search on any search engine, Google, DuckDuckGo, wherever, and try to formulate what you want to do into a single line as clearly as possible. So for example, what I searched was how to join NumPy arrays, and that led me to a tutorial on array concatenation, and that is where I got the code for this operation. So I was not sure what to use, so I just searched how to join two NumPys, or you can search something more specific, how to add a column to a NumPy, and then you will find some result, and that is a good place to start. The next place is probably just to go through the documentation. So there is a full list of array functions. You can, and we'll go through that list a little bit later. So you can just go through the list and just try, and it is categorized based on different criteria, things like this. So you can find the right function there. And finally, you also have the Jovian.ml forum, the course forum. So you can always ask on the course forum, and the course forum is really active. So you will probably get the fastest answer by asking on the forum. Okay. All right. So once again, before we continue, let us just save a snapshot of our work. And in general, when you're working with Jupyter notebooks, especially on Binder, but also on your local computer, just keep running jovian.commit from time to time. It's like saving, but it's saving your work to your Jovian account. Okay. Okay. So we've seen arrays, and we've seen functions operating on these arrays, but I also want to spend some time talking about arithmetic operations. So NumPy arrays support arithmetic operators like plus, minus, star, and the interesting thing is that you can obviously perform these arithmetic operations. So what we call element-wise operations between two arrays. So here we have array 2, array 3, and if I do array 2 plus array 3, so that's going to add up each element, and it's going to return an array of the same shape. And now you might wonder, okay, what if these two arrays do not have the same shape? Then you can try it. That's something that you can experiment with and find out, right? So when they have the same shape, most of these arithmetic operators perform an element-wise operation. But what you can also do is, instead of adding an array of the same shape, you can just add or do any arithmetic operation with just a single number. So here we have array 2. You can see array 2 has a value 1, 2, 3, 4. And then if we just do plus 3, so 3 gets added to every element of the array. Okay, so you can see 1, 2, 3, 4 becomes 4, 5, 6, 7, as we might expect by adding 3. And then we've seen element-wise subtraction. This works as expected. So you can see that if I subtract from array 3, array 2, each of these differs from the corresponding element by 10, and hence we get back this result. You can divide by a single number. So here's division by a scalar. We've already seen element-wise multiplication. And then you can also do things like remainder, right? So you can take array 2 and you can find the remainder of array 2 with a number like 4. And these are all the remainders. Now that's great, but NumPy arrays also support something called broadcasting. And what that does is that it allows arithmetic operations between two arrays having a different number of dimensions, right? So they can have a different number of dimensions, but their shapes must be compatible. So let's take an example and let's work through it. Let's understand it using an example. So here we have array 2. This it has 3 rows and 2 columns. So it has the shape 3, 2. And then here we have array 4, and this simply has the shape 4. Now what we can do is we can write array 2 plus array 4, and that is a perfectly legal thing to do in NumPy. And what NumPy will do is NumPy will check, actually you can see it visually here. So here we have an array, right? And then here we have a smaller array. So what NumPy will try to do is it will try to take the array with lower number of dimensions and replicate it a few times. So here the array gets replicated 3 times because it has to match 3. But here this array 4, 5, 6, 7 will get replicated 3 times. So in a sense, what you will end up with is that NumPy will automatically replicate array 4 in this fashion. So the 4, 5, 6, 7 will now become 4, 5, 6, 7 3 times. Okay. And then the addition can be performed, right? Because now the shapes match. So now we can just do array plus array 4, and you can see that has the result as you might expect. 4, 5, 6, 7 gets added to these, 4, 5, 6, 7 gets added to these, and 4, 5, 6, 7 gets added to these. And you can just verify this completely. Array 2 plus array 4 replicated. Oops, yeah. And you can see that we get the exact same result. All right. So this is the idea here. This is the idea of broadcasting. And here is a visual explanation of the same thing. And then the thing to remember is that broadcasting only works if one of the arrays can be replicated to exactly match the shape of the other array. So for instance, here we have array 5, and we have array 5.shape is just 2, and then we have array 2. So now if we try to do array 2 plus array 5, even if you replicate the 7, 8 3 times, let's try that. Let's write it in a replicated fashion. So array 5 replicated. Okay, so this would be 7, 8 and 7, 8 and 7, 8. So even when it's replicated, what happens is that these dimensions, these shapes don't match up, right? So you have the same number of rows because of the replication, but the columns don't match up. And because the columns don't match up, you get a value error that the operands could not be broadcast together with the shapes 3, 4 and 2. Okay. So broadcasting is a very powerful technique, and it's useful because now you do not have to create this replication for one. And in fact, when NumPy does the replication, it is only a conceptual replication. That means it does not actually create copies of the array. So it saves on memory, it saves on, improves the performance. So it's just a way of conceptually replicating or increasing the dimensions of a smaller array for the purpose of an arithmetic operation while still having good performance gains. So just try it with a few examples. Try it with 2-dimensional arrays, try it with 3-dimensional arrays. So maybe take a 3-dimensional array and to it try to add a 1-dimensional array and see what happens. Okay. And in general, this is true with most things, but specifically with NumPy, the more you experiment with these things, the better you understand it. So you can hear somebody, you can listen to somebody explain these things for hours together, but you will not get how it works unless you experiment with it and see how it breaks. And that's very important. Okay. And then apart from arithmetic, NumPy arrays also support comparison operations. So things like double equal to, not equal to, greater than, less than, and so on. So here we have 2 arrays and we can check if corresponding elements are equal. So you can see here that some of these values are equal. So 2 matched with 2 and 3 matched with 3, and that's why we have true here and then we have false here. So now this is an array of booleans, right? So you can actually check this. So if I do dot d type, that has the type bool, and the same holds true with any comparison operator. Okay. Now, why might you want to do that? One important thing to remember is that even though these are comparison operators, the result itself is not a boolean. It's actually an array of booleans. So that's very important. It's an important thing to keep in mind. And one common use case of something like this could be to count the number of equal elements in 2 arrays. So what you might do is you have array 1 and array 2, and we want to know, for instance, that if we compare the corresponding elements, the elements at the same positions, how many of these are equal? So 1 and 2 are not equal, 2 and 3 is equal, 3 and 3 are equal, these 2 are not equal, 5 and 5 are equal. So the way to do that is you could first do array 1 compared with array 2. So that would give you a list of an array of booleans, and then you could call dot sum on it. So now what dot sum will do is it will try to add up the booleans, and remember that true evaluates to 1 and false evaluates to 0 when they are being used as booleans, when they are being used in an arithmetic operation. So that will just give you the number 3, which is the number of matching elements between the 2 arrays. All right. And then you can imagine now, you can use your imagination to think of other use cases where this might be useful. Okay. So that's about array operations and broadcasting. One thing that we did not go into too much and we'll get into now is how to get data out of a NumPy array, right? If you have a multi-dimensional array, and we looked at this briefly where we said that like lists, you can index into NumPy arrays, and that is possible, but then NumPy actually supports a much more powerful indexing notation. So it extends Python's indexing notation to multiple dimensions, and it does so in a fairly intuitive fashion. So what you can do is you can provide a comma separated list of indices or even ranges, and you can use that to select a specific element from the entire array. So let's take this array and you can select a specific element, let's say this one, or you can select specific portions, right? You can even select just what are called slices or sub arrays from the NumPy array. And we'll see a few examples of that. Okay. So here we have array 3. This is a NumPy array and it has the shape, and you can guess the shape here. It has the shape. So if you see the outermost list, that has 1, 2 and 3 elements, 3 comma, and then if you go one step inside, here you see 2 elements, so 3 comma 2, and then the innermost one has 4 elements, right? So the shape should be 3 comma 2 comma 4. And this is a good exercise just to visually look at an array and try to tell the shape and guess what np.shape will return, the array.shape will return. So now let's say we want to grab a single element out of it. Let's say we want to, and the way to do it is so along each dimension of the shape, you provide which element you want to access. So here we are passing in 1 comma 1 comma 2. So let's see, and the way I find it easiest to do is just to work from the outside. So now we have 1. So that gives us, well, from the outermost list, this is 0. So this is 1. So we take this, and in fact, we can just check this as well. So if you just do array 3, 1, you get back just this element, right? And then we have 1 again. So inside this array, we ignore this and then we choose this. So we get back 1 again. So 1 comma 1 returns this, or you can see it as this. And then finally we have 2. So here 0, 1, 2. So this should give the result 36, right? So that's how indexing works. And I find it easiest to just work all the way from the outside. And let's take an example of indexing using ranges. So now we are no longer getting a single element, but we are actually getting a range of elements from along each dimension. So here what we are saying, let me just print out array 3 again. So here what we are saying is along the first dimension, that means along the outermost list, in the outermost list, we want to start from the first element. So we want to skip the 0th element, start from the first element. So we skip this entire element altogether, and then we take this, and then we want to go till the end. So we take the first element and then second element and however many elements. So remember list indexing, when you're using ranges, if you leave one side of the range empty, that means you want to go till the end. So this is the same as doing 1 colon 3, but 1 colon just says 1 and then everything ahead of it. So yeah, so you have this 15, 16. So now you are left with these two. And again, I just find it very easy just to break it down a lot step by step so that there is no confusion. So as I expect, doing 1 colon here is going to return this. Okay. Then we are saying that in the second dimension, we only want to keep from 0 to 1. So in the second dimension, we want to start at 0. So that means in every inner list, and by inner list this, right? Not the innermost. We are just going from, let's say this is actually dimension number 1. So the outermost was dimension 0, and then this is dimension 1. So let's just use 0 indexing. So outermost was dimension 0, and now we are at dimension 1. So this is dimension 0, and then here we have dimension 1. Now within dimension 1, we want to take the 0th element, which is this, and then we want to skip the first element, right? So the range from 0 to 1 means only 0, because the end point of a range is not part of the range. Okay, so we want to keep the 0th element, but we want to skip the first element. So if I put in 0:1 here and run it, so what I expect to see is that this element should go away. And you can see that element went away, and the same thing happens everywhere along that dimension. And now finally, we have the final dimension, the third dimension, the dimension number 2. So 0th, first and second dimension. So in dimension number 2, we are saying we want to start from the beginning, and that's why it's blank. And then we want to go up to the second index, but not including. So that means we want to take the 0th index and we want to take the first index. So for each of these elements, we just take the 0th element and the first element. So we should end up with 15, 16, 98 and 32. Okay. And one thing to note here is that wherever you are using ranges, the number of dimensions does not reduce. So when we use exact numbers for indexing into an array, each time we use an exact number, the number of dimensions reduces. And then when we use a range, that preserves dimensions, because the range is saying that the result of a range selection is also an array. So along each dimension, we are still keeping an array of some kind. Okay. And then you can mix indices and ranges. So once again, let's take one more example maybe, and then the rest I will leave for you as an exercise. So here we have array 3, and then we are saying that we want to take 1:, so that means we probably want to exclude this element, and then we want to take these, and then we want to take this. And then within these, we want to select 1, 3. So 1 would be this, and then inside that 3 would be 0, 1, 2, 3. So we would be left with 18, but we would also be left with 43. So you can do this step by step again by just putting 1 index and 2 indices and 3 indices. Here you go. We end up with 18, 43. Okay. And then here is another example where we have 2 ranges and then you have 1 index in between. And here you have fewer indices. One thing that you can also do is you can actually leave out, if you want to go all the way from start to end, then you can just put a colon, and that will preserve that entire dimension completely. No selection will happen there. You can also use less than, so if you have 3 dimensions, you can use 1 index, you can use 2 indices, you can use 3 indices, but if you try to use too many indices, you will get an index error. Okay. So this notation and the results that we just got, these can seem confusing at first, especially if it's coming to you in such a short time. But what you should do is you should take your time and experiment so that you become comfortable with it. Okay. And use the cells, create some cells below. So by the way, I'm pressing the B character. So escape plus B creates cells. So just create some cells and then try out some experiments. And here is a visual representation. So here you have a NumPy array, and you can create this array over here, and then you can try out these examples and see how that works. Okay. It's all about experimenting. The more you experiment, the more you understand it. Okay. And so now we've looked at pretty much everything NumPy has to offer. And one last thing that I want to share is how to create NumPy arrays. And we've seen np.array, that is the easiest way to do it. And we've also seen gen from txt, which can take the data from a CSV file. But you can also create arrays, some special arrays using some direct functions. So you can create an array of all zeros. So np.zeros, and then you give it a tuple containing the shape that you want to create. And that will give you, let's say this is a 3x2 array. So it contains all zeros. This is also called the null matrix or the null array sometimes when you talk about it in mathematics terms. Then you have these np.ones. So all of these are 1, and it has the shape that you pass to it. So the shape can be a tuple or the shape can be a list. It doesn't really matter as long as it is something that can be iterated over. You can create the identity matrix. So this is useful if you're performing some matrix operations where you just want to pass in the identity matrix. You can create a random vector or a random matrix. So for NumPy has a .random module. So np.random, and inside it you have the rand function, and then you also have the rand-n function. So what's the difference? The rand function picks uniformly a value between 0 to 1. But the rand-n function picks it from a Gaussian distribution. And this is where you need to know a little bit about probability and random distributions. But if you don't, you can just use rand_n and be well most of the time. And rand_n generally gives values in the range of -2 to 2. It can even be higher. It can generally be lower than -1 to 1, but because it's picked from a probability distribution, it can have a wide range of values, but a lot of the values will be concentrated around 0. Or specifically, technical terms will say that it has a mean of 0 and a standard deviation of 1. Anyway, but if you don't understand those terms, don't worry about it. But one key thing to notice here is that while these normal array creation methods take tuples as the shapes, for rand and rand_n, you need to pass in the shape as the arguments, right? So there's no tuple here. So this will actually lead to an error. Yeah. So that's just a small quirk in the np.random module that sometimes might cause values. But you can experiment with this and you can check the documentation, just call the help function and you will understand how to use it. Then you can create arrays with a fixed value. So here we are creating a 2x3 matrix containing the number 42. And you can create arrays, you can create a range. So you can say np.arange. So this is the analog for range in Python. So we are saying that we want to start at 10, we want to end at 90, and we want to take steps of 3, right? So np.arange. So you can see 10, 13, 16, 19. It goes up all the way up to 88. And I can check the shape of this. And the shape, it seems like there are 27 elements here. Now, when you have this range, what you can do is you can take this, or when you have any array in, and what you can do is you can actually change the shape of the array. So what you can say here is I can take this result of np.arange, which has 27 elements. And I know that if I reshape it, if I call reshape and I pass in 3, 3, what it does is this creates a 3D array where it has the length 3 along each dimension. So essentially what it's doing is still the same numbers, 10, 13, 16, 19, 20, 25. It's just inserting brackets at the right places to make it look like a 3D array. And that is why the reshape function can be quite useful sometimes. And remember, you cannot just reshape this array containing 27 elements to any size. If I tried 3x4, that will fail because the number of elements does not match up, right? Here you have 27 and here you have 12. That cannot match up. So it has to be something like 3x3. It can be 3x9. It can be 1,27. So you can actually increase the number of dimensions while still keeping the same structure, not changing too much, and things like that. One interesting thing is that because the total number of elements is fixed, while reshaping, you can leave out one of the indices, right? So you can just leave out, you can just say 3, 3 minus 1, and NumPy will automatically calculate that in total you need 27 elements. So then this number should be 27 divided by 3 multiplied by 3. So this number will be 27 divided by 9. So this number will be 3. So if you leave it as -1, you can see that we get the same result. Okay. So that's just a very nice way of creating NumPy arrays of different shapes that you need. Another last function that I'll talk about is the linspace function. So here what we do is we take a range. So we go from 3 to 27, but now instead of taking a step, what we provide is the number of elements that we want in the array, and you automatically get equally spaced out numbers. So if you wanted 9 numbers, so we could go from 3, 6, 9, 12 all the way up to 27. But if we wanted, let's say 18 numbers, then we would get back 18 numbers here. All right. So that's that. I'll just make one final commit here. And let's just do a quick recap of all the topics that we just covered. So for the first thing that we saw was how to go from Python lists to NumPy arrays, and why we should do that, why we should consider it. We also looked at how to operate on NumPy arrays. So we looked at the np.dot function or the matrix multiplication. Then we looked at the benefits of using NumPy arrays over lists. And then we saw how we can go beyond just one dimension using multi-dimensional NumPy arrays. And then we also looked at examples of working with CSV data files, how to load them, how to perform computations and then write results back to a file. And then we looked at some arithmetic operations and broadcasting. And then we looked at array indexing and slicing. And finally, we looked at some other ways of creating NumPy arrays, right? So NumPy is, in some sense, it's a very small library because the core concepts that it offers are fairly small in number. But on the other hand, it is a very vast library as well. And it offers hundreds of functions. So if I go back to the NumPy documentation, so on the documentation, you will find a list of all the different functions. Let me see here. Yeah. So there is this section called routines within the NumPy documentation. Let me just zoom it in for you. Yeah. So there is this section called routines, and it is linked to in the notebook as well. So you can see here, these are all the different array creation routines, and then you have array manipulation routines, then you have binary operators, string operators. So NumPy arrays can have strings as well, not just numbers, although we use it mainly for numbers. Then you have some date time related things. You have a bunch of mathematical functions. You have a bunch of things like calculus related functions, Fourier transforms. You have different ways of doing input and output. So it's not just text files. You have a linear algebra, you have logic, you have array operations, here more mathematical functions, trigonometry, and so on, matrices, polynomials, randomization. So there's a whole random section for random sampling, sorting, searching, statistics. So there are a lot of things here, right? And this brings us to the assignment. So because it's not really possible for one person to go through the entire documentation, and I highly recommend not going through the entire documentation and trying to memorize it. That's just not a useful thing to do. But what you could do is just read a few of these and just try to experiment with them and come up with some interesting examples that you found unique, right? That's something that you did not come across in the documentation, something that you came across while you were experimenting. And that is what we are going to do in the assignment. So if I come back to the course page, so that is 0topandas.com. Now here on the course page, you can see that assignment 2 is now live. And the objective of this assignment is to build a solid understanding of some NumPy array operations. So what you need to do is you need to pick 5 interesting NumPy array functions. So you will do that by going through the documentation. So specifically by going through this page on routines, and then you will run and modify a starter notebook. So let me just open up the starter notebook here, and let me just quickly click run here. So the starter notebook contains some instructions. So you can see assignment 2, it contains a bunch of instructions here. But the idea here is that you will go through the documentation and you will pick 5 interesting functions. For example, just as an example, let me pick something related to Fourier transforms. If calculus, this might be of interest to you. So you pick 5 functions, and then what you need to do is for each function, you need to come up with 3 examples. So 3 examples, 2 examples that work and 1 example that breaks. And then you also need to explain the function in your own words, right? And the way you need to do that is by modifying this Jupyter notebook. So you have a Jupyter notebook here. When you run it and open it up, what you should do is give it a nice title. So let's say I'm going to call it something like find NumPy functions you didn't know you needed. Okay. So basically I'm going to pick some rare functions, let's say, and then you can have a subtitle or not, it's up to you, but you should write a short introduction about NumPy. So think of it like a report or a blog post that you're writing. Good documentation is an essential part of data science. It's a lot more important than you might think. So just write a short introduction to NumPy. What is NumPy used for? Use your own words. What do you take away from it? And then list the functions that you will be talking about. You can mention what functions you will talk about, the 5 functions that you have picked, and then save the notebook. So I'm not going to commit here, but keep committing your notebook from time to time. Then here, once again, you need to list the functions, this time inside a code cell. Okay. So I'm just going to show you one example. So I've put in np.concatenate here, but you should change this. So use something else here, whatever you come up with. So list the 5 functions. So like np.concatenate, np.max, np.min, let's say, np.mean, np.median. All right. So these are the functions, statistics related functions I'm going to do. So you just list them here. Then for each function, you need to edit the information. So function 1 np.concatenate. So change this to your first function. Then add some explanation about the function in your own words, right? So you may want to experiment with it a little bit. So you can add a few cells here, do some experiments, and then once you're done with experimentation, you can delete those cells. But finally, you need to have some basic explanation about the function. And then you need to give 3 examples. So here is example number 1, where I'm concatenating 2 arrays along the axis 1. Then you can give some explanation about the example if required, like how the example works. Then we have example 2. So you can try to pick a example that illustrates something different, like maybe instead of axis 0, axis 1, instead of axis 1, I will use axis 0, and I will use different shapes of the inputs. So between 2 examples, you should generally be able to demonstrate the pretty good range of what a function can do. And then finally, the third example should be something that breaks. So this should lead to an error. So for example, here I'm trying to concatenate 2 arrays that cannot be concatenated, and this leads to an error. And then you can provide some explanation about why it breaks. Okay. So the idea here is that you read the documentation, you try to break the function, and when it breaks, you understand why it is breaking and explain that. And when you do that, your own understanding of that function improves dramatically. And finally, you can add some closing comments about when you might want to use this function, where it can be useful. And all of this is just for you to really think about an answer. And then at the end of it, you just commit. So you run jovian.commit. And when you run jovian.commit, what this will do is this will save the notebook to your Jovian profile. Let me just do import Jovian and jovian.commit, and I will set project equals assignment to live, and let me grab my API key. Okay, so now keep committing after every function, otherwise you may lose your work. And we've noticed that a lot of you have complained about this, about assignment 1. So now it is committed to your Jovian profile. So now you need to take this link, and remember, take this link and not the binder link, because the binder instance will get shut down. So you take this link and then you come back to the assignment page and you can make a submission here. Okay, so now you can put in the notebook link, and this has to be a Jovian notebook link, and click submit. And that is going to then put it into evaluation, and then we will do the evaluation. Basically what we're looking for is you should have 5 functions, and you should have some explanation and 3 examples for each function, 2 that work and 1 that breaks. And that is the whole idea here. But after doing that, after you're done with the submission, there is an optional but important part that you should also do. So the assignment discussion thread, and you can see here, this is a discussion thread. You will see a continue discussion button. So just like the lecture, we have a discussion thread for the assignment, and this time you can take the 5 functions that you have created and you can share it on this thread. So I can take this, I just created this assignment to live, and I can click the reply button here. So there is a reply button at the bottom, and paste my link here and just mention that, hey, these are the 5 functions I wrote about. All right, so just share the 5 functions that you wrote about. Maybe you can list them out here. If not, you can just say roughly that, hey, I wrote about trigonometric functions, or I wrote about statistic functions, and share the link to your notebook. And this way, what you will get to do is you will get to share your work with the entire course community. You can even share your notebooks online on Twitter or LinkedIn or wherever, and that would require you to make your explanations nicer. One thing that you can do is, before your final commit, you can actually remove this explanation block. So you can take this explanation block and then just get rid of it, so that it looks a little bit nicer, and that will make it easier for you to share it online. So share this on the thread, and try to go through the notebooks shared by at least 4 or 5 other participants, so that you have gotten a deep understanding of about 5 functions, and then you learn about another 25 or 30 functions by reading the notebooks of other course participants. All right, and this is going to be really interesting. I am really looking forward to what you come up with, what interesting examples you come up with. Yeah, please do share it. Although that is not a requirement for grading, you simply need to make a submission on the submission page. You don't need to go on the forum, but we highly recommend that. All right. So that is the assignment. And if, by the way, if you do share it on Twitter or LinkedIn or other places, and if you tag us, so we are at JovianML on Twitter, we will be retweeting and resharing 4 or 5 interesting notebooks every day. So you can get a chance to get featured on our Twitter or LinkedIn as well. So that is the assignment. That's what you need to do. That is the compulsory exercise for the week for the certification. Apart from the assignment, there is also an optional exercise. Let me just find my notebook. Okay, going back to the lecture. So on the lecture page, you will find, so coming back to lesson 3, you will find an optional exercise here as well, 100 NumPy exercises. So this is a bunch of, this is from a GitHub repository. It's a popular repository which contains, this is basically just 100 questions related to NumPy. So you can import the NumPy package, print some version, create a null vector, get some documentation, create a null vector, fill in a certain value. So there are a lot of different exercises, and this will help you get your hands dirty, and this will require some exploration. So sometimes you may have to even search what some of these terms mean, and sometimes you may have to look up the documentation and try a few ideas. And these are 100 problems. So this is an optional exercise, but once again, if you want to really master Python and master NumPy, we highly recommend doing these 100, or at least try and do maybe 20 or 30 of these. Pick a random set of 20 and try and do these exercises. They're also marked by difficulty, so that's up to you. And what you can do is, if you want to get help, I have created a forum category, forum thread specifically for this, for the 100 NumPy exercises. And this is something that you can keep doing over the next few weeks or even beyond. So this is just, it's not a part of the course as such. It's just something that you can keep doing forever over time. And so please post if you're facing issues, if you need help, or if you need hints, you can post here. You can share, discuss your approach for a problem. You can share your code. So it's okay with sharing the code this time. So you can share your code, and you can work with other community members to figure out the shortest or the most efficient solution. And you can also help others fix their errors and improve their solutions. Please do that. That's a great exercise. I think that will give you enough for at least a week to keep you busy almost on a daily basis. So those are the exercises, the required assignment, and then the optional 100 NumPy exercises. All right. So with that, we complete our discussion of NumPy, and I want to cover another topic here since we have some time. So we've looked at how to use NumPy, and we've also seen briefly how NumPy works with files, but it is also a useful thing to know how to work with files and the operating system, interact with the operating system in general using pure Python. Okay. And that is where we are going to use this other notebook called Working with Operating System and Files. So I'm just going to click the run button here and click run on Binder to run this notebook. And we'll see how to work with files in Python. All right, so the notebook is loaded up now. So let me just hide the header and the toolbar and restart and clear the output here so that we can do things from scratch. Okay. So just as we've learned about the NumPy library, the NumPy module, we've seen a bunch of other modules like the math module. There is a module called OS, short for operating system, which provides many functions for interacting with the operating system as well as the file system, which is basically your hard disk and all the files that exist on it. So let's try it out. So first we are going to import OS. And then we can, so the simplest thing that you can do with OS is to just check what is the current working directory that we are in. So right now we are running on Binder, and this Jupyter notebook is actually running inside a particular directory. So to check the directory, we just say get cwd, and you can see that it is running in a directory called /home/Jovian with a Y. Okay. Then the next thing that you might want to do is you might want to get the list of files in a directory. So to do that, you can use the list dir function, and to it you can pass either an absolute path, so all the way from the root, or you can also pass a relative path. So here we do and you can check the help. So it has a bunch of different things, and it can, so it gives you a bunch of explanation about it. But if you just do os.listdir dot, so this is the relative path, dot refers to the current directory. So you can see that in the current directory, this is our Jupyter notebook. And then there seem to be a bunch of other files and folders. A lot of these have a dot in the beginning. So that means they are hidden files. That's why they don't show up when you do something like file open, because they are hidden files. And then there is, and you can also check an absolute path. So if we check like the /user directly /usr, you can see here that it has all of these subdirectories. And then you can navigate. So you can say os.listdir and pass in, let's say /us user/lib. And then you can probably go inside it and navigate around. And so this is so just within Jupyter, using Python itself, you can browse around the file system. You can also create new files and new directories. So let's see how to create a directory. The way to create a directory is using the os.makeDirs function. And let's create a new directory called data, where we will later download some files. So in the current directory, so dot refers to the current directory, we will create a new directory called data. And then we have this exists okay equal to true. Try using the help function or try reading the documentation to understand what it does. Okay, so now we've created a directory called data, and we can verify this. There are a couple of ways to do this. If we just do file open, and you can see here that a data directory got created, but I don't really even need to do that. I can just do os.listdir dot, and since that returns a list, and that's a nice thing, since that returns a Python list, you can simply check if data exists in that Python list, and that returns true. And inside the data directory, so if you do os.listdir dot/data, you can see that directory is currently empty, as we might expect. So now let us download some files into the data directory. And again, we are going to use the urllib module to do this. So here are 3 URLs for files, and we are going to import urllib.request. This is the module which contains the URL retrieve function. So we are taking the first URL and we are going to download it to dot/data/loans1.txt. And similarly, we are going to retrieve and download the other 2 files as well. So now we have downloaded 3 files inside the data directory. So you can see now the data directory contains 3 files, loans1, loans2, and loans3. Okay. Now to read the contents of a file, we first need to open it. And to open it in Python, there is a built-in function called open. Now the open function takes a path, and then it takes a mode in which to open the file. Do you want to open the file for reading, or do you want to open the file for writing? And if you want to open it for writing, do you want to replace the existing contents, or do you want to append to the end? So there are a bunch of modes, and you can see here. And then there's also something called a binary mode, and the binary mode is for non-text files. Let's say you're working with images, or you're working with some kind of file which cannot be read as text. So that's when you can use the binary mode. The open function, when we call it, that returns what is called a file object, or sometimes also called a file pointer. And the file object contains several methods for interacting with the contents of the file. So you may not just want to, you don't always need to just read the content. Sometimes you may want to do other things as well. So that's why you have the entire file object available to you. So now to get the contents of the file, we take the file object, file1, and then we call .read on it. So when we call file1 contents .read, and then we can get the entire contents of the file into a single string. So this becomes a string, and we can use a print function to print the file contents. And just for you to see that it is a string, I'm just going to output file contents here. And you can see that this is a string, that this contains a bunch of data, and then this contains some new line characters. So when we pass it into the print functions, it just prints it nicely. It prints the new line characters or new lines and so on. Okay. So this is what the file contains. And actually, if you remember the previous lecture, in the previous lecture, we were talking about loans, about people taking a home loan with a certain amount for a certain duration of time. Let's say a duration, let's say somebody is borrowing $100,000. Somebody is buying a house worth $100,000, and they are taking a loan which lasts 36 months, and they're taking it at 8% per annum. And then they're also doing a down payment of $20,000, right? So the actual loan amount is only $80,000. So they're taking $80,000 in loan, for 36 months at 8% per annum. And then we had a function to calculate the equal monthly installment. So for this, I will refer you back to the previous lecture 2 or lesson 2, where we had a discussion about functions. So this represents the information for one loan, and then you have information about other loans. So each line represents information about one loan, right? And then the first row tells you what these numbers mean. So the first number means amount, the second number means duration, the third number means rate, and the fourth number means down payment. And you will notice that in some cases there is no down payment here. So that's why it is empty. Okay. And once again, this is the CSV, or the comma separated value format. So we've read the file, we've seen its contents, and when we are done with a file, or when we've read something from a file already and we are done with it, it is important to close the file, because especially with larger files, what happens is that when you open a file, that file is put into the system RAM or memory. So if you keep opening files but you don't close them, then that will eat up your RAM and that might slow things down for you. So you remember to close the file, and once a file is closed, it can no longer be read, right? So I've closed the file, so now we get that the IO operation on the closed file is not valid. Okay, so let's now try and process the CSV file. Okay, but before we do that, because we always need to open a file, so whenever we open a file, we always need to close it as well. So the Python has some special syntax for it. So there is something called a with statement. Now this with statement is used for a lot of things, but one most common use case is with open. So you say with open, and then you have the open statement, and you can also have a mode here. By default, the mode is a read mode. And then you say as file, or whatever variable name you want to give to the file object. So with open loans2 as file2, we get file2 contents, and we read the contents, and we simply print the contents. So we put a bunch of code inside a block. So we indent it a little bit. So that puts it in a block. And what that does is, after running this code, it automatically closes the file. So we've done all this with file2, and we've never called file2.close. And if we try to invoke file2.read outside the with statement, you will see that it leads to an error. Yeah, so it leads to an error, IO operation on a closed file. Okay, so that's that. But now the next thing that we want to look at is how to read a file line by line. So sometimes you may not want to read the entire file at once, but you may want to read different lines. So here we are opening the file loans3 as file3, and then instead of calling read, we are calling read lines. And when we call read lines, then each line is a separate string, and you get a list of strings. So each element of the list is a line. Now one important thing to note here though is that here there is this new line character at the end of every line, which you may not want. So the way to skip the new line character is that you might want to then go to file3 underscore lines. Let's say I get this particular line, it has the new line character, and I can just call strip. And when we call strip, what that does is that removes the new line character. So strip is used to remove spaces at the beginning, spaces at the end, and new line characters. Okay. And it's especially useful when you're using read lines. So whenever you call read lines, remember to use strip to remove the new line character. Okay. So now we've seen how to get information out of files into a string, but we might want to go further. And in the NumPy tutorial, we just directly used NumPy gen from txt. But for this particular file, we cannot use that because these numbers, sometimes not all the values may be numbers. You may have a combination of strings and numbers, and that causes a problem. But sometimes, as in this case, values may be missing, right? You may have to account for missing values. So for example, if we check this file2, you can see that down payment is present for the first loan, but there is no down payment for the second loan. And there is no down payment for the fourth loan. And now if you try to read it directly using NumPy, this might be difficult. So this is where now we have to do some custom processing. So here's what we can do. Okay. So we will read the file line by line, and then we will parse the first line to get the list of column names or headers. Then we will split each remaining line. We will split each remaining line and convert each value into a float. So maybe let's also try and do that step by step. So here is, let's say, let's get the contents of file 2. So we have the contents of file 2. Let's print it. Okay. So we will first read the first line, the headers, and from here we will get the names of all the columns, all the data, names of all the different fields in our data, which is the amount, duration, rate of interest, and down payment. Then each line, so a line like this, we will take this line and we will split it into the different parts that it has. So this can be done just by calling split with a comma. So here we get back a list of all the values. Then we will convert each of these values into a float, because these are actually numbers ultimately. And we will also have to handle a special case where there is no value for down payment. Then what we'll do is we'll actually convert this into a dictionary. We want to take this line and then we want to write it like this. So we want to say amount is 828400. Then we want to say duration is 120. Then we want to say rate is 0.11, and then down payment is 100,000. Okay. And that becomes basically our loan 1. So now we've created a loan object, and this is a much nicer thing to look at. We know exactly what's going on here. We've created a loan dictionary. So we will we'll create a dictionary for each loan, and we'll use the headers as keys. So these same headers that we saw here are getting used as keys, and the values are just the values that we passed from the line and converted into numbers. Okay. Then finally, what we will do is we will create a list of dictionaries to keep track of all the loans. So this is loan number 1. Similarly, you will have loan number 2. So all the loans together can be tracked in a dictionary. So let me just put this on one line. So this is loan 1, and then I might take loan 1, and then I might create loan 2, and then I might create loan 3, and so on. So this one, the data for this loan will come here, and then the data for this loan will come here. What we want to do is we want to parse the file into a list of dictionaries, which is a lot nicer to work with. That now we have our own Python data structures, and we can write functions and perform calculations on these Python data structures. Another thing as an exercise you can try is, instead of converting it into a list of dictionaries, try converting it into a NumPy array. Okay. Anyway, so this is what we want to do. Now, whenever you have a target like this, you know where you are, like you have the lines from a file, and where you want to get to. You want to get to a list of dictionaries. So it helps to first list out the process, what is the step-by-step process, and then it helps to create a small helper function for each of these steps. So we'll have a read CSV function which performs all of these things, but we will also define some helper functions to build up the functionality step by step. Okay. First of all, let us start by defining the parse header function. So it takes a header line, which is the first line of the file, and it simply strips it. So stripping removes any new line characters, any spaces at the beginning or at the end, and then it splits it at the and when we call split on comma. Okay, this is a very simple function. So this is the header line, amount, duration, rate, down payment, new line, comma separated. We call parse headers on this line from file3_lines, which we just read previously. So remember, file3_lines came in here. So let's just take that here as well. Yeah, so file3_lines came in here. So now we check the headers, and it looks like we now have the headers amount, duration, rate, and down payment and in a list. Okay, great. Next, going forward, let us define a function parse values. So which takes a data line as an argument. So something like this. So this is a data line, file3 lines 2. So it has the amount, duration, rate, down payment, new line, and it returns a list of floating point numbers. Okay. So how does it do that? It creates an array of values, then it goes through the data line, and then it strips each line, and then it splits the data line into an array. So if we take this data line, so let's say we take file3 lines 2 as our data line, and then we call strip, and then we split it. Then we get back 453230, 48, 0.07, 4300, and the new line is gone. Okay, so now we have a list. So now we go over each item in the list, and then we convert that item into a float, and then we append it to values. All right, so we take each of these items, convert it into a float, and then put it back into this values array, and then we return the values. So let's try it out. Let's call parse values on this line. So this line takes 45230, 48, 0.07, 4300. Now you can see that all of these are converted into floats. Okay, so now we have parse headers and we have parse values. Let's try it for another line from the file. This line does not have a down payment. So here it has amount, duration, a rate of interest, but there's no down payment. And if we call it here, you will see that here you will get a value error. Here you will get an error. So you might want to explore why an error showed up. So here it says it could not convert a string to a float. Okay, that's interesting. So let's check what string it could not convert into a float. So if you go back up, you will see that on values.append, there was an issue when we are calling float on item. That seems to be the issue. So let's go back. Let's go through the file here. Let's go through the line that we are working with. So let's take this line and let us strip it and let us split it on comma. And we can see here we have 3 numbers, but then because there is no down payment, we have the empty string, and the empty string cannot be converted to a float. So you can just try it here. So I am inserting a new cell and pasting the empty string, and that leads to us through the same value error. Okay. So this is how you narrow down an error in Python. So you can simply find out which line the error is on, read through the error, and then inspect. Okay, we were going through a list, so let me just print out the list. So I just printed out the list here, and then I noticed that, okay, it seems like there is an empty element. Maybe I failed to convert that into a float. So let me try converting that into a float, and it seems like that gives me the same error. Okay. So all said and done, now what we know is that we need to handle this empty string in a special fashion. So this is also called an edge case, because this is not something that comes up always. So a function can work properly without an edge case, but sometimes it might give an error. Okay. So this is what we do now, that once again we iterate through the data line, which is then stripped and which has been split. And if the item is the empty string, then we append the value 0. So we say that if the down payment or whatever is empty, then we simply use the value 0 in its place. So this is called handling missing values, and we'll see it in the future as well using pandas, how to handle it. And if it does have a value, then we simply convert it to a float. Okay, so now we have parse values, and here we have, so now we see file 3 lines 1. This does not have a down payment, and now we call parse values on it, and we can see that all the values got parsed properly and a 0 got inserted for the down payment. Okay, so now we've done one more step. We've parsed the header, we've parsed the values. Now we can create a dictionary of the data. So here what we can do is, to the dictionary we can give a list of values, we can give a list of headers, and I will let you figure out what is happening inside this function. But the idea is it takes, and we've also already seen the zip function, but you can see an example of the zip function here as well. But the idea is that it takes this. So this is the bunch of, this is a line, and I'm taking this line and converting it into a set of values. So let's see values 1. So here are a set of values from a line of the loan, and we also have the headers. So here are the headers. So create item dict takes the values, takes the headers, and returns this dictionary. Okay, so for each loan we are going to get back a dictionary. And then finally, here's another example. So for a different loan or different line of data, we are getting back a different dictionary. All right, so now we have create item dict as well. So now we have been able to parse the header line, we've been able to parse values, and we are able to convert the values and headers together into a dictionary. So now we can write a read CSV function. Again, we'll just briefly go over it, and then you can read it in more detail. So the read CSV function takes a path, the path to the CSV file that you want to read, and it creates a result list. So first it opens the file in read mode as F. So F is your file object or file pointer. then it gets the list of lines. So we call f.readLines, and that gives us the list of lines. Then it parses the header. So it calls parse headers on line 0. So remember, the first line, the 0th line, will contain the headers. So that will give us the list of headers. Then it loops over all the remaining lines. So if you see an example here, it is then going to pick each line one by one. And then for each line, but we're only checking the remaining lines, right? So that's why we have this 1 colon here, because we want to skip the header row. We've already parsed the header. Then it parses the values. So it takes this line and converts each of these into floating point numbers. Then it takes the values and it takes the headers and it creates an item dictionary. So that creates a dictionary, and then it takes that dictionary and appends it to the result, which is an array, which is a list where we are keeping track of all the dictionaries. Okay. So that's our read CSV function, and let's try it out. So this is our loans2 file. And if we call read CSV on loans2, so looks like we've gotten a list of dictionaries, and you can verify that these values match these values. All right. So that's it. So that is how you read and process a file using just plain Python. So you use the open command and you use the open function, and then you can read lines, and then for each line you can do some processing, and the processing does not have to be this complicated. Instead of creating an entire dictionary, you could simply have just created, let's say, a list of the values, and then you could have taken the list of values and just converted them into a NumPy array. That is another way to do it, but this is just, I wanted to show you something different. Okay. Now, the one interesting thing to notice here is that this read CSV function that we have defined, this is actually generic enough that this can parse any CSV format, not just this specific format of home loans, right? So it can have a CSV file with any number of rows and any number of columns, and it can also handle missing values. In just about 15-20 lines of code, we've written a pretty powerful function that can be pretty helpful. And what you should do is, over time, you should start building a repository of your own functions. Maybe you should just keep a Python file somewhere on your GitHub or just on your computer where you list out all the interesting functions that you have made. Okay. So that's that. Now, what we can do is we can now do some processing. So we have this list of loans, and we can do some processing on this list of loans. And for doing the processing, once again, I will refer you back to the previous lecture 2 on functions, where we defined a function called loan EMI that takes the amount for a loan, the duration, the rate of interest, and a down payment. And it performs a calculation and returns the equal monthly installment for the repayment of the loan. And this we've covered in a lot of detail in the previous lecture. So please refer to lesson 2 and refer to the part on functions. Okay, so what we want to do now is we have this function that operates on a single loan, and then we have a list of loans. Now we can work on this and use this function to calculate the equal monthly installment for each of the loans in that list. Okay, so here we read the CSV file loans2, and now we have loans2, which is a list of loans. Now what we can do is we can say for loan in loans2. So just iterate over each of the loans once we get a loan. So since each loan is a dictionary, we can add a new key within the dictionary called EMI. And here we can the EMI is calculated as using the loan EMI function, and we just need to pass in the amount, we pass in the duration, we pass in the rate of interest, and we divide the rate of interest by 12 because for the equal monthly installment, we need the monthly rate of interest, and what we have in the CSV file is the annual rate of interest. And finally, we have the down payment. So we take all of these, and now you can see that loans2 contains not just the amount, duration, rate, but it also contains the EMI, right? So just in a single for loop, we have now calculated EMIs for all the loans. And we can actually take that and now put that into a function so that you can read from any file a list of loans, and then you can pass it into the compute EMIs function, and that will add the EMI inside those loans. Okay. So great. So now we have defined functions to compute the EMI. So let us now take this function and use that to first read some loans from a file, compute EMIs for those loans, and then print out and then print out these EMIs along with the original data back to a file. Okay. So first we read the CSV loans to, we compute the EMIs, and then now we have loans to with the EMIs. Now we want to write it back to a file. To write to a file, we open with the W mode. So we are going to write to the file ./data/emis2.txt. So for loans to, we have emis2, and we are going to open it in W or write mode. So in write mode, if the file exists, or if it does not exist, it gets created. If it exists, then the data gets wiped out and we write fresh. Then we iterate over the loans in loans2, and then we simply call f.read. So f.read is to read information from the file, f.write is to write information to the file. So to write to f. We need to provide a string. So here we are going to use the string formatting notation. So in the string we have 1, 2, 3, 4, 5 gaps, and then each of these. So here we will insert the loan amount, we will insert the loan duration, we will insert the loan rate, we will insert the down payment, and we will insert the EMI. Okay. And then we will separate them with commas, and we will include a new line character. Okay. So this will make sure that one loan is written to one line along with the EMI. So there you go. Now we have just written to the EMIs file. And if we check now the data directory, you will find that apart from the 3 loans files, now it has an EMIs file, emis2.txt, and we can read the data back from that file. So you can see emis2.txt has the loan information, and at the end it also has the EMI. Okay. So as with everything else, every time we implement some interesting logic like this, it's a good idea to write a function. So let's convert that into a write CSV function. So just as we had the read CSV, which takes in a file and returns a list of dictionaries, we are now writing the write CSV function, which takes in a list of dictionaries and a path, and then it writes it to that path. Okay. So I'll let you go over this function. It does the same thing that we have already looked at here, except that it will also add a header line. So I'll let you figure that out by just going through that function step by step, and let's try it out. So we have loans 3, we read loans 3, and then we compute the EMIs for loans 3, and then we write it back. And you can see here we have created emis3.txt, which contains the amount, duration, rate, down payment, and EMI. And if you want to do it for all the different files that we have, so we have loans1, loans2, loans3.txt. We want to compute the EMI. So what we can do is we can iterate I in the range 1 to 4. So that will take, I will take the values 1, 2, and 3, and we can call read CSV on each of these. So when we use the string formatting, we will read loans1.txt, then loans2.txt, then loans3.txt, and that will, and each of these loans we can compute the EMIs. So we can insert using the data that is already present, we can insert the EMI key using the loan EMI function, and then we can write that back into a EMIs file. So loans1 goes to emis1.txt, loans2 goes to emis2, and loans3 goes to emis3. And yeah, and that's it. So now once we have all of these functions in place, we can read each downloaded file, calculate the EMIs, and write the results back to new files. And now we just check os.cir, and you can see here that we have loans1, loans2, loans3, and then we have emis1, emis2, and emis3. Okay. So that is how you read from and write to files using Python, and always try to create functions for whatever you do. And then you'll start to see the real power of a programming language like Python for processing large amounts of data. Okay. So that completes our discussion of working with files. So I'm just going to save my notebook here, commit it to Jovian. So we copy the API key and paste it here. All right. So that's, and that's pretty much what it is. And I've also linked to some other resources here. So you can just look through these other resources to learn more about working with files in Python. So the topic is analyzing tabular data with pandas, which is one of the libraries that we are exploring in this journey towards data analysis. So let's get started. So the first thing you should do is go to the course page 0topandas.com, And on the course page, if you haven't enrolled already, you will be able to enroll to be able to watch the lectures and submit the assignments. And if you're already enrolled, you can share this course with your friends and colleagues. So here you see assignment 1. You can open it and follow the instructions to get started. It should only take about an hour to complete. Putting that aside, so you can find the videos from the previous lessons. So lessons 1, 2, 3 here on the specific sections, and also assignment 2. But today we are looking at lesson 4, analyzing tabular data with pandas. So we just click the open link here and that will bring you to the lesson page. Here you will be able to see the lesson video. You can watch it live or you can watch a recording later. So the notebook that we are going to use today is called Analyzing Tabular Data with Pandas. So you can click through and open this notebook. So this is a notebook, a Jupyter notebook hosted on the Jovian.ml platform, just as we've been using this for other lectures. And the first thing you should do, and please don't do it right now. Right now you can just watch the lecture, but later on you can click run and click run on Binder. And when you do this, we will take this notebook and run it on an online platform called Binder Hub. And it might take a few minutes to start up for you, but please wait for a few minutes and it should start up just fine. And if you have questions during the lesson right now or afterwards, you can ask questions on the discussion forum. So the link is provided here. You will find the discussion forum here, lecture 4, analyzing tabular data with pandas, on the Jovian.ml forum. And you can simply hit the reply button. So there is a blue reply button you will find at the bottom. You can simply ask a question here. And if you see a question that you like, that you also have, you can click the like button and we will pick the questions that are the most liked and answer them during the session. So going back to the lecture notebook, I have clicked the run button and I have selected run on Binder. And now that has opened up this Jupyter notebook interface. This is where we will be doing all of our coding and we will be executing the code. So I'm just going to open up this specific notebook, Python Pandas data analysis. And the first thing that I like to do just before starting any tutorial from an existing Jupyter notebook is to go kernel, restart and clear output. So this clears all the outputs so that we can now execute the cells, execute the code and view the outputs from scratch. And I will also do a view toggle header and view toggle toolbar so that you can see things a little better. But you can keep the toolbar around. It has many useful functions. Okay. So as we've been going along this journey, we've done a lot of things. We've learned some basics of Python and Jupyter. We've also done a quick tour of variables and data types in Python. And then we looked at branching using conditional statements and loops. And all of these, you got a chance to try them out in the first assignment. Then we looked at writing reusable code using functions, reading and writing from files, and numerical computing with Numpy. Now, all of these topics are available in the previous lectures, so you can go watch these videos. And you can also test out your skills after watching these videos by doing the assignments. Today, we are looking at analyzing tabular data with pandas. Now, we are running this code on an online platform, Binder Hub, and that is why we use the run button on Jovian. But you can also run this on your computer locally, and the instructions are given here. The instructions might vary slightly based on your operating system and the version of Python that you're using, but you should be able to follow along with this quite easily. Okay, so pandas is typically used for working with tabular data. And when I say tabular data, you can think of the data stored in a spreadsheet or in a database table. And the first thing that you might want to do is to actually read a data file into the Jupyter notebook using pandas. And pandas provides many helper functions to read data from various file formats like CSVs, Excel, spreadsheets, HTML, JSON, and many more. But the most common format by far what I've seen is the CSV format. So let's download a file, Italy COVID daywise.csv, which contains the day-wise COVID data for Italy in this format. And we're using COVID data because this is something like we are right now in the middle of a pandemic, and it is a real tragedy. And there is a lot of information floating around. Some of it is right and some of it is just wrong. So what I wanted to help you with is to look at the raw data, analyze the raw data and make your own inferences, and also know what are the shortcomings in the raw data. any headline that you read or any metric that you see, you should be taking it with a grain of salt and trying to verify it on your own. If you're suffering from the coronavirus or know somebody who is, our best wishes are with you. So this is the format, and we have the data for Italy here. So let's download the file and we will look at it. So to download a file, we will be using the URL retrieve function from the urllib.request module. So this is the urllib.request module, and from it we import URL retrieve. And this is the URL from where you can download the file. So we pass the URL and then we also pass a file name where we want to download the file. So we want to download it into the current directory with the name Italy COVID device.csv. So let's run it now. And the file has been downloaded. Now, if you want to see the downloaded file, you can click File, Open, and you will be able to see here that earlier we did not have Italy COVID device, but now we have it. Let's give it a second to show the file. Okay, so while it loads, the format of the file is something like this. So the first row the first line contains headers or column names. So we have the date, we have new cases, new deaths, and new tests. And then we have day-wise data. So this is, each line represents the data for one day. So this starts from, let's say, the 21st of April. The number of new cases was 2,256. The number of new deaths was 454, and the number of new tests was 28,095. And this is the format in which you have the data for a bunch of different days. Okay, this file is loaded. So you can see here, date, new cases, new deaths, and new tests. And then you have the data starting from the 31st of December and day-wise data going all the way up to the 3rd of September. So just a couple of days ago. And this is only the new cases and deaths and tests daily for Italy. Okay. And this is called the comma separated value format because the values are separated by commas. All right. So to read this file, we can use the read CSV method from Pandas, and it's a really simple method. So before that, we need to import Pandas, and the Pandas library by convention is typically imported using the alias PD, so that you do not have to write Pandas each time. So once you've imported Pandas as PD, then you can create, we call pd.readcsv, and then pass in the file name or the full file path, and that returns what we call a data frame. So that's why we're calling it COVID_df. So df is a suffix just indicating that this is a data frame. And data frame is, so the data from the file is read and stored in a data frame object, which is the core data structure in Pandas for storing and working with tabular data. Now we typically use the df suffix to identify data frames, but you don't have to. And if you check the type of COVID_df, it has the type pandas.core.frame. So this is the module where this class lives, and it is an object of the type of the class data frame. And let's take a look at this data frame. What exactly does it look like? So once we run this cell, we see that it looks like a table. So very much like a database table or a spreadsheet, and looks like there are some columns, the same columns that we just saw, and there are some rows. And there seem to be 248 rows and 4 columns. And as we've seen, this provides 4 day-wise counts, and the metrics reported are new cases, deaths, and tests. And the data is provided for 248 days from December 12th to September 3rd. Now, one thing to keep in mind is that these are officially reported numbers, and it's possible that the actual number of cases and deaths may be far higher, because not all cases are diagnosed and not all cases are reported. So you should not take this information to assume that we have a full list of all the cases. And now we can view some basic information about the data frame using the info method. So if you call coviddf.info, we will get some information like the list of columns. So the columns are, as we've seen already, date, new cases, deaths, and tests on a daily basis. And it seems if you just see the non-null counts, then there are 248 values each for the first 3 columns, but new tests, there seem to be some null values. If you see here, you will see nan, and this nan indicates that there was no value provided in the file for that specific on that specific date for this specific column. And it's different from 0 because 0 indicates that the value 0 was provided. So that's an important distinction. So that's some basic information, and you can see that it has, you see the number of entries, you can see the data types that are available. Now the date column seems to have the object data type. So object is a generic data type whenever pandas cannot really figure out what type of data is there in a particular column. And the rest of them, it has figured out that these are floating point numbers. Now one other thing that you can do just to get a quick overview of the numeric data is to call the describe method. Now if you call coviddf.describe, for each of the numeric columns, cases, deaths and tests, you will get back the total count of non-null entries. You will get back the mean or the average. So it seems like the average number of cases per day was 1094. But if you check the standard deviation, it seems like the standard deviation is about 1500. So that means it's a very high deviation, and that's expected because this graph, initially it was close to 0. So during January, there were basically no cases on a daily basis, but during March, the caseload was really high, and then the caseload went down again. So that's why the standard deviation is very high. So the mean by itself is not very useful. And there are a few other metrics as well that you can look at. It seems like the maximum number of cases on a specific day was 6,557. That's pretty high. Now the column property of the data frame will contain the list of columns. So you can call coviddf.columns, and that will give you the list of columns in the data frame. And then you can also retrieve the number of rows and columns as a tuple using the shape method. So these are all different ways to get some meta information about the data frame. So we have looked at info, which is a basic information about rows, columns and data types. Then we have describe, which has statistical information about the numeric columns. Then we have columns to get the list of column names, and shape to get the number of rows and columns as a tuple. Apart from that, we've seen how to read data from a CSV, but apart from read CSV, you have read SQL files, you can read Excel files, you can read JSON files, and a lot many different formats. Okay. So before we move forward, let us save our notebook, because we are running this on an online platform, Binder, and this, if you leave this tab idle for some time, this Jupyter notebook may shut down and you may lose your work. So I'm just going to install the Jovian Python library, and then I'm going to import it and run jovian.commit. And what this does is this asks me for an API key, which I can get from my Jovian profile after logging in. And after logging in, I can copy my API key by clicking the API key button here, and then I can paste it here and hit enter. What this does is this captures this notebook running on Binder, and this takes a snapshot and it puts this snapshot on my Jovian profile so that I can access, I don't lose my work even if this server shuts down. And later what you can do is you can come back and you can run on Binder again from this notebook on your profile. So every time you do some significant work, just keep committing your notebook to Jovian. Okay, so moving right ahead. So now the first thing that we might want to do once we have loaded up this data, the coviddf data frame, is to retrieve some of the data from this data frame. So for instance, we might want to know what is the count of new cases on a specific day, let's say the 4th of April. Right? So a specific value within a specific column and a row. Now to do this, it might help to understand what the internal representation of data in a data frame looks like. So conceptually, you can think of a data frame as a dictionary of lists. So you can think of a data frame as having a structure like this, that the coviddf data frame is similar in structure to this COVID data dict, which is a dictionary. And then this dictionary contains the keys. The keys are the names of the columns, column headers. And then the values of those keys are lists or arrays containing the values in those columns. So it's a little bit flipped from what you might be used to, but this analogy is helpful to think about pandas data frames. Now, obviously it is not an actual dictionary, and inside it you do not have actual arrays, because internally pandas is implemented in C++ using a bunch of other libraries. So it uses some other internal data structures, but this is the conceptual picture that you should have in mind. Now, representing this data in this format has a few benefits, and that is why pandas does it. Now, the one thing is that all the values in the column typically have the same type of the same data type. So it's more efficient to store them in a single array. That's one thing. The second thing is that retrieving the values for a particular row. Let's say we want to know what were the values in the fourth row. So we simply can fetch the fourth element from each column. So that is simply an array indexing, which is very efficient, especially when the data types are all the same. So that's a very efficient operation. So fetching the information for a row becomes very efficient. And then finally, the representation is a more compact compared to other formats. So another format that you can think of is that we actually use a list of dictionaries where we have a list, and then inside each list, each row is represented as a dictionary, which contains the date, new cases, new deaths, and new tests. Now this will take up a lot more space because we are repeating the column names for every single row. And this will also not be as performant. On the other hand, this takes up far less space and is a lot more performant. All right. So keep this picture in mind as we try to retrieve data from this pandas data frame. I personally struggled a lot initially because I did not see this picture, and I would often wonder how exactly do you get data out of a data frame. Okay. And so this is not the picture that you should have. This is not how pandas stores it. And this is the format how pandas actually stores data, conceptually at least. Okay, so now with this analogy in mind, we can now guess how we might be able to retrieve data from the data frame. So the first thing that we might be able to do is, let's see the data frame once again. So this is the data frame here. So the first thing that we might be able to do for the data dictionary that we created for the analogy, we know that the keys are column names. So accessing a key using the indexing notation gives us all the values, all the list of values in a column. So we can do the same here. We can index into COVID DF for new cases. And you see here, you can see that we have all the values. So starting with a bunch of zeros and going down to these numbers, and you can verify that these numbers match with the numbers shown here. So we have been able to retrieve a full list of values in a particular column. Okay. And now each column is actually, it's not really a list or an array, but each column is represented using a data structure called a series, which is essentially a Numpy array, but it has some extra methods and properties associated with it. So if you check the type of COVID DF new cases, you will find that it has the type series. And just like arrays, you can retrieve a specific value within the series using the indexing notation. So this gives us a series, and then out of the series we can get the value at the 246th index. So you can see that it has a specific index that is listed here. So 246 is the value is 975. So there you go, you get the value 975. And similarly, if you go in, let's say 243, you will get the value for new tests, you will get the value 53541. Again, we can verify this by going up. So 243, you can see that the data for new tests is 53541. All right. So that's how you can dig in. You can go find a column using the index, and then you can index into the column. So which is a series, you can index into it by passing the index of the row now that you want to access. Okay. Now this is a little bit inconvenient. So pandas also provides a helpful @ method. And the @ method can be used to directly retrieve the value at a specific row and column. Okay, so you can simply say covid.at. Now here you need to specify the row first, which can sometimes feel more natural. So at the row 246, and then the column is new cases, and you get back the same value 975. And we can check at the row 243 and new tests, and we get back the same value 53,541. Okay. So instead of using the indexing notation, apart from what we've seen already, pandas also allows accessing columns as properties of the data frame using the dot notation. So here what you can also do is you can say COVID DF instead of saying COVID DF. So this is the same as saying COVID DF and then using the indexing notation. Instead of doing that, you can simply say COVID DF dot new cases. So this is a slightly easier to write. It saves you a few keystrokes, and it also, what you can also do is you can just type COVID DF dot and then start typing N and press the tab character, and that will auto complete the column names for you. So this is a good way to just explore the columns and other properties of a data frame. So that's one other way to access a column. Apart from that, what you can also do if you want to access multiple columns together, so you can pass in, instead of a single column, you can pass in a list of columns into the indexing notation to access like what is called a subset of the data frame with just the given columns. So here, notice this double bracket here. So the first bracket is for the indexing notation. And now instead of saying just a single date, we can simply pass in a full list of columns, and passing in that list of columns is going to give us a smaller data frame with just those columns. So now we have the date and we have the new cases right here. Okay. Now, one thing to note here is that this cases data frame, the data frame that we just created right now, it is simply a view of the original data frame. So that means they both point to the same data. So if you were to somehow modify the information here at this location, or you were to modify it in the original data frame, so modifying in one would make the change in the other one as well, because they're pointing to the same data in memory. And this is a very important thing to understand, because this is what makes pandas really fast, especially when you're working with tens of thousands or millions of rows of data. So pandas you can keep creating new data frames, you can keep generating new columns, you can keep processing this data without having to worry about repeatedly copying the data over and over. So that is slow and that takes up a lot of memory, but you do not need to worry about it at all. But the downside of that is if you change something inside one data frame, all the other data frames which are derived from it will also change. However, in the cases where you do need a full copy, and you normally don't, but in case you do need a full copy, all you need to do is just call the copy method. So if I create COVID-df copy as COVID-df.copy, then the data stored within this new data frame is completely separate from the COVID-df data frame. So modifying the values inside one will not affect another. All right. So to access a specific row, we've looked at how to access columns. We've looked at how to access specific elements, but to access a specific row, you can use the .loc method. So the .loc method actually requires indexing. So here we have the data frame once again, and let us try to access this row of data. So you need to pass in this index 243 into .loc. So notice it's not a method. It's more of, you need to use the indexing notation here. So we say COVID-df.loc, pass in 243, and then we get back new cases, new deaths, and new tests. And you can verify that this data matches what we see here. And each retrieved row is also a series object. So this is also a series, just like each retrieved column. So that's about getting a single row, but then you can also get multiple rows out of the data, and sometimes it might help to just look at just the first 5 or 10 rows, or maybe just the last 5 or 10 rows. Then to get the first few rows, you simply use the head method. So here we are trying to get the first 5 rows. You can see these are the first 5 rows, the first few days of January, and then you can also see the last few rows. So you can use tail for that. And here you can see the data for the last few days of August and then the first few days of September. All right. Now, one thing you might notice here is, and this is something that we mentioned earlier, is that some values are 0 and some values are nan. And how do you check? No, the reason this happens is because this column does not have any information in the data file. So if we open up the data file again, so this is the file italycovid.daywise.txt. And if you check here that initially there are only 2 numbers available. So you have the date, new cases, new deaths, but there's no data available for new tests. All right. And then after a few days, after about 2 or 3 months, you start seeing data for new tests. This is an important thing to understand. And so what Pandas does, whenever it does not find a value within a CSV file or any other file, whenever it sees a blank value, it inserts the nan value there. So you can just check it out. So if we just try to access the 0th row, or we try to access this last element here, so row 0 and column new tests, you can see that the value is nan. And if you check its type, it's actually a floating point number. So it's a floating point number, but it is not really a number. It is, in fact, nan stands for not a number. So whenever and it is different from 0, and that's an important distinction to understand, that in this data set, it represents that the daily test numbers were not reported on specific dates. And that is why you have the number nan here. And if you look it up online, you will find that Italy started sharing or reporting daily tests only after April 19th, 2020. And before that time, 935,310 tests had already been conducted. So this is some additional information that is not present in the CSV. And this is something that we should know beforehand. while we are performing any operations, so that we account for this as well. Okay. So when you see a bunch of nans in a column, for instance, the column like new tests, the first thing that you might want to do is just identify where do the first valid indices begin. So you can check that by simply getting the series. So COVID-df.new tests and calling a dot first valid index on the series. And here it tells you that the first valid index is 111. And now once you've gotten the first valid index, it might help to look at a few rows before and after this index, just to verify that the values are indeed changing from NaN to the actual numbers. If we call COVID-df.loc with 108 to 113, so now we see a range of rows instead of a single row. And you can see here that around 19th April was the last day when there were no daily tests reported. And then from the 20th of April, we started seeing a daily test number. Okay. So that's about accessing rows of a data frame. Now, one last method I want to talk about is the sample method, which can be used to retrieve a random sample of rows from the data frame. So it's good to look at the first few, last few, maybe a slice in between. But what might really help to get a sense of the data, to see what kind of values are in there, is just to go through sample rows, randomly picked rows. And I often tend to do this 5 or 10 times with a sample size of 10 or 20, just to get a feel for the data and the feel for the range of numbers, see which ones have NaN values, which ones do not. And of course it's not perfect, but it is something just to get a visual understanding of the data. Okay. Now, one thing to also notice here is that while we get this sample out, you can see that the original indices of those rows are still retained. And that's a very useful thing. In fact, that makes pandas a lot more useful than just a NumPy array, where if you took a random sample, you wouldn't know where those elements came from. But here you also know that, okay, we've gotten the 151st element, and then we have the 88th element, and so on. So that when we want to refer back to the original data frame, we know what to do. All right. So that is how you can get data out of the data frame. You can get columns. So to retrieve columns, you use the indexing notation. You can get out of a series or out of a column, you can get values out by passing in the index. So a series is just like a NumPy array. And then if you want to just get it directly out of the data frame, just get a single value, you simply use the at method and give it an index of a row and a column. And if you want to create a copy, if you want to get a single row, you use the .loc method. The LOC method, again, you have to index into it. And then if you want to create a copy of a data frame, you use the copy method. And then you have the head, tail, and sample methods to retrieve multiple rows of data from a data frame. So the thing here that you need to understand is that whichever way you want to access data out of a pandas data frame, there is a way to do it. Now, you may not always remember this, and you don't have to, but you can always look it up. So suppose you want to figure out how do you access a particular row of a data frame. All you need to do is take this expression, or just type out this expression into a search engine, how to access a specific row from a data frame. And that will lead you either to the documentation or an answer somewhere on a site like Stack Overflow, where you can find the syntax. And that is a perfectly valid way of going about this, right? And as you keep doing this over time, you tend to start remembering some of these methods. But honestly, I still tend to look up a lot of these methods, even though I've been using pandas for many years now. So moving ahead, let us now start analyzing the data from the data frames. We've created the data frame, we've accessed some values, and let us try to answer some questions about our data. So the simplest questions you might want to ask once you have this data is, what is the total number of reported cases and reported deaths related to COVID-19 in Italy? And I say related because not all of these deaths may have been due to COVID-19 alone. In fact, in a lot of cases, there are comorbidities. So that's again another detail to keep in mind, that to say that the disease has killed that many people is not completely accurate, although it is definitely a contributing factor. And these are all these things when you're doing your data analysis with the raw data. These are all these things that you really understand, which are sometimes not conveyed, subtle details that are not conveyed in the headlines or the reports that you see. So now we have the COVID data frame, and out of which we get back the new cases, and then on the new cases we call .sum. So this is the dot sum method is similar to the dot sum method in NumPy, and you can call it on a series to get the sum of all the elements in that series or that column. So we will have the total cases and we get back the total deaths, and then we can simply print it out. So it seems like the total cases, number of reported cases is 271,515, and the total number of reported deaths is 35,497. So that's the data we have on Italy so far till about the first week of September. We might want to know, okay, what is the overall reported death rate, which is the ratio of reported deaths to reported cases. So that is simply the sum, the total number of deaths reported by the total number of cases. And you can see that is about 13%. Now that does not mean that 13% of people who contract the virus are going to suffer or die from it. In fact, the number is actually far lower, but we have to keep in mind the subtle detail here that not a lot of cases are actually asymptomatic, and then a lot of cases may never even get diagnosed because the person may not feel sick enough to actually come to the hospital, or they may come to the hospital and not find a test on a particular day. Then let's look at what is the overall number of tests conducted. And here we have to remember that daily test data was not being reported till a particular date, and a total of 935,310 tests were conducted before the daily test numbers were reported. So let us use that and let us incorporate that. So here we are saying that the initial tests were 900 was this number, and then so the total test becomes the initial tests plus COVID-DF dot new tests and dot sum, right? So this is the sum of all the data in the new tests column. And when we're taking a sum on a series, the nan values get ignored. This is just something to remember with pandas, that nan values will always get ignored and while aggregating. And then the initial tests, we are adding that. So that gives us the total number of tests, which is about 5.2 million. All right. Then we have, we might want to find out what fraction of tests returned a positive result. So it turns out that the positive rate of total cases by total tests, that was about 5.21%, right? So about 5.21% of the tests in Italy led to a positive diagnosis. Now this value may actually have varied month from month, and we are only looking at the overall value here. So this is how we can answer some basic questions about our data. Now at this point, you might want to try asking some more questions about the data, and you can use these empty cells to first, and this is how you actually go about analyzing a data set. The first thing you have to do before you even do any analysis or write some code is just to ask what are the questions you want to answer from the data. And I'm sure as you've seen this data, as you've looked at the things we are doing, you may have many other questions. So try them out here. And that's the best way to learn the pandas library as a whole and data analysis in general. And from time to time, I'm just committing and saving my work so that if this binder instance shuts down, I can resume my work by just clicking the run button from Jovian. Okay. So now let's look at querying and sorting rows of data. So let's say we want to only look at the days which had more than 1,000 reported cases, or we want to look at the days which had less than 100 cases, and we can have many other criteria like this. So to do that, what we can do is we can use a Boolean expression to check which rows satisfy this criterion, which is more than 1,000 reported cases. So for instance, we can say COVID-DF.new cases. So this is a series, or the column, which is a series, and we can simply use the expression greater than 1,000. And what this does is this creates a new series. Now this series has the same length as the original series or column, except that it now contains Boolean values, false and true. So the false here indicates that at that particular index, the value within COVID-DF.new cases was not greater than 1,000, was less than 1,000. So false is where the criteria was satisfied, and true is where false is where the criteria failed, and true is where the criteria was satisfied. So now what we can do is we can take the series of Booleans, the high new cases series, and we can pass that as an index into COVID-DF. So this is another way of just indexing COVID-DF, and then you use the index, and then you pass in this Boolean series. Now when you pass in this Boolean series, what happens is wherever there was a true, those rows are retained, and wherever it was false, those rows are skipped, right? So you get back a subset of rows Now these, you can see that there are only about 72 rows here, and this is basically another data frame, which is again a view of the original data frame. So here you can see that there are 72 rows, and in all of these rows, you can see that the number of new cases is higher than 1000. All right, so this is if the question was on how many days was the number of new cases higher than 1000, you now know that it is 72, and you can actually pull out a full list of dates as well by just accessing the date column of the data frame. Now we can also write this very succinctly on a single line by simply passing the Boolean expression, so COVID-df.new cases greater than 1000, as an index into the data frame. So this might seem confusing if you see it directly, COVID-df, and then it looks like inside the index you are once again using COVID-df. And it might feel a bit odd, but if you look at it this way, that this creates a series of Boolean expressions, and then that series is passed in as an index to filter out the rows which satisfy that expression. So that makes it a little more intuitive. And you can see here that you get back the same result, which is 72 rows and 4 columns. Now, although there are 72 rows here, we do not actually see 72 rows. What we see is 5 rows, and then we see these dots, and then we see then we see the 5 rows at the end. And Pandas does this because your data frames can have tens of thousands or even millions of rows. So it will really slow things down, especially on the browser, where if you print out the millions of rows. But in this case, sometimes we might want to look at all the rows of data. And when you do want to do that, there is some special syntax that you can use. So there is an option context method that you can use where you need to set the display of max rows to 100 and or whatever you want. So you can set the maximum number of rows to be displayed to, in this case, I'm setting it to 100. And then you have to use the display function from ipython.display. So these are just some details that the specifics are not important, but the idea here is that you can use this kind of a syntax to simply display all the rows of data. And once again, this is not something that you need to remember specifically. You can simply search it online, how to show all the rows, or sometimes even columns are truncated. So how to show all the columns of a data frame, and you will find some syntax like this. Okay. So here are all the 72 days where the number of cases was higher than 1000. Now we can also formulate more complex queries. So complex queries that involve multiple columns. Also often you may want to combine data from multiple columns to actually identify or create a criteria. So we already have a positive rate, which is the number of cases that out of the tests conducted, what percentage of or what fraction of cases turned out to be positive. So it was about 5.2% or 0.052. And now we might want to determine the days where the ratio of cases reported to tests conducted was higher than the overall positive rate. So you could interpret these as days where a lot of people got infected, or a high percentage of people got infected among the tests that were conducted. So the way we can do that is, once again, we have COVID-df, and then we pass in an index. So remember, whenever you're filtering out or querying something from a data frame, you have to use the indexing notation. And inside it, we have this expression. So we say COVID-df.new cases. So that's a column or a series divided by COVID-df.new tests. That is another series. So here we are dividing a series by a series. And as you might expect, that performs an element-wise division. So we get back a new series which contains the element-wise corresponding divisions. And so that is the kind of the daily positivity rate. And then when you check whether it is greater than the positive rate overall, that will give us the list of rows. The list of rows, which is about 12 rows or about 12 days when the positive ratio, so that is the ratio of new cases by new tests, was higher than the overall average. All right. And as we saw here, you can even check this specific operation. So dividing two series or two columns by one another. So that simply gives you another series which contains the element-wise divisions. Okay. And further, what we can do is, whenever we do an operation like this, which returns a series which has the same length as the number of rows in the data frame, we can actually set that back as a new column into the data frame. And this is once again where the dictionary of lists analogy will make sense, because if you think of COVID-df as a dictionary, then into that dictionary you are adding a new key called positive rate, and into that new key you will add the values of that specific column. So the column being new cases divided by new tests, which we are calling the positive rate. All right. So now if we check the COVID DF data frame, you can see here that we have a new column called positive rate. And whenever there are nans in any of these calculations, you will also see a nan reflected here in column wise calculations. Okay. But here's a detail to keep in mind. And this is once again going back to the context about the data, that sometimes it takes a few days to get the results for a test. So as such, we can't really compare the number of new cases with the number of new tests conducted on the same day. You may conduct 1,000 tests today, but maybe 500 of these results might come out tomorrow, and then another 200 might come out a few days later, and so on. On the other hand, the number of cases that were reported today could have contributions from tests conducted over many of the past few days. So comparing cases and tests on a day-to-day basis is probably incorrect, and any inference based on that is likely to be incorrect, right? So this is a place where you should dig in more and see what is the average duration it takes to get the result for a test, and how did that change over time, and so on. So it's important to watch out for subtle relationships like this in the data, which are not conveyed clearly by just the CSV file. So these require some external context. So you should always read through the documentation provided with the dataset about how the data was collected, what are the processes involved in collecting the data. And if you have any questions on your own, then you might want to ask these questions from the source of the dataset. Whether it is your company or some online source, you might want to ask for more information. Okay. So for now, what we can do is we can simply remove the positive rate column. So to remove the positive rate column, we call the drop method. So we say COVID-df.drop. And when we call COVID-df drop, we can remove one or more columns, and we can either get a new data frame out, which will be a view of the previous data frame, or we can simply drop it from the existing variable. So COVID-df, right? So I'm just going to drop it from the existing variable so that we do not have to worry about a new variable now. So if we check COVID-df now, you can see that the positive rate is now gone. Okay. So now we've looked at querying data. We've even looked at adding new columns. But another thing that we might want to do is just sort these rows by a specific column. So for instance, you might want to identify what were the 10 days with the highest number of cases, right? And the way to do that is to first use the sort values method. So you can simply use say COVID-df.sort values, and into sort values you can pass in the column by which to sort. So you can either pass a single column or a list of columns. And to figure out how to use these functions, a simple way to do is to use the help function. So you can call help on COVID-df.sort values, or you can simply press shift plus tab while the cursor is inside that method or that function. So if you do shift tab once or twice, you will see the full signature. So you can see here that the first argument is by, and by can be a string or a list of strings. So either a single column or a list of columns. And similarly, you can also specify whether you want to sort by ascending or descending order. And again, ascending can either be a single Boolean, or if your list of columns is a list, you can also pass a list of trues and falses, a list of Booleans, so that you can sort by descending and ascending with multiple columns as you require it. All right. So that's a very powerful way to sort, similar to what you might do in Excel or SQL. And then another thing that we have done is we have actually chained this. So the result of sort values is another data frame. And then we have changed that. We have chained that with the head method, and we are looking at just the top 10 elements from that sorted data frame. So that gives us the 10 days. So it seems like the 22nd of March was the peak with 6,557 reported cases that day. And then, and it was mostly the last couple of weeks of March, it seems like, where most of the highest number of cases were reported. Okay. Now let's compare this with the days where the highest number of deaths were recorded. So here now we have COVID-df.sort values, and here we are sorting by new deaths. And once again, we're looking at the top 10, and it seems like the 28th of March was when there was the peak, and then the 29th. So if you compare these two, it seems like overall that the daily deaths hit a peak just about a week after the peak in the daily new cases. So that might lead you to, and then you can dig in a little more and read some literature, and that might lead you to understand that, okay, maybe for somebody who's contracted a virus and is going to become seriously ill from it. So they are going to probably suffer the most within the next week or so, and they will either recover or not. Okay, so let's also look at the days with the least number of cases. And here, this might be obvious to you that, okay, the least number of cases might be in the first few weeks of January, but even then it's a good thing to look at. So I'm just going to sort these values. So coviddf.sort values, and by new cases, this time in ascending order, and pick the 10 lowest numbers. So as we might expect, we see a lot of days from the last day of December, and then we see a bunch of days in January. But here's one. So on the 20th of June, there seems to be the value -148. And now this is unexpected. You might not expect to see a negative number of cases in a day, but that is the nature of real world data. This is what happens, and it invariably happens with any real world data, and it really cannot get more real world than this, which this is data being updated based on real facts and real numbers being reported by hundreds of countries and hundreds of agencies and hospitals on a daily basis. So there are likely to be errors, there are likely to be discrepancies, and this could simply be a data entry error, or it's possible that the government may have issued a correction to account for miscounting in the past. So you may have to see the documentation around the data. And this particular data set that we have is pulled from Our World in Data. So you can go to Our World in Data, the website, and try to find out more why this might be the case. And I encourage you to dig through news articles online and figure out why this number was negative. Okay. But another thing that you might do if you do not have any external information is to just look at some of the days before and after that date where we have this negative column, this negative value. So if you look at the days, so this negative value was at index 172. So we can look at the few days before it and a few days after it. So it seems like the values for new cases were in the range of 210, 328, 331, and similar range after that, but only this value seems to have some discrepancy. Now, based on this, I am guessing, although I cannot know for sure, but I'm guessing that this might be a data entry error. And if it was, and if we are able to verify that, we can use one of these approaches to deal with this missing or faulty value. So one way is to just replace it with 0. Just say that we are assuming there were no tests, there were no new cases reported that day, but that is a little unlikely for this specific data set. It may not, it may be likely for a different data set, but not for this. Another thing is to replace it with the average of the entire column. So we can say that, okay, we just take the entire average number of new cases and then simply put that in here. Again, you can do that in certain cases, but in this case, once again, it may not make a lot of sense because the variation is so high, the standard deviation is so high that the average here is probably not going to be anywhere close to the actual number. The average we know is about 1,000, but the actual numbers on the days before and after are actually more in the range of 300 or so. Another thing that we can do is to discard this row entirely. This is something that is, so in a lot of cases you can do this. You see some faulty data and it is okay to discard. It is not going to affect the overall results significantly. So you can just discard that data as well, that row of data. And one more thing, which is probably makes the most sense in this case, is to simply replace this value with the average of the numbers around it. So we can simply take the average of these two numbers, or these two and these four numbers. So which approach you pick really requires some context about the data and the problem. In this case, we are dealing with data ordered by date, or what is called time series data. And that is why taking an average of the values around it actually makes a lot more sense. So now to do that, we need to modify that value within the data frame, and we can modify it using the same at method that we use for access. So we say coviddf.at, and so 172 is the row number or the row index, and then new cases is the column. And here we simply say that we want to take the average of the two values of the value above and below it in the data frame. All right. And with that, we have fixed, or at least temporarily fixed, the discrepancy in the data frame. All right. So these are just some ways in which we can filter out data and sort rows out of the data frame. So we looked at finding the sum of values in a column or a series. We looked at querying a subset of rows satisfying a given criteria. We looked at adding new columns by combining data from existing columns. And then we also looked at removing one or more columns from the data frame using drop. And then we looked at sorting the rows of a data using the column values. And finally, we looked at replacing a value within a data frame. And once again, this is not something that you need to remember by heart. On the other hand, you need not, and you can simply search for this online and you will be able to find the right resource. Okay, so now I've committed my notebook once again. So moving forward, as I just mentioned, this data is ordered by date. So this is what is called time series data. So while we've looked at the overall number for cases and tests and positive rates, it might also be useful to study these numbers on a month by month basis because there is so much variation on the daily cases. So you might want to just drill down and look at a specific month or a specific week. Now to do that, the date column might come in handy here. And in fact, because so much data tends to have a date or a time associated with it, Pandas provides many utilities for working with dates. All right. So if you just check the date column here, so it seems like this is a series as we might expect, but this has the D type or data type of object. And that means that Pandas currently does not know that this column is a date. So what we might want to first do is convert this date column into a new column which has the data type of date time, and this can be done using pd.toDateTime. Okay, so we just say pd.toDateTime and then we give it a series, and it takes the series and then it converts those data types into the date time format. So it's an internal format within Pandas, and then what we can do is we can take that and we can assign it to a new column. But instead of assigning it to a new column, we can simply assign it back to the same column, because once you have the date in the date time format, then we don't really need the string date. We can always get it out from the date time format if we need it. So now if we check coviddf.date or coviddf indexed the date column, so you can see here that the data looks similar, but this time the data type is datetime 64. So this tracks time up to a particular nanosecond. But since there was no time portion in the date, so you don't really see a time portion, but it tracks time up to nanoseconds. Okay. So what we can do is we can extract different parts of the data into separate columns using the datetime index class. So this is a really helpful class in Pandas. So all you need to do is take the series or the column and pass it into pd.datetime index. So that creates an object of type datetime index. Now, if you want to extract a specific information, a piece of information out of it, you can do that. So if you want to get back the year, so we just do .year, and then we can set, and that will return a series, and we can set that into the year column. Similarly, we can set a month column, and we can set a day and a weekday column as well. All right. So now we've just added 4 columns simply by converting the date column into a date time data type and then passing it into the datetime index. Okay. And let's look at the data frame now. So we have the date as before. We have the metrics that we had earlier, but now you can see year, month, day, and even the weekday. So the months go from 1 to 12, January to December. The day goes from 1 to 31 or whatever is the number of days in the month. And the weekday represents Monday to Sunday. So Monday is 0 and Sunday is 6, and then you can guess the values in between. All right. So now that we have the month related information, so let us track the overall metrics for the month of May. And for this, we are actually going to do it in a few steps. So let us just see all the intermediate steps here. First of all, we may want to query the rows for May. So here what we are saying is coviddf May is coviddf, and then we are indexing into it and passing a Boolean expression where the month column is equal to 5. And let's check the value of it. So there you go. Looks like there are 31 values, there are 31 values here, and you can count it as well. So there are 31 values and this contains the data only for May. Now the next step now is to get the sum for each column, right? So we want a sum for new cases, we want the sum for new deaths, and we want the sum for new tests. But instead of doing it column by column, we can also do it all at once on the entire data frame. But to do it all at once, we may want to first exclude the columns which we do not want to sum over, because for some of these columns the sum may not make sense. So we can simply extract just these 3 columns. So let's do that. So we say we create another data frame called COVID DF May metrics, where we pass COVID DF May, and from it we simply extract the columns new cases, new deaths, and new tests. So here we are using the indexing notation, and instead of giving it a single column, we are giving it a list of columns. And now you can check the value of COVID DF May metrics. And you can see here that it has 31 values, but only for the new cases, deaths, and tests column. Okay. And now finally, now we can get these totals. So instead of calling sum on each series individually, we can simply call it on the entire data frame. And when we do that, now we get back the totals. So now the entire data frame collapses into a single series. So you can see that this is a series. And now we have the total number of new cases, which is 29,000 during the month of May. The total number of deaths was such, and the total number of tests was about 1,078,000. Okay. And this is how you should initially do it when you're learning pandas. This is how you should initially just go step by step, keep creating intermediate data frames. As I said, all the data is shared between the data frames, so you need not worry about it being very slow or taking up a lot of memory. So just keep creating as many intermediate data frames as you need. The most important thing is for you to have clarity about what's going on in your calculations, and performance and optimization can be an afterthought. But what you can do is, once you become comfortable with this, is you can actually start doing it in a single statement. So now here we are saying that, okay, we are getting the data out for May. Out of it, we are selecting a few columns, and then we are calling dot sum on those columns together. And that gives us the exact same result. Okay. That's some data about May. Now you can try finding the data about January, February, March, and see how they compare. Now here's another example. Let us check if the number of cases reported on Sundays is higher than the average number of cases reported every day. Okay. So this time what we might want to do is, instead of aggregating, so we do not want the total number of cases on Sundays. We simply want the average number of cases. And we also want the average number of cases. We also want the average number of cases in general per day. So the overall average, what we can do is we can say COVID df.new cases and call dot mean on it. So it seems like the overall average is 1095.78 cases per day. And the average for Sundays. So the average for Sundays, it looks like is COVID df. So first we extract out the data for Sundays. So we say COVID df dot weekday equals 6, and we pass that as an index. So the Boolean expression returns a series of Booleans, which we pass as an index to COVID df. And from that index, we get back the new. So now we have only the data for Sundays, and from it, we get back the new cases column by using the dot notation. And then we can, now that we have the list of new cases on Sundays, we can call mean, and that gives us the mean 1247. All right. So now it does seem like more cases were reported on Sundays compared to other days. And you can get this information for each day of the week. And now at this point is where you might want to go do some investigation, do some research, and figure out why it was the case. Okay. So data analysis cannot be done within a silo. Any data that you analyze and any inferences that you come up with, you have to then go and investigate why it is, why. All right. So those are just some basic questions that we've asked about our data, but try asking some more date related questions about the data, and share your results on the forum. If you found some interesting insights, share the results, discuss what might be the reasons behind those insights. Who knows, you might discover something new. Okay. But what we really wanted to do as we started talking about dates was that we wanted to summarize the day-wise data, and we wanted to summarize it on a month-wise level. So instead of having the new cases, new tests, and new deaths on a daily basis, we might want to see them on a weekly basis or on a monthly basis. And this is again a very common use case. Often the data, and this is called the granularity of data. So often you may have data that is collected per millisecond, or you may have data that is collected per second or per minute or per hour, per day. And you might want to change the granularity. Now, obviously you cannot go back from hours to minutes, but you can combine the data from minutes to hours, right? So in this case, what we want to do is we want to combine the data for multiple days within a month into a single row of data. All right. And the way to do that is using the group by function. So in the group by function, what we need to do, it's a function of the data frame. So we say COVID df.group by, and let's just do it step by step here. So we say COVID df.group by, and then we want to group by month. So what this does is it does not show you any output because this is an intermediate data structure. It does not really do anything. It simply collects some information about how you want to do some grouping. But conceptually, what you can think it does is that if you look at COVID df, so here you can see that there are a lot of values for month, and in fact month has about 10 values. So there is 12 for December 2019, and then there is 1 to 9 for 2020. Now fortunately all the data is from a single year, and so we do not need to consider just month and year, but in some cases we might want to group by month and year. But in this case, if we just group by month, what happens is Pandas creates one group for each unique value of month. So for the month of January, all the rows are collected together into one group. Similarly, for the month of February, all the rows are collected together into one group. And for the month of March, April, May, June, and so on. So each month, the rows for that month are collected into a single group. Now, what do you do with that group? Now on that group, you can do you can then say how to aggregate the information in that group. So what we might want to do then is that for all the data, all the rows in January, we may want to add up new cases, new deaths, and new tests to get back the total number of cases, the total deaths, and total tests in that particular month. But before we do that, now to do that aggregation, we may have to first ignore all the other columns, right? So just like a data frame, a group by also allows you to specify which columns to keep. So once you've done a group by, once we've done a group by, let's put this into a variable called group. So let's say monthly groups. Okay. So now from the monthly groups, before we summarize the data, we may want to simply say monthly groups, and out of these simply select the columns that we want to look at. So monthly groups, now you can see here that we still get back a group by object. So we are still in an intermediate state. No aggregation has been performed yet. But what we can do is we can select these columns and then we can call .sum. And now what is a new data frame, a completely new data frame. So the original data frame still exists, but this new data frame, the index, it does not have the same number of rows as the original data frame. In fact, the number of rows here is equal to the number of groups in the grouping column, right? So month had 10 values in total. So you have 10 rows, 10 elements in this, 10 rows in this data frame. And then we had selected 3 columns, new cases, new deaths, and new tests. So now for each of these groups, so these are the 3 columns that show up in the result. And for each of these groups, we have then performed an aggregation using sum. So that's where you can see that the total number of cases reported in January was 3, and then it grew to 885, and then it grew to 100,000, and it remained at 100,000 in April, and then it started going down in the month of May. And then you can see here that it started going down, but it seems like the number of cases seems to have grown again in the month of August. So it seems like there might be a second wave going on here. And already you can see here that simply by grouping and aggregating the data onto a monthly basis, we can already make some more inferences than we were able to do previously using just the date level data. And that is really the whole purpose of data analysis. What we are doing is we are transforming data from one form into another, whether it is aggregating it, whether it is creating new columns, whether it is creating new groups, or whether it is sorting in a certain way. So we are simply moving the data around to gather more inferences about the data. All right. And the underlying data remains the same. Now we will take this idea further next week, where we also use this to plot graphs, because while you can see the trend here, you cannot really see how drastic the change is. And that is where humans are able to perceive things much better visually, especially when they are comparative. So we will also look at a few ways to draw some graphs. All right. So that's grouping, and there's a lot of depth in grouping. So you should probably just check out the documentation or read a tutorial on grouping in Python, in Pandas. But we will just leave it at this one simple example, or maybe let's do one more. So let's do this. Let us, instead of aggregating by sum, let us aggregate by the mean. And let me pose the question this way. So let's try and find out what was the average number of cases reported on every weekday. or average number of cases or tests or deaths. So we group by weekday now, and then we select the columns new cases, deaths, and tests, and then we call dot mean. So instead of aggregating by sum, we can aggregate by mean. So there are a lot of ways to aggregate. You can aggregate simply by the count. So if you just want to see the counts, in this case, the counts will be equal for every weekday, because we have over time the number of weeks, each week has 7 days. The count is not very interesting, but sometimes that might be interesting. But then you can also check aggregate by just keeping track of the maximum, and you can aggregate by keeping track of the minimum. So there are a lot of ways to aggregate, but we are aggregating by mean. And when we do that, we can see here that for each weekday, we can see how many new cases on average were found. So on average, 1100 cases on Mondays and 1200 cases on Sundays. And it seems like on Tuesday and Wednesdays when on average you had the lowest number of cases. All right. And then you might want to now dig in and investigate that. Why is this the case? Maybe it has something to do with the testing methodology. Maybe it has something to do with the reporting. And maybe you can see that, okay, how does it compare with the average number of tests? So it seems like the average number of tests was highest on probably around the 4th day. So which is Monday, Tuesday, Wednesday, Thursday, Friday. It seems like the average number of tests was the highest on Fridays, but the average number of reported cases were highest on Sundays. So it might suggest that it seems like that maybe it took about 2 days for the test results to come out. But this is where you have to then go back and investigate a little more. Okay. So now, apart from grouping, another form of aggregation is to calculate the running or the cumulative sum, right? So we have in our data frame, we have data for on a daily basis in the original data frame. So once we look back here, so we have new cases, new tests, new deaths. But what we might also want to know is that up to a particular date, what was the total number of cases? And we might want that information on a daily basis, because that is again another interesting trend to study, right? So the way to do that is using the cumulative method. So there is a cum sum, cum cum sum method, but there is also a cumulative maximum, there is a cumulative mean, and there are a lot of other ways to accumulate the data on a row by row level. So let's just call cum sum on new cases and set that into a new column, total cases. And similarly, we do that for the deaths and the tests as well. And now what we've done is, by the way, for tests, we have also included the initial test count. So this is again to account for, there were a lot of days where daily tests were not reported. So we have accounted for that as well. And now when we check the data frame, you can see here, apart from new cases, new deaths, and new tests, we have total cases, total deaths, and total tests as well. All right. So that's pretty good that now we have this information to look at too. Notice that the NaN values still remain here. So you can still see that the total tests was NaN. So the cumulative values tend to remain NaN till you have a single NaN value. And actually, whenever you see a NaN value, the cumulative result turns out to be NaN. Okay. Next up, now we have the cumulative information, and we've gathered a lot of information about our data, about our data set from the data that was given. But more often than not, you might need to merge data from multiple sources. So you might want to calculate, let's say we want to calculate a metric like tests per million or cases per million. And so for this, we require some more information about the country, specifically its population in this case. Okay. So let's download another file, locations.csv, which contains the health related information for different countries around the world, including Italy. Okay. So we have URL retrieve here. And this is where we're passing in the full URL, and we're passing in a CSV file name where we want to download this data. Once again, we read this into a data frame and we can check it out here. So this contains the location. It contains, which is basically country, but there are also one entry each for world, and then international, that was to track for any country, anything that was happening not in any specific country's borders. But yeah, we have location, continent, population, life expectancy, hospital beds per 1,000, and GDP per capita. So we will only be using the population data right now, but in the assignment that you will do after this lecture, that you will end up using all of these different all of this different information about each of the countries. So let's just check, let's verify that Italy is here. So the way to verify is, once again, we just have a Boolean here that we want to check that the location is Italy and pass that as an index into the locations df. So it looks like Italy was there. It was at the 97th index and it is in Europe and it has a certain population. So it seems like it has a population of 60 million people. And then there's a certain life expectancy and beds per thousand and GDP per capita. All right. So now one thing you might just do is take this population and then just use it directly for our calculations. But a more interesting thing that we can do is to insert all of these columns, all of these values into every row of our data frame. And why might we want to do that? So we have COVID DF. Let's take a look at it. So this is our COVID DF data frame. And right now we only have the information for Italy, but it's possible that we may have information for multiple countries in a single data frame. All right. So we may have, let's say, if I introduce a new column called location, and right now, because we only have data for Italy, I'm just going to set it to Italy. So now we know that for Italy, so in the location Italy, on this particular date, these were the metrics. And similarly, in the location Italy, on this particular date, these were the metrics. And then, we can do the same analysis for, let's say, Spain and Portugal and Germany. And then we can put all those data frames together. So you can imagine having a data frame where you not only have data for Italy, but also have data for Spain and Portugal and all of these other countries. So location may take different values. Now, when we want to calculate the per million metrics, then a good idea would be to introduce a few new columns into the data. So for each row, if we could introduce columns like continent, population, life expectancy, then we can calculate a few more metrics. All right. And the way to do that, so the way to join these two data frames is to use the merge operation within Python. But to merge the data frame, you need to have at least one common column. And in this case, the common column is Italy, right? So the location Italy is the common column is location. So the location column can actually be matched up. So what we can do is, for each row here, we can look up the location. For that location, we can look up the data from the locations data frame and insert that as new columns within that row. And the way to do exactly that is to use the merge method. So here we take the source data frame, which is the COVID data frame. And in the COVID data frame, we are saying that we want to get information out from the locations data frame. And how do we want to get the information out? We want to get the information out using the location column. So for each row of the COVID data frame, we check the location, and then for that location, we get the data from the locations data frame, and then we insert that data into that row as new columns. Okay, so let's see what that looks like. So here we have the same data as before, and we are calling this merge df because it returns a new data frame. So COVID df still contains the original data, locations df remains undisturbed, and merge df will now contain the merged information. So now in this merged df, you can see here that we have the same information that we had earlier, but after location, you can see a bunch of new columns were inserted, and these columns are fetched from the locations data frame. Okay, and these are the data for the corresponding locations. Now, since we only have Italy in our COVID df data frame, you can see that all of these rows pretty much have the same data. But if we had multiple locations, you would see different data for each corresponding location. Okay. So now we can calculate metrics like cases per million, deaths per million, and tests per million. So we simply take the total number of cases and then we divide it by the population. But because the population is the overall population, we need to divide the population by 1 million, or we can simply bring it up here. So this is just to account for the per million calculation. And now if we check our merged data frame, now we also have this information of cases, deaths, and tests per million people. And that's an important metric probably to look at when we are comparing countries, because between countries, what we really might want to know is not the overall number of cases, not maybe even the number of tests conducted, but more the per million or per capita number of cases. And that's where this is useful. Okay. So that's merging. So now we have merged our data, and with this, we've pretty much done everything that we can do with a pandas data frame. There's still a lot more for sure. There are many different kinds of functions to explore. There are many different things that you can do, but this is some of the common things that you do, and we are using a real world data set. So this is like a real world data analysis that we are doing. And what we might want to do after doing some analysis, after creating some new columns, it would be a good idea to write the results back to a file, because right now we are running a Jupyter notebook which is running on Binder, and whenever this Jupyter notebook shuts down, the data will be lost, all the analysis that we have done so far. So before writing this data to a file, the first thing we might want to do is just create a smaller data frame, because now while you're working through your data, you may create tons of columns, you may create dozens of columns, and you may sometimes you may create columns that you don't even really need. For instance, we've not really used the weekday data or the day data, and while we are exporting this back to a file, since we already have a date now including year, month, day and weekday is somewhat redundant. What we can do is we can once again create a results data frame where we can get rid of all the intermediate columns that we had created which we don't really need. We also pulled in a lot of columns from the locations data frame. Once again, we may not really need them. So we are simply going to keep the date, the new cases, the total cases, the similar metrics for deaths and tests, and then the per million metrics. Okay. So we take this and check it out. So result df here. And now this is the information that we want to save to a file. Now to save this data to a file, we can use the toCSV function or the toCSV method of a data frame. So we simply say result df.toCSV, and then we pass in results.csv here, which is the file where we want to write to. Now, if this file already exists, it will get overwritten. And then we also set index equal to none. So this is a small detail that you need to know about pandas. This is a common error that I tend to make all the time. So what pandas does is it also treats the index as a column while writing to file, because sometimes that an index need not just be just numeric indices. For instance, we saw that month was an index earlier or weekday was an index earlier. So sometimes you may want to retain that information, but in many cases you don't. So since we do not want to retain the index information, we do not want an additional columns going from 0 to 247, we can just say index equal to none or index equal to false, and that will tell pandas not to include the index in the output. Okay. So now once we do that, we have now created the file. So we can open up that file. So we can go file, open, and open up the results.csv file. And now with this results.csv file, you can see here that these are all the columns that were exported, and this was the data for all these columns. And wherever the data was nan, so now just as empty values got read as nans, so same way nan values get written as empty values within the CSV file. But you can see here, probably sometime in March, you can see that all the numbers most of the numbers at least have non-zero values over time. So that's how you save data back. And then you can, just as you can read many different file formats, you can also write back to different file formats. Like you can create a SQL file, you can create an Excel file, you can create a JSON file, and so on. Okay. Now, one other thing that you might want to do is, one thing you can do is you can simply download this file. So you can select results.csv and click download to download this to your computer. And by the way, you can also use the upload button to upload files from your computer. So if you have a CSV file sitting on your computer and you want to upload it to Binder, then you can just click the upload button and select the file instead of using the URL retrieve method to download it from an online URL. In any case, so that is one way you can keep the file around. But it would be nice to, since we are already putting our Jupyter notebook on Jovian.ml, it would be nice to also attach the file as an output of the Jupyter notebook. And in fact, as we do multiple analysis, each time we may get back different results. If we come back tomorrow, get the new data out, then we may get new results. And for that, what you can do is when you do Jovian.commit, you can actually specify an outputs argument, and in the outputs argument, you can specify a list of files or folders. And what Jovian will do is it will, along with the Jupyter notebook, it will also capture and upload the results.csv file. So let's take a look at that. So here we have created version 14. So every time we run Jovian.commit, a new version got created, and you can see the same Jupyter notebook here in a read-only mode. And then you can click run and run it on Binder, and the whole, just exactly as you might expect. But if you check the files tab, you will find on the files tab that there is a section called artifacts where you can see the results.csv file. So this is the results.csv file, and you can view it here. You can view the raw file. You can even delete it if you want to get rid of it, or download it if you want to simply pass it on to somebody. And now each version will get a different results.txt file. So this is a good way to keep your outputs organized. All right. And that's pretty much it about writing data out from pandas into a CSV file. Now I want to take a few questions at this point. So let's see what questions we have. Okay, so the first question that we have is, why do we use pandas when data analysis and presentation can be done in SQL or Excel? Okay, so that's a good question. And there are two parts here. The first question is about SQL, let's say about SQL and Excel. Let's answer that first. Yes, you can do a lot of this analysis in SQL and Excel, but SQL, for instance, is one limitation that you might face is that SQL only works with database tables. So if you want to combine data from multiple sources, one of which is a SQL table and one of which is an Excel file and one of which is a CSV file and one is a JSON, and that is just how real world data is, that you may have some COVID data in your SQL database, but then you may have to download a locations.csv file from somewhere, and then to combine them, either you have to create a new table. Now pandas lets you avoid all that. You can pull data from any format into a pandas data frame, which is held in memory, and then do all and combine them and then perform all these operations. So that's one benefit. Then the other thing is that SQL is a very limited language. So Python being a general purpose language, you can write functions, you can reuse the code, you can use the pandas library, and then there is a whole ecosystem of thousands of libraries that you can use, which are built on top of Numpy and pandas, like things like SciPy and so on. So that's something that you can draw into, and that makes whatever you want to do, you can possibly do that in just a few lines of code. Whereas with SQL interviews are the hardest because you have to write everything from scratch, and you have to write these huge expressions which all have to be within a single line. So it's not very convenient and it's not very reusable. And you can use variables within pandas. So that's a benefit. Then comparing it to Excel, if you are able to do all the analysis that you need to do within Excel, that's great. That's a good place to start. You need not really use pandas if you can do all your analysis in Excel. But when you want to scale things, like we've done analysis for Italy, but now we want to do this similar analysis for 100 or 200 other countries. Now at that point, it might get a little difficult to do that in Excel, because you cannot really capture all of the analysis that we did into some basic Excel formula or even like an Excel macro. So that is where, again, pandas, this might be useful. You can take all the analysis we have done, put that into a function, and use that function to analyze hundreds of files. So that's about SQL and Excel. And then the second question was about presentation. Now, in terms of presentation, what I would say is that the Jupyter Notebook is probably a better way to present, because you can add all of this explanation. You can draw graphs within a Jupyter Notebook, and it has this sequential order, which is, it's also very well suited for a narrative or a storytelling flow, where you can present all of your findings in a structured format. And there are ways where you can hide the code and so on. So I would say that Jupyter is actually a good way to present. And what you can do is you can simply take the Jovian URL and you can share that. And that is a good way to just create a report and share it. If you're doing a project and you want to create a report, you can simply upload the notebook to Jovian, and that's a report right there. What you can also do is, now you can also see previous versions. So that's one other benefit, that if you're, let's say, doing this analysis on a daily basis, you can always go back and check previous versions. Versioning is not something that you can do easily with Excel or SQL. So these are just some of the benefits of, I would say, benefits of programming in general, but using pandas and Python and Jupyter in particular. All right, let's take another question here. Okay, there was another question. Is it better to write individual statements, or is it better to combine multiple statements into a single statement to improve performance? In general, what I would suggest is it is better to do the thing that you find the most clear, because the performance hit that you're really taking, unless you're working with millions of rows of data, is maybe you go from 1 second to 5 seconds. if you split something into multiple lines or do something a little bit inefficient. But I would suggest that's probably totally worth it rather than trying to create one long expression or one long statement that you don't really understand. So initially try to break things down, try to write small statements, and over time, as you get the hang of it, try to write single statements, because ultimately it is true that a single expression is going to be faster or going to be more efficient. Okay. So now let's talk about plotting, and this is something that is leading into the next lecture. So typically we use a library like matplotlib or seaborn to plot graphs within a Jupyter notebook. But pandas, data frames, and series also provide a handy plot method for a very quick and easy plotting, right? So we're not going to learn a lot about the syntax for plotting, but we will see how to draw a few graphs. So the simplest way is to just call the plot function on a series, and you can say, and that plots a line graph. So here we take the result data frame and then we check the new cases and then we just call plot, and you can see that plots a line graph. So here you go. So now, so we've been looking at this data for about an hour and a half, but only by looking at this, and so far I don't think we've had that insight of how exactly the trend was on a day-to-day basis. But just by looking at this single picture, we know now, probably now know more in a different sense that we did all this while. So you can see that the trend is the number of cases increases to a certain point, hits a peak, and then it goes down. And then it seems to be going up once again. So there seems to be a second wave happening right now. So this is just like a line graph visualizing the number of daily cases. Now it would be nice to see, it's hard to tell where the peak occurred exactly because it is simply using the indices that are already there in the series. And those indices go from 0 to 248. So we might have to do some mental math to figure out where the peak occurred. But we can actually put the dates on the x-axis, and the way to do that is take the date column and convert it to the index for the entire data frame. So what we can do is we can take the result df and then just set the index to the date column, and we just do it in place so that we don't want to create a new data frame. So now we check result df. You can see that the index is now gone, and now the date is the index, and this is no longer a numeric index. Now this is a date time or a string index essentially. And now we can in fact even access the data for a specific date. So now into loc we pass not the index like a number 1 to 248, but we actually pass the date, and then we can get the data out for that specific date. Okay. And every series that we extract out will also have the date. So if we check results, result df dot new cases, now each of these series or each of these columns will have the date as the index. And that is just one of the benefits of using series, that it can let you index using a specific index and not just numbers. So now that we have this, the next time we run plot, so now if we plot new cases, and what you can do is you can also combine plots. So you can also say dot new deaths, and we are going to plot that as well, just to compare, okay, what was the ratio of cases to deaths and what was the trend looking like. So we can plot them. And now you can see that we have a graph. It has the data for new cases, which is the blue line, and the data for new deaths reported, which is the orange line. And then we have the x-axis also shows the months. So as we saw earlier, it seems like towards the mid or towards the last couple of weeks of March was when the maximum number of cases was reached. And just about a week from there, about 7 days out, was when the peak number of deaths was reached. We can also compare the total cases with the total number of deaths. And you can see here that this number grows up to a certain point, and it seems like it is increasing again, but the number of deaths seems to have mostly flattened out. So this is what, when we talk about flattening the curve, that was a popular term initially. This is the curve that we talk about that we are flattening. Actually, this is the curve that we're talking about flattening because we want to reduce the number of cases on a daily basis. So what happens when you do social distancing, when you wash your hands regularly, when you wear a mask in public, is that the daily cases probably will not hit such a high peak. It will actually go slightly lower, and it will take a longer time, but overall it is not going to reach that peak. And you can see here, while the second wave is coming, it doesn't seem like it is growing at the same pace or at the same speed that it was growing earlier. So it seems like we've flattened the curve to a reasonable extent. At least Italy has. So let's see how the death rate and the positive testing rates vary over time. So we can also plot them. So here is how the death rate changes over time. So the death rate is simply the total number of deaths divided by the total number of reported cases. So you can see that initially it is low because the number of cases is very low, and it's mostly people coming from different parts of the world. So initially we were not really tracking, they were not really able to account for all the cases because testing was limited, and probably even deaths were not being diagnosed as COVID deaths. But over time that number has increased as the contact tracing improved. So the people who were being tested were specifically being tested, people with symptoms, people who had come into contact with other COVID patients, and that's why this number may have gone up. And now it seems like maybe the pressure on the hospitals is now not as high. So it seems like the death rate seems to be going down once again. So different parts of this curve may have happened for different reasons, and you need to be you need to be following the recent developments. You need to be reading the literature, reading the research to come to an informed understanding of why this seems to be happening, right? And this is the common pattern. You see a certain trend, or you see a certain pattern, and then you wonder why it is. Maybe you take a few guesses, but your guesses are just guesses. So what you then need to do is go back and back up those guesses with evidence and see which of your guesses are correct. Okay. Then we have the positive rates. So the positive rates also, the total number of tests was only tracked from April. So the positive rate data is available only from April. So it seems like that over time testing was increased to cover a wider number of people. So initially, while only people who were very sick or had very strong symptoms, or it was well known that they had either come from a foreign country or they had come into contact with another COVID patient, so only those people were being tested, and that is why the positive rate was quite high, about 18%. But over time, as more tests are being conducted, even for healthy people, just to identify, contact, test and trace people, you can see that the positive rate seems to have gone down, and its overall positive rate is currently at around 5%, which means that there is a fairly good level of testing. Finally, let's also plot some month-wise graphs. So remember we had this month-wise data. Okay, let me just grab the monthly information here. Yeah, so here we have the month-wise data. So this is the month-wise data that we have. So for each month we have the total number of cases, deaths and tests. And then we can come back here and we take the COVID month TF, the cases, tests and deaths, and then we can simply plot that. So here is the number of cases per month. So you can see here that in January there were no cases pretty much. Actually it was about 3 cases, and this time we have chosen a bar plot. So when we have a smaller number of elements on the smaller number of values on the x-axis, then it helps to have a bar plot. It can give you a slightly better idea for comparison. So it seems like the months of March and April were the worst, where there were the most cases, and then the number of cases went down quite significantly starting in May, and then May, then June, and it seems like it is on the rise again in August, and then in September we've just had a few days. So we need to see how the trend turns out in September. But definitely now we are a lot better prepared. Every country is now a lot better prepared. So this number should probably not go as high as 100,000. Then here we are looking at the number of tests being conducted. So again, we do not have daily test data for Jan, Feb and March, and even half of April. So you can see that testing really picked up in May, and Italy has continued to conduct a large number of tests. But even though the large number of tests are being conducted, the number of positive cases is low, which means that probably the country is doing a good job of containing the positive cases. The country is doing a good job of isolating people. Maybe people are also following things like wearing masks in public and avoiding and doing social distancing. And as you compare this information, ratio of tests conducted and positive cases, and maybe even positive cases and death rates, you get to know about the per country situation, and every country is unique. So you really need to dig into the data to really understand how things are unfolding in each country. Okay. And with that, we complete our discussion of data analysis with pandas, especially for tabular data. So we can do one final commit, and Now we are ready to move on to the assignment, but apart from that, I've also listed a few other resources you can check out. So here are some exercises on pandas. You can check out the official user guide, or if you want to, you can check out the book by Wes McKinney, the creator of pandas. It's called Python for Data Analysis. It is a huge book, pretty comprehensive, and a lot of the material in this course is also inspired. In fact, a lot of material in general related to data analysis is inspired from that book. So do check it out as well. So now let's come to the assignment. And the objective of this assignment is essentially to gain some hands-on experience with the pandas library. So the things that we learned today, you will get to apply them. So things like creating data frames, querying and indexing operations, grouping, merging and aggregation, and dealing with missing values. And to get started, you can simply open up the starter notebook. So here is the starter notebook, and it contains the information that you need to work on the assignment. And the first thing that you might want to do is just click run and run it on Binder. And you can do this assignment completely using Binder. The basic idea here is that you will see in a lot of places, you will see question marks. So you will see 3 question marks in certain places, and your job is to complete the assignment. To complete the assignment, you have to replace these 3 question marks with appropriate values, expressions, or statements to ensure that the notebook runs end to end properly. Okay. And some things to keep in mind is that to make sure that you run all the code cells, because if you do not run, if you miss a certain code cell, then you may get errors like name error or undefined variables. You do not want to change the variable names that are already there. You can create new variables and you can add new cells, add new code, but do not delete existing cells, do not change variable names, and do not disturb any other existing code, because that may cause problems during the evaluation. And in some cases, you may need to add more code cells or new statements. So feel free to do that. It's not that you just have to replace the question marks. You can write additional code as and when you need it. And you can do this assignment on Binder, but since it is a temporary online service, then you do need to save your work by running jovian.commit at regular intervals. And ideally, we recommend doing it after solving every single question. Then finally, there are some optional questions here. So these will not be considered for evaluation, but we highly recommend doing them, work on them later. Okay. So let's look at the notebook. So I have just clicked the run button and selected run on Binder. And now on run on Binder, here I can open up the notebook pandas practice assignment. And the same thing that I like to do always is to just clear the outputs and toggle the header and toggle the toolbar. Okay, so now in this assignment, the first thing that we do, the very first thing that we do is we simply import Jovian and commit. And the reason for doing that is so that you can save a snapshot of this assignment to your profile. So let's just copy our API key from our profile and paste it here. And so now you've taken the starter notebook and created a snapshot that is saved on your profile. So the next time you want to continue your work, you need to open up this URL, which is on your profile, and then click run from there. Okay. Now here you have to run this line to install pandas. So we are not automatically installing pandas so that the assignment runs a little bit faster for you. But each time you run the assignment, just on Binder, just make sure to install pandas. And then we install import pandas as PD. So this is all done for you. So in this assignment, we are going to analyze and operate on analyze and operate on data from a CSV file. So this is the same locations.csv file that you saw, but we've cut it down to just 210 countries. So this is the information, health related information for 210 countries. And we will do some analysis on that. So here you can see questions like how many countries does the data frame contain? So you can try and answer this question. Here's a hint. You can also see the number here and put in the number directly, but here's another hint. So you have the countries df. We have seen the shape method, and the shape contains the number of rows and columns. So it seems like there is one row per country, and you can verify that by looking at some sample data and just make sure that there is one row per country. So you can then, in that way, you can check how many countries there are. And then you can take this information and then simply put it here, either directly like by typing the number or by simply getting the first element out of this tuple. Okay, whichever way you do it is completely fine. And then you answer the question and then you print it out. And at the end of the question, just run jovian.commit again. And we do that for every question just so that you don't lose any work. Then you can retrieve a list of continents from the data frame. So there is a method here. Here's a hint, use the unique method of the series. So you can see that for each country you have a continent. Can you get the full list of continents out from the data frame using pandas methods? Try to do that. Then there's a question to find out the total population across all the countries listed in the data set. So each country has a population. So if you add up all the populations, you get the total population of the world approximately, because there might be some small minor countries which are not included here, and the population also keeps changing daily, but this would give you an idea of the approximate population of the world. Now here's an optional question that you need not do, but it's an interesting one to try out. What is the overall life expectancy across the world? And your first thought may be to just take an average of life expectancies across countries. We have a column for life expectancy, but you might not want to do that because each country has a different population. So it's not right to say that you give an equal weight to the life expectancy of, let's say, Andorra, which only has 77,000 people, and a country like Afghanistan, which has 38 million people. So you may want to take a weighted average using the population as weights. So try that out. This is an interesting question to try out. Then we have basic sorting and filtering. So here we are asking for creating a data frame containing 10 countries with the highest population. So here you can use sort values and then you can use head. Then we are also trying to add a column here. So add a column into the country's data frame to record the overall GDP per country. So the overall GDP is simply the product of the GDP per capita, which is given in the data frame, and the population of the country. Then here is a slightly more complex question. Create a data frame containing 10 countries with the lowest GDP per capita among the countries which have a population greater than 100 million. All right. So that's just it's a 2 or 3 step problem, and you can try to solve this as well. And create a data frame that counts the number of countries in each continent. So this is, again, now here you might want to do some kind of grouping and aggregation. So here we are counting. So here we might want to aggregate using count. There's another question to show the total population for each continent. So you might want to group by continent and simply select the population column and aggregate it using the sum. So that was the first part. And then the second part is to merge this data with some COVID-19 stats. So once again, there is this file called COVID-19 countries data. So here for each country, we have the total cases, total deaths, and total tests. And a lot of countries, the total tests are actually not reported. So that's where you see nans. And that's what the first question is. Count the number of countries where the total tests data is missing. So just use the isNA method to do this. That is a hint here for you. And all of these, even if this hint wasn't available, you can simply say count the number of missing values in a column pandas, and that will give you this same result. So this hint is essentially just saving you a search, but do try that out as well. Then you will merge the two data frames, the countries data frame and the COVID data frame, using the location column, and that you might want to use the merge method for it. Now once you've merged it, you can calculate the tests per million, cases per million, and deaths per million. And then now you can look at what were the countries with the highest number of tests per million people, what are the countries with the highest number of positive cases per million people, and what is the number of what are the countries with the highest number of deaths per million people. All right. So that's something to try out. And then here's an optional question. Here is where you can try and check, okay, just to get an idea of maybe which country has managed things well. You might want to count how many countries feature in both the lists of the highest number of tests per million and the highest number of cases per million. So is it true that more testing necessarily leads to more cases, or are there cases where even with a small number of tests, you have a large number of cases, right? So do this kind of an analysis and really ask these questions of your data. We've only mentioned a few optional questions here, but you can go on and asking more questions, and that will let you draw your own inferences on how different countries are dealing with the outbreak. And then you might also have to go back and you have to figure out how these test numbers are reported, because each country tests differently. There are different types of tests. There is a test which is a test for the virus, and then there is a test which is a test for the antibodies. And it seems like both of these numbers, the total gets reported. Some countries are reporting only the number of samples and not really the number of diagnoses, or some countries are reporting just the number of diagnoses. Some countries are reporting just the unique number of people tested, and so on, right? So just keep that in mind, that there's a lot of nuance and a lot of subtlety in this aggregate information. So it's not always fair to just calculate these metrics and make assumptions or make inferences on top of it. Although that's a good starting point, but from that point you need to dig in and learn more. And the more original research that you do, the better your understanding of the situation improves. So please try and do as much as possible. In fact, and there's one more final question before that, and then I'll talk about the data set itself. So this question is to count the number of countries that feature in both 20 countries with lowest GDP per capita and 20 countries with the lowest number of hospital beds per million. But for this question, you should only consider countries with a population higher than 10 million. Okay. So this is a complex 3-4 part question. And then you can just, all you need to do is do it step by step. Get the list of countries with a population higher than 10 million, and then get the 20 countries with lowest GDP per capita, 20 countries with lowest number of hospital beds, and then count the number of countries which feature in both lists. And then you can see if GDP has, what kind of a relation GDP has with healthcare facilities in a country. Okay. And once you do that, once you solve each question, just keep committing. And then when you are ready to submit, just take the link. So the link that you get once you commit, this is from your Jovian profile. Just take that link. You can also get this link by clicking the share button and clicking the copy link button here. So take that link and come back to the assignment page and make a submission here. So you can just paste the link here. It needs to be a Jovian ML link on your profile. And when you do that, you can see here that it gets added. And you will see that the evaluation is currently pending. A few things to keep in mind is to always use a Jovian ML link, because we are going to do automated evaluation. So do not submit Binder links, because Binder shuts down after some time. Do not submit Kaggle or Colab links, because we cannot extract that Jupyter notebook out for automated evaluation. Okay. So with that said, I wanted to just share a little bit about where this data came from. So this data came from Our World in Data. So I just searched for Our World in Data, COVID raw data. And you can see here, this is the source data for this analysis. And in fact, what we've done is we've taken this original data set, which is in CSV format, and we've extracted out just the information for Italy. So one good exercise for you is to download this CSV file. And from this CSV file, we've done analysis for Italy, but what you might want to do is pick your country, and for your country, just extract out the same information, which is a data frame or a CSV file containing the dates, the daily new cases, new deaths, new tests. Just keep these 4 columns and then repeat the analysis for your country. And how do you repeat the analysis? So the way to repeat the analysis is, you take this lecture notebook that we have. So let's go all the way to the top here. And alongside, you open up a new notebook as well. So here I'm just going to go File, New Notebook. Okay. And keep these side by side and download the data for your country, or first create the data for your country and then download the data for your country. And then for your country, just start typing out each of these lines one by one. Download the data using URL retrieve, or you can simply upload it into the Jupyter notebook, and then you can start typing out each of these one by one. So import pandas as PD. And then if I have the data for India, I might do COVID df equal to pd.read CSV and India device.csv. Now, once that is read, then I might want to look at the data frame, and get some information about the data. So type out each line of code, and typing it out is a great way to just get some practice, because then you feel more confident typing it out. Then you feel more confident with each of these functions. You feel more confident, like you've learned pandas. And initially you're just looking at it and typing, but then with time, the notebook on the right goes away, and then you can simply type by looking things up online or by looking at the documentation or just from memory once you've done it enough times. Okay, so do this analysis for your country. Try to first create that data set for your country from the raw data, and I'll post a link to the raw data as well. So the lecture notebook that we will use is called Matplotlib and Seaborn tutorial. So let me open up the notebook. And if you have any questions during the lecture, you can ask them on the discussion forum that is linked here. Now on the notebook page, you will be able to see a run button. So I will be running the notebook right now, and you can run this after the lecture, so that you do not have to face a delay when thousands of us run at the same time. But we click run and then we click run on binder. And while this gets started, this might take a minute or two to get started. In the meantime, if you have any questions during the lecture, you can ask them on the discussion forum. So this is lecture 5, data visualization. This is the discussion forum, and you can just click the reply button, the big blue button on the bottom, and ask a question and click reply. And if you see a question that you like, just click the like button. All right. So coming back, we've clicked the run button and selected run on binder, and that has brought us to this page. So now we have a Jupyter notebook running in front of us. So let me just open up the notebook here, and I'm going to click kernel, restart and clear output. So that is going to clear all the outputs, and we can just see the code cells and execute them for ourselves. I'm also going to toggle the header and the toolbar. But you need not hide it, because the toolbar has many interesting and useful operations that you might need. So today's topic is data visualization using Matplotlib and Seaborn, and we've been building towards this slowly. So we've talked about the basics of Python. We've learned numerical computing with Numpy, analyzing tabular data with Pandas, and now we're looking at data visualization. And you can run this code. We are currently running it on binder, but you can also run this code on your computer. So the instructions for running it on your computer are given here. Okay, so let's get into it. Now, data visualization is the graphic representation of data. So what it involves is producing images that communicate relationships between the represented data to viewers. So the idea here is that a lot of the data that we deal with is in the form of numbers. It's in the form of tables or data frames or CSV files, and it's not really easy to look at a lot of numbers at once and understand something. But if you take the same numbers and then represent them using some kind of a picture or what is called a graph or a chart, then that leads to a better understanding of what the data represents and what the relationships between the different data points are. And in this lecture, what we are going to look at is some popular data visualization techniques, and we'll understand how to implement them using Python libraries, Matplotlib and Seaborn. So to begin with, let's import the libraries. So we'll import matplotlib.pyplot. That is the module that is used for doing most of the basic plotting. So we'll import matplotlib.pyplot with an alias of PLT, because that is the most common alias that is used in the data science domain. And then there is also a Seaborn library, which provides a Seaborn module, which we'll import as SNS. And this library is built on top of Matplotlib, and it provides many convenient methods that help you avoid writing a lot of code in basic Matplotlib. Okay. And apart from these two import statements, we also have this magic command matplotlib inline. What this does is this informs Jupyter that you want your graphs to show up as outputs below the cells where you've plotted them, and not as pop-ups. So without this line, sometimes you may see that your graphs show up as pop-ups. Okay. So that's the setup. Now we've imported matplotlib.pyplot as PLT and Seaborn as SNS. And to get started, we will study one of the simplest types of charts or graph data visualization techniques, and that is called line charts. And a line chart simply displays some information, especially a sequence of numbers, as a series of data points or markers, and these data points are connected by straight lines. So let's see what that means. So here we have some data. Here we have a Python list called yield apples, and it contains 6 numbers. What this represents, it's an imaginary data set, but it could be a real one as well. So what this represents is the annual yield of apples in tons per hectare over 6 years in an imaginary country called Canto. So there's a country Canto where they grow apples, and we've simply measured the annual yield of apples in tons per hectare over the past 6 years. Okay. So ultimately those measurements turn out to be numbers like this. So now we have the yield of apples, and by looking at this, we might wonder what the trend is looking like. So we have a certain idea by looking at this that it seems like the yield is growing over time, but it's not very clear how fast or slow the growth is and whether this growth is likely to sustain. So immediately the simplest thing that we can do is we can plot it on a two-dimensional XY axis coordinate plane, and we can plot these points on the coordinate plane. So the simplest way to do that is to use a line chart, which you can plot using plt.plot. So we say plt.plot and give it a sequence of numbers, and that sequence of numbers now gets plotted. So you can see that this was the number at the 0th index, 0.895. This was the number at the first index, 0.910, and 0.920, and so on. So already we can see that it looks like the yield of apples is growing with time, but it appears that the growth is slowing down. So it seems likely that over time this will flatten out around 0.95 unless we make some technological improvements or there is a significant change in climate or things like that. So that is the power of visualization. Just a simple graph. This is already giving you a lot of information. Now, one thing you may have noticed here is when we call plt.plot with yield apples, it draws the graph here, but it also gives an output. So this output is basically the result of the plot function. So the plot function returns whatever was called. And in this case, it returns a matplotlib.lines.lines2D object. And we may not want to always look at this in the output because we are mainly concerned with the graph. So one thing that you can do is you can include a semicolon after your code. So if we call plt.plot with the semicolon, you can see here that now we do not have that output, the line 2D output. We simply see the graph being plotted. And in general, while using matplotlib, you might want to just include a semicolon with the last statement so that you do not see an unintended output. Okay. So now we have a line plot and it's already telling us a lot, but let us enhance this plot step by step to make it more informative and beautiful. Okay. So the first thing that we are going to do is we are going to customize the x-axis of the plot. Now you may have noticed that here we know what the values or the yields of apples are, and this is plotted along the y-axis, but we do not know which years this data is for. And without that, this plot is not very informative. So the first thing that we can do is we can change the x-axis to show the actual years. So here now we have two sequences. We have years, which is 2010 to 2015, and then we have the yield of apples. And now we are passing to the plt.plot years. So this will form the labels on the x-axis, the text on the x-axis, and then the yield of apples. These will form the points on the y-axis. So in a sense, we are actually giving it now a list of points. So for 2010 on the x-axis, we want to point to 0.895. For 2011, we want to show 0.91 and so on. So we plot it now. And now you can see that you have the years 2010, 11, 12, 13, and 14 and the corresponding values. So that's great, but it would be nice as if we share this chart with someone, it would be nice to include information about what these axes represent. And these are called labels for the axes. So we can add labels for the axes to show what each axis represents using the plt.x label and plt.y label functions. And now one interesting thing to note here is that we've already called plt.plot, and any other plt functions that we call within the same Jupyter Notebook cell are going to get applied to the same plot. All right. So we can actually write these in any order, and all of these will get applied to the same plot that comes out as the output of this cell. So we call plt.plot, and that plots the two lines. And then we say plt.x label and set that to year. And then we say plt.y label and set that to yield in tons per hectare. And that gives us this result. So we have the year here, and then we have the yield in tons per hectare. So now this plot is starting to get a little better. Now what would be interesting is that, okay, we can see that the yield for apples is growing, but we may want to know if this is happening for other crops as well, or is it just that the whole agriculture sector is growing, so this does not really say a lot about apples in particular. All right, and so what we might do is we might want to plot multiple lines within the same graph, and to do that is really easy. So all you need to do is invoke the plt.plot function multiple times with different data within the same cell. So here let us construct some more synthetic data. So here we have data from 2000 to 2011, because in a range the last value does not get included. So we have 2000 to 2011. So there are 12 years, and then we have the data for apples and the data for oranges for 12 years. Now already you can see here there are about 25 numbers you are looking at here, and it's very hard for you to make an inference even if you spend a few minutes looking at all the numbers. And this is where a visualization is going to help. So now we're going to plot plt.plot years, and then plt.plot years with apples and years with oranges. So the x-axis remains the same. This is not necessary, but in this case we just want to keep the x-axis the same. And then we set an x label and the y label, and then we plot it. So there you go. So now you can see that we have two lines for apples and oranges, and it seems, since we already know that this was the graph for apples, it seems like the graph for oranges is going down. So based on this, you may form a hypothesis that it's probable that maybe the demand for oranges is falling or the demand for apples is growing. So maybe some of the land that was being used for apples is now being used to grow oranges or something like that. And once you have a hypothesis like that, then you can go back and investigate and find out if this is indeed the case. This is great, but just by looking at this graph, it's not quite clear which line represents what. So we already knew this was apples, and that's how we could tell. But you can actually include what is called a legend. So you can simply say plt.legend, and into the legend you can give a list of labels for each of the lines. So the labels will get applied to each line, and then you have the title. This title is applied to the entire chart as a whole. So now you see here, you can see a title, crop yields in Canto at the top of the chart, and then you have the apples and oranges, and then you have the yield in tons per hectare and the year. Now, as we add more lines, sometimes it can get difficult to understand where the points exactly are. So for instance, if we want to know the data for 2005, we have to estimate it a little bit. So we can tell that 2005 is around here, and so the value is probably this one, and that is about 0.908 or something like that. It's not very clear sometimes, especially in a graph like this, which seems to be growing linearly, where the points exactly lie. And this is where you can actually add markers to the points. So to show markers for the data points, we can simply use the marker argument of plt.plot. And matplotlib supports many different kinds of markers like circles, cross, square, diamonds, and so on. And you can actually see a full list of markers here. So if you visit this page, you just search for matplotlib markers. You can see what the value that you need to provide to the marker argument and the symbol it displays on the screen. Okay. So let's try out a couple of examples. Now we are going to plot the yield of apples, and we are going to use a circular marker for it. So apart from the line, there will be a circular marker, and then for the yield of oranges, we are going to use an X marker or a cross marker. So let's run this. So you can see now you have circular markers here, and then you have cross markers here, and they're also represented in the legend. So this is a little better, but you might want to style these lines and markers. Suppose you want to use these in a presentation, then you might want to include some of your brand colors and backgrounds and things like that. So to do this styling, to style the lines and the markers, plt.plot, the plot function, supports many arguments for styling them. So you can use this color or C argument to set the color of the line. And once again, there are many inbuilt colors that are supported within matplotlib. So here you can just search for list of colors in matplotlib. And you can see here that there are a lot of colors already supported. And if you want to use a color other than this, then you can use the RGB hex code of that specific color to set a custom color as well. So you can set the color and you can set the line style. So you can have a solid line or you can have a dashed line. Maybe you have one primary metric that you want to show using a solid line and the rest you want to make them dashed. You can do that. And then you can set the width of the line. In each line's width can be set separately. You can set the size of the markers and you can modify some colors of the markers as well, like the edge color, which is the outline of the marker, the edge width, the width of the outline, and the face color, which is the color of the filling in the marker if it has a filling. And you can also change the opacity of that specific line plus markers. So check out the documentation of plt.plot to learn more about what you can do. And here we've just included a few examples. So for apples, we are going to use a square marker and the color is going to be blue, and it is going to be a solid line with a width of 2 and the marker size of 8, and then the marker edge and the marker color is going to be different as well. And then for oranges, we are going to use the red color and we are going to use a dashed line. So we use 2 hyphens to indicate a dashed line, and then the line width and the marker size, etc. will also be different. And we are also setting an opacity of 50%. So for the oranges. So once we run this, now we see that now we have the crop yields in Canto, but now you can see that the lines are a little bit wider and the lines have bigger markers, and then the orange one is a little less opaque. It has an opacity of 50%, whereas the blue line, which is apples, is solid. So this is how you can modify the lines and the markers. Now there's one shorthand here, because often the most common thing that you want to do is to specify the type of line, the type of marker, and the color of the two things. So there is a fmt argument that you can pass into plt.plot, and that can specify the line style. So the way you specify it, you specify the marker first, then you specify the line style, and then you specify the color, all within a single string. So for example, here what we're doing is we're saying ears, apples, and then fmt is the third argument that goes into plt.plot. So you do not need to call it as a named argument. So you can just pass in the third argument. So here we are saying that it will have a square marker, it will have a solid line, and it will have a blue color. Whereas oranges, we are saying that they will have a dashed line and it will have a circular marker and it will have a red color. So you can use this shorthand from time to time when you're quickly drawing some graphs, just to differentiate between different lines. And once again, you can see that we've still copied over the X label, Y label, title, and legend. What you can do is you can take all of this. If you have plots that you want to draw in a certain way, you can take all of these and put them into a function, so that each time you pass in 2 lists of values, apples and oranges, all these styles are applied to them, right? So you can use all the nice things that Python offers, things like functions, modules, and so on, to organize your code and organize your graphs as well. Okay, now one exception here is that if in the format argument, if you do not specify a line type, so in this case we are plotting ears and oranges, and here instead of specifying a solid or a dashed line, we have skipped it entirely. So then the line will not be drawn and only markers will be drawn. So you can see here that you can just see the markers and not the lines. And this is a useful thing to have as well. Sometimes you might want to have a line for a particular set of data and you want to show points for another. So you can do that too. Okay. Now, if you want to change the size of the figure, sometimes the figure might be too small and you might want to increase the height of it, or you might want to increase the width of it. For that, you can use the plt.figure function to change its size. So you simply say plt.figure and then you set fig size, and then you give a tuple. So you can experiment with this, what the tuple does. So let me just try out 2, 2, and then you put in a sample value and see what 2, 2 gives you, and then use that to maybe make some changes. Let's try 8 and 4. So yeah, that way you can change the size and the aspect ratio of the image. Now already we are starting to draw pretty good line graphs, but one interesting thing that we can do just to make our charts a little more beautiful is to use the Seaborn library. So now we are going to use the Seaborn library for plotting, but one of its use cases is also to just improve the look and the feel of the graphs that we draw using matplotlib without doing anything additional. All you need to do is import Seaborn. So we have imported Seaborn as SNS, and then use the set style function. So the Seaborn contains a bunch of pre-defined styles within the library, and you can get the full list of predefined styles here at this link. So for instance, one of the predefined styles is white grid. So when we say sns.setStyle white grid, what happens is a certain set of styles get applied to all matplotlib charts, and this includes some background, some font colors, some other configurations, and we'll see an example of that. And this gets applied globally. So now this style is going to be used for any plot that we make using matplotlib or Seaborn. So now we do plt.plot, we plot apples and oranges in the exact same way that we did before, and we set the X label, Y label and legend. So we're not doing too much styling here. And you can see that you can already see there are some changes. So the font is a slightly different, and there is now a grid. So the grid makes it slightly easier to see, okay, where the values lie. For instance, you can see that this point is 0.93 and then this is 0.94. So this point is probably around 0.934. You do not have to draw an imaginary line in your head from here to here. You can just follow the grid. So that's pretty useful. And one style I like, so this is the white grid style. One style I particularly is the dark grid style. So you can just call sns.setStyle dark grid. And now we have the exact same code that we had in this cell that we're going to run, but it's going to have a slightly different style. So here now you see that now we have a graph where it has a background. So the part of the graph has a background, and then it has a grid as well. And then the colors are slightly different too. If you had used the default colors, then those would be slightly different too. You can see here that these colors are slightly nicer than the default colors that you will get with matplotlib. This is one of the benefits of using Seaborn, that it automatically makes your charts a little more beautiful. Now the next thing that, and here's one more example of that. So you can see that we've only called setStyle once, and then every subsequent plot that we do will automatically have that style. Okay. But if you want to, you can also edit the default styles within matplotlib directly. So matplotlib so you can import matplotlib, and then there is something called RC params inside matplotlib. In fact, you can just check it out. Let's say we just print it out here, matplotlib.rc params. You can see a whole set of values here. You can see there are probably hundreds of values, and you can change the font size, you can change the font family, you can change the background colors, you can change the default ways, the default grid, whether you should show a grid or not, and a lot of other things like that. You can change the default marker style, you can change the default line style, and so on. And the way to do it is to simply set RC params. So here, for instance, I'm changing the font size, the default font size to 14, and I'm changing the default figure size to 9,5. So just making it slightly bigger, and then setting the figure.face color to, this is basically transparent. So here, let me just take this same graph. So you just keep this graph, this picture in mind, and let me just take the same graph and plot it here. And you can see now that this graph is bigger. So this is nicer when you want to present, or let's say do a video. So I'm doing a video with you, I can show you this, and it's a slightly bigger graph, easier to see. And sometimes you might want a small graph as well. Now, one quick note here is any graph, if you want to just download it, you can simply right click and click save image as in whatever browser that you're using, and you can just save the image to a file. With that, we complete our discussion of line charts, and let us just save and upload our notebook to our jovian.ml account. So we just call pip install jovian, and then we import the jovian library, and then we commit. And then we commit the notebook using jovian.commit. So you can change the project name here to whatever you like. And this will ask us for an API key, which we can get from our jovian.ml account. So here I'm going to my account and clicking copy API key. And then I'm pasting the API key here. And what this does is this captures the entire notebook and puts it online for me to share and continue working on. So even if the binder instance shuts down now, we have the notebook on our profile, and you can see here that it contains the charts that we have drawn. And if we want to continue our work, we can simply click run and click run on binder once again to continue. So moving forward, next we are going to look at a scatter plot. So a line plot is primarily used to represent a bunch of values in a sequence, whereas a scatter plot is used to visualize the relationship between two variables as points on a two-dimensional grid. Okay, so what does that mean? A good way to look at it is by looking at an example. And for the example, we are going to use a data set that is already included within the Seaborn library, but you can also use any CSV file and import it using pandas. So here Seaborn contains a utility function called load dataset, and into load dataset we can give one of the predefined datasets that are included with Seaborn. So we have flower, and that returns a data frame in pandas. So this is our pandas data frame for flowers df, but you could just as easily have done pd.read CSV here and passed in a path to a CSV file, and that would have worked well too. So let's study this dataset. So it looks like this dataset contains 4 or 5 columns. So it contains, it is information about flowers. So these are some measurements made on a total of 150 flowers. So here we have 150 rows. So for 150 flowers in a garden, let's say, we've measured the sepal length, the sepal width. So sepal is a part of the flower, and then petal is another part of the flower. So then we've also measured the petal length and the petal width, and we've noted the species of the flower. So this is a typical data set that you might work with. All right, and this is you can learn more about it. Here's a link to the Wikipedia page. It is called the iris flower dataset. And the first thing that I wonder here is, okay, it seems like there are a lot of values of sepal length, width, petal and width, but the species seem to be limited. So the first thing that we can check is what were the species here. So if we just check the flowers df.species.unique, so it turns out that there are 3 species, Setosa, versicolor and virginica. Now let's try to visualize. You can see a lot of numbers here. So there's a sepal length and a sepal width. Now you might wonder, is there a relationship between the sepal width and the sepal length? Like when the length increases, does the width increase, or vice versa, right? Or is there an opposite relationship where if the length is low, then the width is high? Currently, by looking at just these numbers, it's hard to tell. You may have some idea that, okay, for 4.9 you have the width is 3.0, but for 5.1 the width is 3.5. So there seems to be an increase, but the relationship seems to be different here. Like the width is higher for flower 2, but the length is higher for flower 1, right? So it's not very easy to tell the relationship, and we can't even look at and grasp all the numbers at once. That's where we might to visualize the relationship, our first instinct might be to create a line chart using plt.plot. So we may call plt.plot, and remember that we need to pass in an x-axis, a bunch of values for the x-axis and a bunch of values for the y-axis, and then all those points will be plotted and connected with lines. So here we say flowers df.length and flowers df.sepal width. So this is a series, or the column, this is a column from the data frame, which is a series object, a pandas series. And that is similar to a list in the sense that it can be iterated over. So matplotlib can automatically work with anything that looks like a list. So a numpy array will do, a pandas series will do, and so on. So we plot it, and that leads to this plot, right? So this plot is not very pretty or very useful, because, and why do we end up with a plot like this? Because there are 150 values, and all of those values are in this range of, like in a small range of 4.5 to 8, you have 150 values for the sepal length. And then similarly in the small range of 2 to 4.5, you have 150 values of sepal width. And there is no natural order to either of these values, right? These are all completely random measurements. Earlier what we had was we had ears. So we know that the ears would increase. So at least one of them was ordered, but here there's no order. So in cases like this, especially you might, first time you might try something, just start with a plot like this and see, and if you get a bad output like this, then maybe a line chart is not the best thing to draw here. And the next thing that you should try is to draw a scatter plot. Now let's see a scatter plot. It's going to be somewhat similar to this, but instead of the lines, you will just have points. So for scatter plot, we use the scatter plot function from Seaborn. Now matplotlib also allows you to draw scatter plots, but it is a little bit limited in its power. So the scatter plot function in Seaborn is much nicer to use. So we just say sns.scatterplot, and then we say flowers df. So dot sepal length. So this is the x-axis, and flowers dl dot sepal width. These are the points on the coordinates on the y-axis, the corresponding coordinates. All right. And then once we call it, this is what we get. So now all the 150 flowers, the points have been plotted. Like for instance, this represents a flower with the sepal width of length of 5.5 and a sepal width of something around 2.3. And you can see that the scatter plot has automatically picked up the names from the series and shown them here as axes, as labels for the axes. And this is one of the nice things with Seaborn. It saves you a few lines of code every time by automatically doing the right thing. But we were concerned about the relationship between length and width, but there doesn't seem to be a clear relationship here. In fact, like the points seem to be all over the place. But if you notice carefully, you will notice about 2 or 3 clusters. So you can see this one cluster of points here. These are all together, and then there are some outliers. And then you can see another cluster of points around here. These are all together. And then you can see another cluster of points here. So there seem to be 3 clusters of points, and you might have a hypothesis here. Okay, there are 3 species of flowers, and now we can see about 3 clusters of points. And it makes sense that across different species of flowers, we may not really see a relationship, but maybe if we just study a single species separately, maybe we might be able to find a relationship. All right. So this is where you can use the hue argument to scatter plot. So here now we are specifying flowers df.sepal width, and then we are also specifying a hue. So what the hue says is that you pass it another column or another series which has the same length as these two. So for each flower we also know a species, and now for each distinct value of species, the corresponding points will get a different color. Okay. And then one other thing that we are doing is we are increasing the size of the points. So you can just make the size of the points larger, and you can try experimenting with a few values here. I tried it and I found 100 to be a good value. Okay, so now we have this graph. So now here we have the sepal length once again and the sepal width, but now the dots are slightly bigger because we have a bigger size, and they are of 3 different colors. So now we have setosa, which is blue. So all the setosa flowers are here, and as we had guessed, so they do form a cluster. And then versicolor are orange, and then virginica are green. And now you can also visually see there does seem to be a relationship here, that in setosa flowers, the sepal length tends to be a little bit low, whereas the sepal width tends to be high compared to other flowers. And there is a general relationship. Probably as the flower grows, both the sepal length and width grow proportionately. So there seems to be like a line that you can cut through. Obviously there are more factors involved, so this is not a perfect relationship, but you can see that there's some kind of a rough linear correlation. Then similarly, you can observe a similar trend for versicolor, maybe not so much, but versicolor values are somewhere in between both the width and length. And then you have virginica. So virginica tends to have pretty long sepals, but the width seems to be pretty small. And virginica also seems to be more spread out. So it's not as concentrated or as close to a linear relationship as we have seen in the others. So then we might want to go back and learn more about virginica. Maybe there are multiple classes of virginica flowers, or maybe they behave differently for a certain region. So this can inspire research when you plot a graph in fashion like this. Okay. And now we have a great plot, but it is missing a few things. One, it would be nicer to make this figure a little bit bigger, so we can do that. And the way to do that is because Seaborn builds on top of matplotlib. So whenever you call a Seaborn whenever you call an SNS.scatterplot or a function like that, along with it, you can also include some PLT functions within the same cell. So you can say plt.figure, and that will apply to the same chart that is being drawn by scatterplot. And then you can say plt.title, and that will apply to the same chart as well. So in this way, you can mix and match things from matplotlib and Seaborn. And this interoperability is sometimes really useful. So now we have a title, and now you see that because we had a more wide graph, the legend was moved to this corner, and that allows us to see some points here. Then we have the sepal width and the sepal length as well. So this is how you modify a plot drawn using Seaborn. Now, one other thing I want to mention here is that Seaborn has a great inbuilt support for pandas data frames. So instead of passing each column as a series, you can also simply pass column names and then use the data argument to pass the data frame as the source for the data. So for instance, you can say here we have sns.scatterplot, and here we can say that we simply want to use the sepal length column as the X and the sepal width column as the Y, and the hue should be the species column, and then pass in a single argument called data where we pass in a data frame. And then Seaborn will automatically pick these columns from the data frame for the respective axes. So you can see here we get back the same result. So that's it for scatter plots. Now, I hope you're getting a sense of when you might want to use a line plot and when you might want to use a scatter plot. And even if it's not very clear yet, the best thing to do is just to try it out. That's the best thing about Jupyter Notebooks and about Python, that you can just first draw a scatter plot and then draw a line plot and see if it looks good, if it serves your purpose. If not, draw a scatter plot. Maybe that will help you. Visualize the data better, and so on. The next plot that we're going to look at is called a histogram, and a histogram represents the distribution of data for a single column or for a single type of variable essentially. So what do I mean by that? I think the best way to look at it once again is using an example. So once again, we load up the flowers data set, the flowers data frame, and let us just look at the sepal width this time. So let's not concern ourselves with other columns. So histograms are typically just the data for a specific column. Now you're looking at a bunch of values here, and it seems like there is so you might wonder, okay, what is the range of sepal width in terms of the smallest and the largest value? And one way to do that is just to do flowers df dot sepal, or you can just do flowers df dot describe. Remember the describe function on data frames. So if you call the describe function, then for each numeric column, it tells you a bunch of statistics. If we look at sepal width, it seems like the minimum value is 2 and the maximum value is 4.4. So you already know a little bit. And then the mean is 3.0. So that means 3.0 is the average, and then there is standard deviation of 0.43. And okay, that's good that now we know more than we did earlier, but it is still not very clear where the values lie. If we had to count, okay, how many values lie between 2.5 to 3 and how many lie between 3 to 3.5, we might not that way. And then if we were to plot that somehow, then it would be easier to visualize the visualize the distribution of the values along this range. And that is where the histogram comes into picture. That within the range of values that a variable takes, so sepal width in this data set takes the values from 2.0 to 4.4. So within the range of the values it takes, how are the measurements, how are the data points distributed? So let's just see it now, and then we'll talk a little more about it. So here we are saying plt.hist, HIST for histogram, and we simply pass in the sepal width column to it. And we've also set a title, distribution of sepal width. Okay. So now we have this graph. So let's just spend a couple of minutes understanding what this graph represents. So here as we saw earlier, the range of values is from 2 to 4.4. Now this entire range of values taken by sepal width is split into 10 parts here automatically. So that's the default setting, and we can change that. So it is split into 10 intervals, and you can probably guess that this would be around 2 to 2.2, and this would be 2.2 to 2.4, and this would be 2.4 to 2.6, and so on. And then what we do is we look through the column, we look through this data of sepal width, and then we count how many values lie in this range. So in this case, about 5 values lie in the range of 2 to 2.2, and around 4 values. So we draw a bar which goes up to the height of 4. And then similarly, we count the number of measurements that lie within the range 2.2 to 2.4, and then we draw a bar which shows the number. So this number seems to be around 7, and so on. So now when you study this, it seems like somewhere around 3.0. So it seems like from 2.9 to 3.1, somewhere around that range, there are 36 measurements. So that is where a large number of measurements lie. And then it seems like there are more measurements on the larger side than on the smaller side. So from 3.2 to 3.3, let's say 3.4 or something like that, you have another 30 or so measurements. Okay. So already now we know how the values are distributed, the values of sepal width, the measurements, how they are distributed in the range that they take. Now these bin intervals are currently a little bit arbitrary. We may not want to check between 2 and 2.2. That's a little bit arbitrary. We may want to have a fixed number of bins, or we may want to decide what the intervals, the bins. So each of these intervals is called a bin. So interval is a mathematical term and bin is the statistical term used with histograms. They mean the same thing. What we can do is we can specify the number of bins. So if we, let's say instead of the 10 bins, we wanted to see just 5 bins. So here now we can split the entire range into just 5 bins. And now we can see that, okay, obviously now if the bins are larger, the interval is larger, then between 3 to 3.4, it seems like you have a total of close to 70 values. Or what we can also do is we can specify what should be the points at which bins should be created. And the way to do that is to give a list or an array as an input to the bins argument. So there's a bins argument. So here we are giving an input. Let's just see what this does. So we are to the bins argument, we are passing np.arange. So let's see what that does. So np.arange 2, 5 and 0.25. What this says is create an array that starts at 2, goes up to 5, not including 5. So goes up to 5 and it takes steps of 0.25. So we have 2, 2.25, 2.5, 2.75 and so on. Okay, so now we can take this array and we can give that as a list to bins, and then the matplotlib will automatically create an interval between each two consecutive numbers. So 2.5 to 2.25 to 2.5, 2.5 to 2.75, 2.75 to 3 and so on. So these are much nicer boundaries to have, I think, in this case compared to what we had earlier. So you can see now we are going between 2.0 to 4.5, and then we have these nice intervals that line up with our measurements. You can also have bins of unequal sizes if you want to. So here we have simply set the bin measurements to starting from 1 going up to 3. So that's a bin of length 2. And then starting from 3 going up to 4. So that's a bin of length 1, and then a bin of length half. So there you go. Now we have 3 unequal bins, and obviously when the bins are unequal, the data points that lie in each bin, the number of data points will change. But you can still see that even though the 3.3 to 4 bin is a little bit smaller, half the size of the first bin, it still has twice as many values. So this is how you can play around with histograms. Just change the number of bins and the size of each bin. But I hope you get the idea that the basic idea here is it tells you how a single variable like the sepal width, how its measurements are distributed along the full range of values that it takes. Okay. Now, similar to line charts, we can also draw multiple histograms on a single chart, and we can reduce the opacity of each histogram so that, because there are bars here and these are opaque bars, if one of the histograms is going to be drawn on top of the other, and typically this is the order in which they are listed. So the first one that you list is drawn at the bottom, then the second command that you include is drawn on top of it, and so on. So some of the bars of the first histogram may get hidden by the second, and to avoid that, what you can do is you can simply set a lower opacity for each of the histograms. So what we are doing now is we are taking the same flowers data frame, but this time we are going to filter out just a specific data frame for each species of the flower. So here we are saying flowers data frame where the species is equal to setosa, and similarly we have versicolor, and similarly we have virginica. So you can check here that for setosa DF you only have setosa flowers, and you can verify the same for versicolor and virginica. So you have 50 flowers in each, and you can check that. Now let us plot setosa and versicolor using two different histograms. And once again, you can set the color using the C argument, but by default, if you simply plot two of them, Matplotlib will automatically cycle through different colors. So let's plot them, and we are plotting them with an alpha or an opacity of 0.4. It might be helpful to add a legend here as well, because we don't know which one is which here. So if I just do plt.legend, and here we can say setosa, that should be the first one drawn, and versicolor. All right, so here we go. So now we have setosa and we have versicolor. So setosa is blue. So it seems like the setosa flowers, the sepal width seems to be on the higher side, mostly higher than 3.0. Whereas for versicolor, the sepal widths tend to be on the lower side. So mostly between 2.2 to 3. And that's already a lot more information than we had earlier. So this is one way to show multiple histograms. But what we can also do is we can stack histograms on top of one another. So we can, rather than showing this on top of, rather than when I top, like above. So here actually it is, both are overlapping, but what we can do is we can put this bar above the previous bar. And the way to do that, it is actually a little bit easier, is into plt.hist, instead of passing a single set of values, you can pass multiple arrays. So we can pass the setosa df sepal widths, and we can pass the versicolor df sepal widths and the virginica sepal widths as a list. And then we simply specify the same set of bins that we want. And then we say that we want to stack them. So we set stacked equals true. And once we do that, you can see here that the bars get stacked, right? So there are these many. So for setosa, we can see that in the range of 3 to 3.25, there are these many setosa flowers and these many versicolor and these many virginica. Excuse me. And these many virginica flowers. And now this histogram obviously is a lot more informative than before. So you can see the overall trend, but you can also see the trend for each species of flower. So you can see that setosa lie in this range, and then virginica in this range, and versicolor in this range. So let us save and commit our work before continuing. Okay, so now we've looked at line charts, scatter plots, and histograms. The next type of chart that we're going to look at is called the bar chart. And a bar chart is conceptually very similar to a line chart in that they show a sequence of values, except that what we do is we use a bar for each value. We show a bar for each value rather than we're showing points connected by line. And let's just see that as an example. So let's maybe first draw a bar chart for this data. So here once again we have the data for apples and oranges, and then years. So first we might want to draw let's say plt plot, and we say years and apples. Oops. Yeah, so here we have a line chart showing the yield of apples. So that goes from around, it seems like it goes from in the range, it goes from around 0.35 to 0.9 and then goes up and down. Now a better way, now this is great to study the trend. Line charts are great for that, but they're not very useful for comparing individual values, right? So you can tell probably that this value and this value is a little bit higher than this value, but it's not visually, it's not very obvious. And that is where when you want to compare data across multiple years, then it might be better to plot a bar chart. So we can just say plt.bar. And the only difference here is instead of there being points and these points being connected by lines, you have a bar for each year, and then the height of the bar goes up to the data points value, which is the yield of apples. Say plt.bar, and here we have the yield of this is the yield of oranges. So let me just plot oranges here. Yeah, so this is the yield of oranges, and you can see that the same thing is represented here now, and you can see that now it's not that easy. It's maybe not as easy as a line chart to visualize the relationship on how the trend looks, but it's definitely easier to compare across. So if you want to say between 2003 and 2005 or between 2004 and 2001, it's very easy to look through and identify. And one trick here is that you can actually draw bar charts and line charts together. So let's take this plt.plot, put it here. Let's also add a marker here. So let's make it a red line, let's make it a circular marker with a dashed line and a red color. And let's also take the bar chart here, and let's put the bar chart behind. So first we will plot the bar chart, then we will plot the lines, and let's set a title. Okay, so there you go. So now we have a graph which shows both the same data, yield of oranges, both as a bar chart and as a line chart. So now it's easier to study the trend, and now it's easy to compare multiple values as well. And you can choose based on what looks better for you for that particular data set. You can choose which one to use, or you can use both. And then like histograms, you can also stack bars on top of one another. So for instance, here we can plot the yield of apples, and then we are plotting the yield of oranges, but we do need to specify that we need to use a bottom argument for the second bar. So here we are specifying that the bottom for oranges is apples. So this tells that the bars for oranges should be drawn at particular heights. So here you go. So now you can see the trend for apples. So you can see how the yield of apples changes. You can see how the yield of oranges changes. And then you can see how the overall yield, let's say this is the yield of fruits. So what is the overall yield of fruits? How is that changing over time? Okay. So that's the bar plot. And this was a convenient case because here we already had a single value for each item on the x-axis. So for each year we already had the average yield, but that may not always be the case. Sometimes we may want to show not a single metric, but we want to show an average of many columns on a bar chart. And let me show you what I mean by that. And for that, we are going to use another dataset that is included within Seaborn called the tips dataset. So this dataset contains some information about customers visiting a restaurant over a weekend. So from Thursday to Sunday, a bunch of customers visit a restaurant, and for each customer we note down a bunch of information. So for each customer, the information that has been noted down is the total bill, the tip given by the customer on the bill, the sex of the customer, and whether the customer was a smoker, and what time or what day it was. So whether it was Thursday, Friday, Saturday or Sunday, what time of the day it was, whether it was lunch or dinner, and what was the size of the party. So how many people were there in that group along with the customer in total. Okay, so this is the tips data frame, and you can see here that one of the questions that you might want to ask is, what does the average bill look like on a particular on every weekday or on every day? So how does the average bills between Thursday, Friday, Saturday and Sunday compare? And to do that, you might have to do like a group by operation. So actually let's try to do that maybe. So let's say we have tips df, and you might do group by. Yeah, so you might do group by, and on group by you may group by day, and then from that group by you may select simply the total bill, and from that you might then do mean. So now you have, this is the average total bill for on the days of Thursday, Friday, Saturday and Sunday. Okay, and then you can draw bar plot here. So you can just say plt dot bar, and here you can just pass in tips df dot, let's just call this bill average df. So now we want to provide an x-axis and a y-axis. Now unfortunately in the bill average df, the day has become the index, so there's no longer a day column. But what we can do is we can simply use the index column. The index column is called day, and then we can pass in the bill average df dot total bill. Okay, and now we have the total bill, average total bill compared across Thursday, Friday, Saturday and Sunday. But we had to go through 2 steps here. We had to first do this group by operation, and then we got the average, and then we plotted it. But since this is such a common thing to want to know, that you may want to see that for, let's say, for days, but then you may want to see how does the average bill compare across men and women, how does the average bill compare across different let's say smokers and non-smokers and so on, and that will involve all of these calculations. And that is where we can use the Seaborn library, which provides helper functions so that we don't have to do this calculation. So instead of doing that entire calculation yourself, what you can say is you can call SNS, so seaborn.bar plot, and the bar plot is the plot for drawing bar charts in Seaborn. And you can specify, so here we have specified the data as the tips df data frame, and here we have now specified the day as the x-axis. So we now say that we want to group on the day, and we want to average the total bill, right? So on the x-axis we have the day, and on the y-axis we have the total bill, and Seaborn will automatically calculate the average and now plot a graph. So now you can see Thursday, Friday, Saturday, Sunday. We see a very similar graph, similar to what we saw here, but this is done automatically for us. And another thing this includes here is this line. So this line tells you that what was the variation in the values. So I think it's called confidence interval if I'm not wrong. basically what it tells you is that 50% of the values lie in this range from here to here. So you can see that there's a lot more variation on Friday in the bill, even though the bill is lower compared to Thursday. On the other hand, on Sunday, the bill seems to be the highest and there seems to be a much lower variation. And then Seaborn has also automatically added these labels here: Thursday, Friday, Saturday, Sunday, the day and the total bill. So in a lot of cases, I find myself using sns.barplot rather than doing plt.bar, especially when there is some average to be computed. Okay. One thing that we can also do is, just like a scatter plot, we can specify a hue argument, and that can be a third argument. So let's specify hue as sex. So we know that here in this data set, we have male and female. Let's specify hue argument apart from the day and total bill. And now you can see that for each day, you have 2 bars. So you have 1 bar for male and 1 bar for female. So it seems like on average, you can see that the bill for the female is lower than the bill for the male. And there also seems to be, if you look at Friday, there also seems to be more variation in the bill from males rather than the bills from females. And then you can look closer into the data set. Maybe you can go and investigate and figure out why this is the case. Why is the total bill lower for female? Is it? And similarly, you can specify, you can just say filter on smokers. Let's see if the average bill for smokers is lower or higher. Yeah. So if a person is a smoker, it seems like on average their bill is higher, but then there seems to be a lot of variation. So I'm not sure if we can make that assessment, if we can make that inference very confidently, but that seems to be true on average, except again on Friday seems to be an exception, right? So the correlation between total bill and smoker is not as high as the correlation between total bill and or the average total bill and sex. Now, one thing that you can also do is you can make the bars horizontal simply by switching the axes. So you can go from day total bill to total bill day, and that will switch the axes and draw the bars horizontally. And sometimes these are slightly nicer to look at, and it's really up to you. And like on a case by case basis, you decide what looks better for your use case and do that. A good point where you might want to make these horizontal bars is if, let's say, you had a lot of values here, right? So if you had a lot of values here on the x-axis, you may instead want to make them, let's say the x-axis was countries and not days of the week. So then you would need to show 200 countries, and that's very difficult to show. So rather, what you might want to do then is use a horizontal plot. So you can show a list of 200 countries here, and then the y-axis could represent, let's say, something like population. All right. So that's it about bar plots. And once again, let's save and commit our work before continuing. And the next kind of chart, so we are only looking at a few common charts here, the ones that are used most frequently. And in fact, if I have to tell you from my experience, around half of the plots that I tend to end up drawing turn out to be line plots, sometimes bar plots, and then those where the line plots do not make sense tend to be scatter plots. And histograms are useful when you are visualizing a specific variable, just a distribution of values. So histograms are pretty useful as well. And then there is this last one called heat map, which you will use from time to time. Not very often, but this is also one of the most common plots. So to understand what a heat map is, it's used to visualize a 2-dimensional data like a matrix or a table using colors. Now that's probably not telling you a lot, but the best way to understand it is to look at an example. So what we are going to look at is we're going to use a data set called flights. Once again, this is included within Seaborn. So we say sns.load dataset flights. So here what we have is we have data for years, for a bunch of years. So starting from 1949 to 1960, and then for each month, starting from January to December for each year, we have the total count of passengers in thousands. So these are the count of passengers who visited a certain airport. So this is the footfall at the airport. Okay. And we don't know, I can't recall which airport this is, but let's assume it's an airport. So in January 1949, 112,000 passengers visited the airport. In February of 1949, 118 passengers visited the airport, 18,000 passengers, and so on. We have this data for 1949 to 1960. Now what we may want to know is, what does the trend look like? What does the trend of passengers coming to this airport look like? Is it increasing or is it decreasing? And we could do a line plot. So we could simply do plt.plot. So this we have, let's call this df. Let's simply do df.passengers. And it seems like there's an increasing trend, but you can see that things go up and down. And a nicer way to visualize this, in my opinion, would be to use a heat map. And for using a heat map, we could, first of all, we have to represent this data as a matrix. So here what we're going to do is we're going to use the pivot argument. We're going to use the pivot function on pivot method of a data frame. And we're saying that we want to pivot on month and year. And what that does is that creates, that sort of puts this data frame into more of a matrix kind of a format. So now instead of the rows, instead of the columns being year, month and passengers, the months become the rows. So for each month we have one row, January, February, March, and all the way up to December. And for each year we have a column. So here we have 1949, 50, 51, all the way up to 1960. So there's still a pandas data frame, still the same data represented in a different way. And then the element at a particular, the value at a particular position. So let's say 51 February, this is the number of passengers in thousands, of course, that was there in the original data frame. Okay. And you can look up the documentation of pivot to learn more. But now we have this matrix of values, all of which is representing a count of passengers across. So one axis is the months and one axis is the years. Okay. And looking at this matrix of values, it's not easy to tell what the trend looks like. It seems like the values increase over the years, and it seems like the values increase up all the way up to June, July, and then decrease. But it's still not very obvious. And this is where we can use a heat map. So all we need to do is first get the data into this format, right? And you've seen how to do that. You can using the pivot method, or sometimes you can simply use a NumPy two-dimensional array with all of these values. And then we pass in this into sns.heatmap. So once again, this is a Seaborn, something that Seaborn gives you. And we're also setting a title here. So once we create a heat map, we get this nice visualization. So this is a visual representation of the same information. So instead of the numbers, now we see colors. And then you can see that the darker the color represents a lower number. So you can see this legend here on the side. The strip, it tells you that the darkest color, black, is closer to, let's say, 100 passengers, whereas the lightest color, which is close to a very pale color, that is about 600,000 passengers in thousands. And then now you can see the trend a little bit better. So it seems like over the years we go from dark to bright. So that means over the years the traffic seems to increase. And then within a year, we go from dark to bright and back to dark. So that's the same trend that you can see everywhere. So it seems like, once again, that the traffic increases up to June, July, and then decreases once again. Okay. And this heat map is pretty useful here to visualize this relationship in a single glance. Then once again, what we can also do is we can also show the values here apart from the colors. So we simply set anot equal to true. So just use the argument anot equal to true, and that will also show the numbers. And then we have the C map. So here it uses this color map of going from very dark to very bright. I actually would prefer the opposite here. I would want a lighter color to show a smaller number of passengers, and a darker color to show a higher number of passengers. So you can search for color maps in Matplotlib, and there are a lot of pre-included inbuilt color maps. I'm going to use a color map called blues. So that's going to be slightly different from what you saw before. And this is what that looks like. So now we are showing the number of passengers, the actual value, and we are showing a background color behind it. And the background color goes from very light, showing a small number of passengers, to very dark, showing a high number of passengers. So here now you can see that once again the same trend, that the number of passengers increases over the years, and the highest footfall seems to be around July. Okay, so that's the heat map. And the main reason, you may not draw a lot of heat maps yourself, but you may come across a lot of heat maps as you're looking at tutorials or notebooks drawn by other people, and then over time you'll start to see when they make sense, and then you can start including them in your own visualizations. So next up, we've looked at 5 types of graphs, and that's pretty much it in terms of the types of plots that we are looking at. But matplotlib can also be used to display images. So to display an image, let's first download an image from the internet. So this is the image. You can follow this link to see where what it looks like. And we are using the URL retrieve function from the urllib.request module for this. Okay, let's just try that again. Yeah, so the image is now downloaded. Now before the image can be displayed, it has to be read into memory. And to do this, we use the Python imaging library, or the PIL module. And from the PIL module, we import the image class. And then to the image class, there is a method called open. So this creates an image. So this is an image, and then you can check the type of this. So this has a type of PIL.jpg image plugin.jpg image file. So image.open automatically converts this into a certain class within a certain object of a certain class within the PIL library. But internally, PIL is simply using a NumPy array, a 3-dimensional NumPy, to represent this image. And we will look at that array. But first, let us display the image. So to display the image, we can use plt.imshow. So we just say plt.imshow, and then we put in the image, the PIL image object. And this is what the image looks like. So it seems like the image itself is the image of a graph. It is actually a meme about a bar plot, where one of the bar plots has a very high variance. The confidence interval is very large. And so the other bar plot says, sorry, we just can't trust you. And that's the image. And it seems like this image is displayed, but along with this image, an axis is also displayed. Now you see this is drawn by matplotlib. So you see it seems like it goes from about 0 to 480, and again 0 to 600 and something. So this image is of height 640, and this image is of width 640, and it is of height around 480. And you might know that images are represented using pixels. So each point, so when we say 480 is the height, so there's a pixel or a point. There are 480 points vertically, and then there are 640 points horizontally. So in some sense, it is a matrix of points. So it is a matrix of points with 480 rows and 640 columns. Now what does each point contain? So each point is actually a point on the screen, which is called an RGB pixel, or a red, green, blue pixel. So how images are displayed on the screen is that you have a red pixel which shines with a certain intensity, and then you have a blue pixel which shines with a certain intensity, and then you have a green pixel which shines with a certain intensity, and all of them together form one pixel of a color image. And as we vary the intensities of the red, green, and blue lights, that leads to all the different colors that we see on our screens, millions of colors. So that's what an image is. And if you want to see the internal representation of an image, so you can simply do np.array and pass in the image object, and that will create an image array. And then you can check the shape of the image array. So as you might expect, the image array has 481 rows and then 640 columns. So that means there are 481 cross 640 pixels points on the image, and then each point is again has 3 values. So these 3 values are the color intensities of red, green, and blue, and typically these values go from 0 to 255. So we're getting a little bit into like how images are represented and so on. It's a little bit outside the scope of this tutorial, but let's look at it anyway. So you can see here that there's a 3D array, and then each pixel is represented using 3 values R, G, and B. And then these values can go from 0, which means that the red light is completely turned off, to 255, which means that the red light is completely turned to a full value of like bright red, and then similarly green and blue. Okay. So that's a little bit about images, but the key idea here is that you can actually display images using plt.imshow. And now if we do want to just see the image and not see the axis and the grid lines, so then we can simply turn off the grid. So we say plt.grid false, and then we turn off the axis, and then we say plt.axis off. So this is a little bit odd, where for grid you say false and for axis you say off. But you know, these are just same things that you can look up. You can always just search online how to disable the grid in Matplotlib. So by grid, these lines, these white lines that seem to be cutting the image, and then the axis, by axis, these x-axis and y-axis, which has a bunch of values here. And we also can set a title for this plot. So here once again we have the actual image now. So it seems like the image had a border internally, that's why you see a border, and we have a title for it, and then you can look at the image. Okay, now we can, since I mentioned that this image is a NumPy array, we can actually also display just a part of the image. So all we need to do is we need to select which columns and which rows we want to show. Let's say we simply want to show this portion. And if I go back to this image where we had all the axes, so if we just want to show this portion, then I might start from picking from the 120th row to, let's say, the 320th row. And I might pick somewhere from the 100th row to the 100th column to the 300th column. So that might give me just this section. So that's what we do here. We say img array, and here we say 125 to 325 and 105 to 305. So we've picked certain rows and certain columns. And now when we pass that into plt.imshow, it will only display that particular section of the image, right? So you can see here now it only displays this particular section from a certain set of columns and a certain set of rows. So that's how you effectively, what this means is we have zoomed into the image. So that's it about images in Matplotlib. Then we have plotting multiple charts in a grid, because we've seen different types of charts. We've seen how to plot images, but there are certain cases where you might want to show certain charts side by side, certain different charts, right? Not just, let's say, two lines within the same plot, but you may want to show a line plot and a scatter plot and an image side by side. And this is possible. This is actually really easy to do in Matplotlib. So let's look at it. So the way we do it is to first call plt.subplots. And then in plt.subplots, we pass in the number of rows that we want to see and then the number of columns. You can see here, we get back some 1, 2, 3, 4, 5, 6 plots. There are 2 rows and 3 columns, and then you can change this and see how that varies. So now here we have 3 and 3. So that's a good starting point. Now the next thing that you might want to do is, because you can see that these values are overlapping a little bit, so you can actually specify spacing between these. So you can just say plt.tight_layout. And then in this tight layout, you can specify a pad argument. So I'm just going to set pad equals 2. So now that is going to give some space. So now you have space between each of these graphs. So it's starting to look a little bit better. And now we need to start filling these graphs. So to start filling these, we need to use the result of plt.subplots. So plt.subplots returns 2 results. So it returns a figure, so something called a fig, and then it returns axes. And we'll see what each of these mean. But yeah, let's just get the return values out. And let's just look at what the axes contain. So the axes, it turns out, is a NumPy array. And this NumPy array just contains what is called an axis subplot object. So each of these is an object. So if we check axes.shape, it has the same shape that we had set. It has the same shape that we had set for within plt.subplots. So 2 rows and 3 columns. So if we just check axis 0, 0, so that seems to be an axis.subplot function, right? Axis.subplot object. Now this subplot object is something that you can use for drawing plots. So just as we do plt.plot, we can do axis, we can pick a particular subplot axis like that object, and then we can say plot, right? So axis 0.plot, and then here, let's say we want to plot a line chart. So let's say we want to plot the yield of oranges. So we say ears, oranges, and once again, we want to make this a circular markers and have a dashed line and make it red. So we can do that. And now you can see that we've plotted oranges inside this small subplot. Let's go one step further. We can once again take this axis 0, 0 and let us set a title for it. So let's set the title yield of oranges. Let's also plot apples maybe. So for apples, we are going to use a square, and then we are going to use a blue color and solid line, and let's set a legend. So you can do all of that just within that specific plot. So we can set legend, and the legend is apples and oranges, or yeah, let's move apples up. So apples and oranges. So we use it exactly like plt.plot, but there are a few differences. And to understand these differences, you can refer to the documentation. I'll provide a link below. So to set the title, you need to actually call set_title. And then if you want to set labels, so let's say we want to set X label and Y label. So in PLT, we were doing .x label, but here you need to do set_X label. And this is just it's just a specific thing, an implementation detail within matplotlib, which unfortunately we have to deal with. So you just say set_X label. So X label is the year, and then similarly we set the Y label, and the Y label is the yield in tons per hectare. Okay, so that's it. Now within that particular axis, we have drawn a pretty complicated chart here. You can see here. Okay, maybe I don't want a legend. Maybe the legend is too much in a small graph like this. So yeah, let me just hide that. You can see now, you can see this is crop yields. So now if this is getting a little bit too cramped, you can increase the size of the figure. So you can specify a fig size, and let me set the fig size to 12,9, and let's see if that makes it better. Okay, so now the figure is a little bit better. So now we have crop yields. Maybe we can even add back the legend. Alright, so there we have it. Now we have the crop yields for apples and oranges in yields tons per hectare, and then we have the year here, and then we have a title for the graph. So that we've done for the first one, and similarly we can do it for the next one as well. So now we pick axis 0, 0. We pick axis 0, 1. So that would be this one. Now here, let's do a scatter plot. But to do a scatter plot, we need to use sns.scatterplot, right? So we say sns.scatter plot, and here maybe we want to visualize, let's say flowersdf.sepal length and flowersdf.sepal width. So let's just take that and put in sepal width, and then we want to give it a hue. So we set the hue to flowersdf.species. Okay, and then we want to set the size to 100, the size of the dots, and we want to give it a title. So we want to give this a title of sepal length versus width, let's say. Now one issue here is that we've not passed in the we've not specified which axis the scatter plot should be drawn on, and that's where Seaborn provides an AX argument, and to this AX argument you can specify axis 0, 1, and here this one should also be 0, 1. Okay, so we've now specified the axis. So for when you're using matplotlib, you can directly call functions on the axes, but when you want to use Seaborn, you simply pass in the axis into the Seaborn scatter plot or whatever function you're using. Okay, so let's run that too. Oops, it seems okay. So we need to set set title. All right, so this is where I get confused sometimes, but we need to call set title for the axes. Okay, so now you see here, now we have the sepal length versus width. Species are Sentosa, versicolor and virginica, and these are the plots. And similarly, you just extend this forward. So here once again we are creating a plt.subplots. We have used a figure size of 16,8, and then we are plotting, here we are plotting a line graph. Then here we're plotting a scatter plot. So these two we just did ourselves. Then we can also similarly here, now we are plotting a histogram. So in the third position, we are plotting a histogram. So for histogram, we directly use .hist on the axis 0, 2. Then we are plotting a bar plot. So here is a bar plot from the restaurant bills data set. Then we are plotting a heat map. So on like axis 1, 1, and then we are passing the same heat map. We're passing the axis into the sns.heatmap function. And finally, we are plotting an image. And for that particular axis, we are hiding the grid, and we are hiding all the axis, like the x-axis and y-axis. And then finally we are calling plt.tight_layout to give some space between these. So once we do that, once we use subplots, and then in each subplot we draw something, here we end up with a single image. So you can see this, if I drag this around, this is a single image. In this single image we have 6 plots, and in this 6 plots we have all the different kinds of graphs that we've drawn. So let's do a quick review as well. So first we looked at a line graph. We saw how to use the plt.plot function to draw a line graph. And then we saw that you can include, you can add a x-axis by including a bunch of values for the x-axis and a bunch of values for the y-axis. Then you can also add labels for the x and y-axis using plt.xlabel and ylabel. You can also add a title to the chart using plt.title. And then you can add markers. You can add a legend, and then you can modify the style of the markers and the lines using various arguments to plt.plot. So all those also apply to the axis.plot function. Then we looked at the scatter plot. So we learned that a scatter plot is used to visualize the relationship between two variables, especially when there are a lot of values within a small range. So here we compared sepal length, and we just plotted the values and we did not see too much of a relationship, but then we introduced a color or a hue to decide the color of the dots, and that turned out to give us more information that now we could see that each species has an independent relationship. So that was a scatter plot. Then, and we also saw that a scatter plot or so scatter plot was created using sns.scatterplot, so the seaborn function, and any seaborn function has great support for pandas data frames. So instead of passing full lists of values, you can simply pass in column names, and then you can pass in the data frame using the data argument. Then we looked at the histogram is used to visualize the distribution of values of a single variable. So for instance, sepal width, we saw how the values of sepal width, how they are distributed in the range of 2 to 4.4. It seems like a large number of sepal width values lie in the range of 3 to 3.25, about 50 values to be exact. And then there are a smaller number of values in each range. So that gives you like a probability distribution. And we saw that we can stack histograms for multiple species. So we did a filtering, we created a list of values for each species, and then we used different colors to plot them so that we can see the overall relationship as well as the relationship for individual species of flowers. So that was the histogram. Then we looked at a bar plot. So our bar plot, in this case we used the restaurant bills dataset, and the bar plot was used to represent the average bill on a weekday, the average total bill on each weekday, and to be able to compare them side by side. So for instance, we could see that the bills on Sunday were the highest and the bills on Thursday were the lowest. Then we also introduced a hue, so either a sex or a smoker or things like that, which would then show two plots side by side for each value on the x-axis, so that we could compare male and female as well. So that was the bar plot using sns.barplot. For histogram, we had used plt.hist. Then we looked at heat maps. So we looked at heat maps to visualize flight traffic into a particular airport over time. So from 1949 to 1960. And then we saw how the footfall increased over the years, but within a year, the footfall increased up to July and then it tended to decrease, right? And a heat map was a good way to visualize that in a compact fashion. And finally, we also looked at how to display images. So we first load up an image using using pil.image.open, and then we can display it using plt.imshow. We also learned that images are actually in Python are represented using Numpy arrays with a certain number of rows, columns, and pixel values. So there are 3D arrays, and you can actually select a specific slice of the image and just display a small part of the image. So that's what we looked at as well. Now this is just a small selection of what's possible, and there is a lot more that you can do. So what I would recommend is, I have pointed to a few resources here. So I've pointed to a data visualization cheat sheet. So let's go through these one by one. So I pointed to a data visualization cheat sheet, which takes everything that you've learned here and then a few more plots and gives it to you in a very simple format that you can use as a place to copy paste from. Because with data visualization, what I often struggle with is that I know what I want, but it's very hard to figure out what the right syntax should be. So here we have included some examples for line plots, scatter plots, frequency distributions, heat maps. There's something called a contour plot, something called a box plot, which we've not covered, and a bar chart. So you can see simple examples, 1 line, 2 line examples, and you can simply copy over this code whenever you are, and use this as a reference whenever you are working on a visualization project. Similarly, we've pointed to a gallery of seaborn plots and matplotlib plots. So you can see what's possible with Seaborn and Matplotlib. So there are a whole different variety of plots that you can draw, and you can combine different kinds of plots in very interesting ways to create some really good visualizations. And the good thing is that these only take a few lines of code, especially with Seaborn. So for instance, if we open up this, so here you can see that this is just a few lines of code, less than 20 lines of code, and you get this beautiful visualization. And all of these contain, Seaborn contains example datasets, so you can just try it out using these example datasets. So do try it out. If you just do it once, you're going to get a good idea, a good handle over Seaborn. Then similarly, we have this gallery for Matplotlib. Now, since Seaborn builds on top of Matplotlib, about that. So for Matplotlib, you will have to write a little more code, but Matplotlib is equally powerful ultimately, and it gives you a lot more control over your plots. So you can open up any of these examples and see. And then we've also pointed you to a documentation and a tutorial for Matplotlib. So here's a great tutorial that goes into a lot more depth. So it may take a few hours to work through, may take a couple of days, but you can work through this great tutorial that goes a lot deeper into Matplotlib. And this is by the same person from whom we borrowed the 100 NumPy exercises. So if you like this tutorial, just definitely give them a star. So with that, we complete our discussion of data visualization. One of the questions that commonly gets asked is, should I use Matplotlib or Seaborn? And do I even need to use Matplotlib? What does Seaborn not contain? Well, so I tend to use Matplotlib especially for line plots and for simple histograms, because it's so easy to use. You just call plt.plot, and also for displaying images. So you just call plt.plot and put in some data, and then you can progressively enhance it. So whenever there's a simple plot to be drawn, just use Matplotlib. But whenever you're doing something a little more complex, like you want to have a scatter plot across 2 dimensions, and then you want to use a color as a 3rd dimension, and you can also use a 4th dimension to decide the size of the dots. So that's something that we did not look at, but that's possible too. So Seaborn is when you want to do more with your graphs, and that's when you would use Seaborn. So I would use Matplotlib for more simpler stuff like lines and histograms, and Seaborn for the rest. Now, in terms of how to choose the right plot, a good rule of thumb is to just try out a line plot, and in a lot of cases it can give you a good enough result. But then once you want to go beyond, then you start looking through this list. Okay, a scatter plot makes sense here. Will it be interesting to use a heat map here? And a lot of these things just come from experimentation. Now take the same data and try to draw different kinds of plots with it, and see which plot gives you the most information and presents the information visually in the best fashion. All right. And as you experiment with it, you will start to cultivate an intuition for which plot to use where. Now, one last thing we should do is to just commit our notebook from time to time. Remember that we're using Binder, which is a temporary online service. So it can get shut down if you leave the computer idle for some time. So whenever you're working on Binder, just do commit from time to time. Okay. So with that, we complete our discussion of data visualization. So let us open up the course project. This is one of the most interesting parts of this course. So the objective of the course project is to apply all the skills and techniques that you have learned during the course onto a real world data set. And the thing about the course project is, well, to get it accepted, there is a certain evaluation criteria that you have to complete, and we'll talk about that. But then it's really open-ended in the sense that you can do as much with it as you want. You can end up drawing dozens of different types of graphs and answer many different questions. You can combine data from many sources. So use this to really practice all the skills that you've learned. Don't take it as something that you just have to submit. Take it as something that you will showcase on your portfolio. And we'll tell you a lot about that as well, that how you can showcase this on your portfolio later on your LinkedIn profile or elsewhere. So let's open up the starter notebook. The starter notebook contains all the information, all the guidelines for the course project. So the first cell of the starter notebook contains guidelines, and then there is a template that you can use, but you do not have to use this template. You can start from scratch too. The way to start from scratch is to go on your jovian.ml profile and then click new notebook and select blank notebook, and that will create a blank notebook that you can start working with. But in this case, I'm going to use this starter template. and then I'm going to click run on binder. So let's just give that a minute to load. And coming back here, if you have questions about the course project, once again, there is a discussion going on. So you can ask questions on the discussion thread, and all the instructions are given here too, the same guidelines that are there in the starter notebook. So you can refer to them here too. Let's give this one more try. Okay, so while the Jupyter notebook starts up, let's start going through the guidelines. As I mentioned that this is the starter notebook, and you will pick a real world dataset of your choice, and then you will apply all the concepts that you've learned in this course to perform exploratory data analysis. Okay, and this seems to have opened up. So let me just open up the Jupyter notebook here. All right, so the first thing, the step one, is to select a real world dataset. So you can find and download an interesting real world dataset, and we have pointed to a lot of interesting datasets in the recommended dataset section. So you can just scroll down below and you will find recommended datasets, and we'll spend a little bit of time there too. And the criteria is that this dataset should contain tabular data, which is rows and columns, and preferably in a CSV, JSON or Excel formats or other formats that can be read using pandas, because we have used pandas primarily for this course, and if you're unable to read the data using pandas, you will not be able to analyze it. If it is not in a compatible format, then you may have to write some code to convert it to the desired format. So remember, we also had a discussion about reading and writing to files. So you may have to read it using pure Python and then write it back into a CSV or a JSON format, which can be read using pandas. Okay, I would suggest that if you're not too comfortable with Python yet, don't do that. Just pick a dataset that is already in the CSV format and just run with it. But if you are feeling comfortable, if you really like a particular dataset, it's not in a CSV format, then you can just convert it into CSV as well. Then the dataset should contain at least 3 columns and at least 150 rows of data. Now this is important because so that there should be enough in the project. If it is just 1 column of data and 100 rows of data, then you're not going to have enough to showcase when you present this project, let's say while you're applying for an internship or a job. So just pick a dataset that is large enough. Now when I say at least, this is just a lower bound. You can pick datasets with tens of thousands of rows of data. Probably bigger than that will slow you down. So restrict yourself to maybe a few thousand rows or 10,000 rows or so. And you can pick datasets with hundreds of columns. Once again, that will probably once again cause a lot of confusion. So stick to maybe something around 10 columns. A maximum would be good. But as such, the dataset should be rich enough that you can ask enough questions and draw enough graphs and so on. Okay. One thing that you can also do, and this will be great because it will really enhance your skills and your experience, is if you can combine data from multiple sources. That will let you create something really unique. And you've learned how to combine data using the merge function in pandas. Yeah, so just keep that in mind. Those are some guidelines for picking the right dataset, and we'll show you some examples. But once you have picked the right dataset, then next step is to perform some data preparation and cleaning. So you simply load the dataset using pandas, and then the same way we've done with the COVID dataset and a few other examples. And then you explore the number of rows and columns, the range of values. So you use things like info, describe, shape, and such. So just to get some basic understanding about the data. This is like some meta information about the data. You also decide how you're going to handle missing values, maybe fix any incorrect values, maybe drop any rows that you don't want to consider. So there's some basic cleaning up that you might have to do. And you can also perform additional steps, like you might want to parse dates into the date time format. You might want to create additional columns or merge multiple data sets. So you do all of that. That's the data preparation step. And so take these steps as a guideline on what to do and not as something that you have to really stick to. You can work on the data as you see fit, but these are just some guidelines to help you along the process. Okay. So once you're done with the data preparation and cleaning, then you will perform some exploratory analysis and visualization. So what this means is you will compute the mean, the average, the sum, range, and other interesting statistics for numeric columns. So here we are still discovering, you're going one step deeper where you're looking into specific columns. Maybe you can use this, you can look at the distributions of numeric columns using histograms. Maybe you can explore relationships between columns using scatter plots, bar charts, and things like that. and also make a note of interesting insights from this exploratory analysis. So here we are not really trying to ask any questions yet. We are still just exploring what we're just feeling it out. And through that, as we plotted some graphs, we got some, we could infer some things from it, or we could form some hypotheses. So make a note of all of these interesting insights from this exploratory analysis. And then the next step is to ask and answer questions about the data. So now once you have become familiar with the data, you have looked at it in different ways through graphs and through summaries and things like that. Now you have to figure out what are 5 things, at least 5 things that you want to know about the data set. So ask 5 interesting questions, so questions 1 through 5, and then answer these questions either by computing the results. So you can use Numpy, Pandas, the different functions that we have for computing the results, or by plotting graphs. So the questions do not have to be numeric questions. The questions, in fact, sometimes even if they are numeric questions, let's say which country has the highest population, if you're trying to answer that, you can actually draw a bar graph and use the bar graph to answer that question, right? So it's not, there's no automated evaluation here. It's more for you to explain what's going on in the data, and you get to decide your own questions. And you can create new columns, you can merge multiple data sets, and you can perform grouping and aggregation wherever necessary. And one good thing to do is, in all of this process, apart from writing the code, you should also try to write good explanations. So make it like a tutorial, so that it is useful to read for somebody who is one step behind you, for somebody who has not taken this course. So in that sense, it becomes like a full report and a tutorial as well. So whenever you're using some library function from Pandas, Numpy, or Matplotlib, just explain briefly what it does, or link to the documentation that we can use the pandas dot read CSV function to read a file from in the CSV format, right? Just one sentence like this, even though it's obvious to you, it's really helpful for a reader. So that's where you will ask and answer some questions. And then finally, at the end, you have to just conclude. So treat this Jupyter Notebook as a project report along with the code itself. So just write a summary of what you've learned from the analysis, include some interesting insights or graphs from the previous sessions. So you can once again copy over the code and then just include those graphs if you need to. Again, all of these are guidelines, so you do not have to stick to them perfectly. And then share ideas for future work on the same topic or using other relevant data sets. You have gathered some insights, but maybe you've not really figured out everything, and you maybe did not have the time. So you can just mention these are a few other things that you can try out with the same data set, and maybe even point to some other relevant data sets which can probably be combined with this data set, or maybe the insights can be combined to get something more interesting out of it. And this could be an idea that might help you in the future, that this is a starter project that you do, and then 2 months later you're looking for another project to work on. You can just look through the future work ideas from your current project, your previous project, and see if any of those make sense to pick up. So this is a very important thing to do. So do some reflection and then share more ideas while you are still in the thick of things. And finally, while working on this project, you will probably refer to at least a few dozen blog posts, articles, documentation pages, Stack Overflow answers, and some of these you might want to just note down and keep a track of. So just keep a note somewhere of the most interesting links that you found, and just link to those resources at the end of your analysis. All right. And in this entire process, from let's say step 2 to step 5, all of this will happen in the Jupyter Notebook. So document your Jupyter Notebook, write detailed explanations, use the markdown cells, use the markdown syntax, use headings, use bullet lists, use tables. So there are a lot of things you can do with markdown. So just make it a point to make it as nice as possible, because when you send this notebook to somebody, you want them to look at it and you want them to look at it and be able to understand what's going on, and also really appreciate the effort that you have put in. And that will really help you make progress, because presentation is a very important part of data science, right? So that will really help you make progress towards getting a role, or getting an internship, a fellowship, or a job in the data science domain. Okay. So now once you're done with all of this, and then you can use this, you then need to make a submission. So you can use this starter notebook, or you can just start a new notebook from scratch. but make sure to keep running jovian.commit from time to time. So here we have a project name. Just give this a nicer project name, whatever makes sense for you. Let's say if I'm working on some COVID-19 data analysis, that's a data set, a real world data set, something that is evolving on a daily basis. Okay, so I am just setting a project name, and then just use the Jovian library and keep committing the project. So here I've created sections for you in the starter notebook. So let me just make a commit first, and then I'll go through that. So here we just put in the API key and then make a commit. But here you can see some sections like data preparation and cleaning, exploratory data analysis, asking and answering questions, inferences and conclusion, and then references and future work, right? So you can just use that as a guideline and write some explanations, write some code, plot some graphs, get some results, and keep committing from time to time. And then when you're done with the entire project, when you feel that you have something significant enough, then you take this committed notebook. So in this case, 02 Pandas course project starter is what I've committed to. You take this committed notebook and then come back here to the assignment page, course project, and make a submission here. Sorry, and make a submission here on the make a submission form, and then click submit. Oh, sorry. So this needs to be, let me just try that again. So this is the notebook that let me just run jovian.commit. So I have committed the notebook. I take the notebook here, the notebook link, COVID-19 data analysis demo that I just committed. I come back to the course project page, and here I make a submission and click submit, and a submission will be made, and then we will evaluate it. Okay, so now what are the evaluation criteria? The evaluation criteria is this, that your submission will be evaluated on these criteria: that the dataset must contain at least 3 columns and 150 rows of data. So this is just so that it has enough of a breadth, enough information within the data. You must ask and answer at least 5 questions about the dataset. So asking the right questions is also a skill. So that's why you have to come up with 5 interesting original questions about the dataset. Your submission should include at least 5 visualizations or graphs. And once again, try to make these different, but we're not going to test if these are all different graphs, but don't make just 5 line plots. Try to use different kinds of charts, scatter plots, histograms, heat maps, whatever you can try out. Your submission should include explanations using markdown cells. So it should not be just code. It should not be just a series of code cells, because then it shows that you've not really put an effort into presentation. Presentation is an important part of data science, and especially of doing projects. And then your work must not be plagiarized. That you should not have copy pasted the entire thing from somewhere else. Now you can see a lot of these data sets are already analyzed. There's a lot of information available online. So you can repeat what somebody else has done, but just there's a difference between simply copy pasting where you do not really understand what has happened, versus borrowing the right things from specific notebooks or tutorials. And it's a fine line, and it's something that you should hold yourself accountable to. But just try to, as long as you have put in some original work into the project and you have satisfied all of these criteria, we will evaluate and accept your project. And this course project, along with the 3 assignments, if you've completed all of them, then you will be able to earn the verified certificate of accomplishment that you can add on your LinkedIn profile or wherever else you want to. So these are the evaluation criteria. This is how we will evaluate your work. Now I just want to spend a little more time talking about some of the interesting some of the data sets that you can use for working. So we have created a list of a few data sources from where you can get data sets. So the first one is Kaggle datasets. This is the easiest one to get started with. So you just click on Kaggle datasets and you will find a whole bunch of, there are over 50,000 datasets you can pick from. So for instance, what you do is just open up a dataset and then just click download, and that is going to download the dataset for you. And I'm just going to save it on my desktop, and I'm just going to open it up. So unbundle it. So you can see here that there is a file here. So from 1976 to 2018, you have the data for US Senate. Let us open it up in, let's use Visual Studio Code to open it up. So you can see that this data is in CSV format. This data is in CSV format, and in the CSV format, you can now read it using pandas and you can start doing your analysis. So that's one example, the US elections dataset. And there are lots more that you can look through here. You can also filter. There are a lot of filters that you can use for this dataset, for these datasets. So that's Kaggle datasets. Then similarly, you have the UCI machine learning repository. This has a whole bunch of datasets too. So here you can, for example, just click on view all datasets here, and you can see you can even filter it out with different areas, different attributes. You can see different data types and different instances, and use that. So here, for instance, breast cancer dataset. So this has around 2000 data. You can see a basic information that it contains a bunch of information about breast cancer patients, and you can found the data folder here. So here it is in a certain format called .data. You might want to then convert that format to CSV, but a lot of these datasets are also in a specific CSV format that you can directly use too. Okay. Then you have awesome public datasets. This is also another great source. So this is a GitHub repository from where you can find links to a lot of datasets in many different areas. So if you are from a different domain, like whatever domain you're from or you're currently working in, find an interesting dataset there, use that. And then you have, we also linked to a place, you have Google dataset search. So on Google dataset search, you can find data for anything and everything pretty much. So for instance, if we try global temperatures, you can see that there is some data here about global surface temperatures, and you can then get this data. So in some cases, you might have to go through a few links to get the data, and you might have to look through on how to actually download the data. So I'm not sure here what, it seems like there's a lot of different data files here, but as you just go through and look through all of this information, you will be able to find a CSV file. If not, probably just try another dataset. So these are some sources where you can find these datasets, right? And whenever you get a dataset downloaded to your computer, now you will need to upload it back to Binder. So here, whenever you're working on it, you will need to just upload this data. So here, for example, you have the USA presidential election by county. I'm just going to upload that. Actually, let me upload a smaller file. So here, let me upload this 2012 data. So this is how you upload a data to Binder. And if you want to download a file, let's say you've created a CSV file by processing some other data file, you can download it by selecting it and clicking the download button. So that's something you can do as well. One other thing that you can do is when you're running jovian.commit, you can also include a bunch of files. So for instance, here in the list of files, I can include this CSV file name. So in this way, what happens is that your CSV files can get included. Your CSV files can get included along with your commit, so that the next time when you run, then the CSV file will automatically become available to you. So the first time you run commit, you might want to just include the CSV file using the files argument. So then when you commit and you check the files tab of your project, you will be able to see the file here. And when you run it, the file will already be present, so that you don't have to upload it again and again. Okay. So that's how you work. So these are some dataset sources. And then we've also picked out some specific datasets like the Stack Overflow annual developer survey, some COVID-19 data, some Google Play Store data, and a bunch of, so these are datasets that we would highly recommend that you can analyze. So there are some game datasets like Dota, cricket, basketball, PUBG, and so on. And then there is also data that you can download from your personal apps that you use. So things like WhatsApp, Chrome, Google Calendar, Apple's apps, Instagram, Facebook, LinkedIn. And that is also another really interesting thing to do. So now what I want to do is I want to show you a few examples of what a good project will look like. And actually one last thing that I want to mention is that apart from making a submission, you should also share your work on the forum. So a submission is more for us to evaluate your work, but then you can also go on this forum thread, the course project on exploratory data analysis, where you can share your work. And we are hoping that we see thousands of projects shared here. And when each of us share our project and then go through maybe 5 to 10 other projects, that way we learn a lot more than we would learn individually. So please share whatever you do, please share ideas. So on the datasets thread, you can also share ideas for datasets. On this thread, you can share ideas for projects, share an update on what you're working on, how your notebook looks like so far, and keep sharing updates on a day-to-day basis and support each other. And that's how we can all create maybe 1,000 or so interesting projects. And you can also share these projects on social media and just tag us, and then we will be retweeting 4 or 5 interesting projects every day. And do try to give feedback to other participants too. Now, apart from that, there is one optional step here, and the optional step is to write a blog post. So you can have a Jupyter notebook and you can have great explanations, but sometimes it is also helpful to write a separate blog post. So you can use the medium.com platform. Again, this is completely optional, not part of the required submission. You can sign up on medium.com and you can copy over the explanations from your Jupyter notebook into your blog post. And the code cells and the outputs, you can actually embed them within your blog post. So I'll just show you an example. So here you can see that you have, this is a blog post where we have embedded this code cell from a Jupyter notebook. You can see here that you have the inputs and the outputs. So you have some code and then you have a graph. This is embedded from a Jupyter notebook. They're called Kaggle Python recipes. So you can embed code and output from your Jupyter notebook inside a blog post. So try that out as well. And if you want some inspiration, you can check out our Medium publication, right? And we will love to feature your work on our Medium publication, and we will share it with our user base. We will share it on our social media. So we are looking forward to interesting submissions, interesting blog posts, and interesting notebooks. Okay. Now I want to show you a few examples of some good projects that you can take inspiration from. So here's one. This is analyzing your personal browser history using Pandas and Seaborn by Karthik Godawat, a good friend of ours. So here what Karthik did was he used Google Takeout. So Google has something called Google Takeout, so takeout.google.com, from where he exported his entire browser history across all devices, including mobile and desktop, in the JSON format. Then he took that browser history JSON and then he converted that into a Pandas data frame. So this is what the data frame looked like, where there you had the URL and then you had the title and then you had some other information like at what time he visited the page. Based on that data frame, he extracted a bunch of features, so created new columns. So he created like days of the week, year, month, and things like that. He also created categories. So based on the URL, like if Coursera, FastAI, Kaggle, or FreeCodeCamp were part of the URL, then he categorized that as learning. On the other hand, if it was Y Combinator, Medium, or HackerNoon, he categorized that as tech reads, and then probably categorized YouTube, etc. as entertainment. So he did some categorization and created a data frame out of that as well. And so that is some pre-processing on the data. Then he started exploring the data and creating visualizations. So here he has used Seaborn to create a count plot. This is something that we have not explored, but you can look up the documentation. So to check how many sites were HTTPS and how many were HTTP, he has done some more analysis to figure out how the browsing activity varies on weekends versus weekdays. So it seems like there's more activity happening on weekdays compared to weekends. So that's great. He also looked at his browsing activity over the different months and the different hours of the day. So sorry, different days and different hours of the day. So here it looks like that most of the browsing, so between let's say 12 a.m. to 9 a.m. not a lot of activity happens, and then there's a lot of activity happening on certain nights, probably when you're binge watching something or maybe busy with work. So here a heat map is a good example, and you can see that all these graphs are things that we have covered. Then he also looked at browser visits by the day of week and the hour, again a heat map. And then there are some more analysis. Here this is a list of the most common Stack Overflow questions. So sometimes you don't need to create a graph, you can just create a filtered out data frame. So it seems like these are some of the most common Stack Overflow questions that Karthik looked at, and so on. So this is one great example. Then another one is just analyzing the COVID-19 data using Pandas. This is what we did for the Pandas tutorial. So you can see that we followed all these steps here, and you will be able to just take a data set and follow the same steps, reading a file using Pandas, retrieving some data from a data, then exploring the data, querying and sorting the data. We did not do a lot of visualization, but you can see very easily how you can insert a lot of interesting visualization here. We also asked and answered many questions here. So we've asked 4 questions and answered them. So this is again something that you can review. Here's one where Prajwal used his own WhatsApp data to perform certain analysis. So here Prajwal has downloaded his WhatsApp data and he has given you the instructions on how you can do that too. And based on that, he has then converted that into a data frame. So you can probably even just borrow this function if you want to analyze your WhatsApp data. And then he's done some data cleaning. And then based on that, he's asked questions like who is the most active member of the group. So it seems like this person is the most active. And what were the most popular emojis that have been used? It seems like the laughing emoji was the most popular emoji. What can you say about the sleep cycle? So it seems like there's a lot of activity on WhatsApp happening around after 9 p.m. So these are interesting insights that you can discover about yourself. And then there are a few more. So here's one called Understanding the Gender Divide in Data Science. This is more around data visualization. So you can see this is from a Kaggle dataset, and here Akansha has walked through many different interesting kinds of plots that you don't normally see in Matplotlib Seaborn. So if you want to explore more interesting plots, you can check out this tutorial. And then there is also a couple more that you can follow. Okay. We are hoping to have a lot more examples as the course participant work on projects. So you can take your projects and then share them on this thread, discuss and share your work thread. And you can also share ideas for datasets on the datasets thread. So we have a separate thread for datasets. This is recommended datasets for course projects. So here you can check out these datasets and you can also post ideas for datasets. Okay. And I hope you're excited to work on this project. We are really excited to put this together for you. We've gathered a lot of resources from a lot of different places, and everything that we have been doing in the course so far has been building towards it. So just take it step by step, follow the guidelines, do something, try to make some progress. So find a nice data set, do some analysis, explore it, see if you want to pursue it and create a full project out of it, and so on. Right? And you can always ask questions on the forum wherever you feel stuck. You can ask questions just simply as simple as, do you think this data set is interesting to work on? And others will reply to you. Even the course team will reply to you. And our final lecture is going to be a case study of exploratory data analysis. So in some sense, it is one project that we are doing. And so that will also help as serve as a tutorial for how to take up a data set and then do some processing on it and do the analysis on it and present some results. And we'll just walk through that entire process. Get started now. Okay. Once again, I do get started as soon as you can, and I wish you all the best with the course project. And I hope that this will be something that you will be able to proudly showcase on your professional profile. Our final lecture is Exploratory Data Analysis, a case study, where we will be taking everything that we have learned in the entire course and bringing it together into a single project where we will be analyzing a real world data set, and we will be asking and answering some interesting questions about the data, and we will figure out how to use the right tools and techniques and libraries and functions at the right places, and we will be drawing some inferences and conclusions. So this is in some sense a walkthrough of a real world project that you might do in data analysis. So with that, let's get started. So the first thing you should do is go to the course page 02pandas.com, and on the course page you will be able to find all the course materials. So today, since we are looking at lesson 5, so you can lesson 6, so you can scroll down to lesson 6, Exploratory Data Analysis, a case study, and click open. This will take you to the course page, the lecture page, where you will be able to see the video. So the video that you're watching right now will be available as a recording for you to review. Now for each lecture, we have been using Jupyter Notebooks. So today we will be using the Jupyter Notebook EDA on Stack Overflow Developer Survey. So you can just click on this link and that will bring you to this Jupyter Notebook. Now you can view this Jupyter Notebook, you can read through it. But what we would want to do is we would want to run this notebook. Now you need not run it right now if you're watching live. You just watch the lecture, and after the lecture you can run this notebook and experiment with it. But I'm going to run it right now, and we are going to work through it. and we click the run button and click run on Binder to start the notebook up on the Binder platform. Now this might take a couple of minutes, and in the meantime I just want to show you how to ask questions. So if you have questions during or after the lecture, you can come to the lesson page and here click on the discussion forum link, and this will take you to a page on the discussion forum. This is where we've been having all our discussions, and you can use this thread for asking questions. All you need to do is click the reply button and post your question. There's a big blue reply button, and you just post your question and hit reply, and either somebody from the course team or somebody from the community will answer your questions. Okay, so please ask your questions on the forum and also answer questions if you already know answers to some of the questions that have been asked here. So returning to the notebook, this notebook is called Exploratory Data Analysis Using Python, a case study. And we have clicked the run button and selected run on Binder. So finally here we have our Jupyter interface running. So let's just open up the notebook here, Python EDA Stack Overflow survey.ipynb. And the first thing that I'm going to do is I'm going to click kernel, restart and clear output. This is to clear all the outputs so that only the code remains and we can run the code and see the outputs for ourselves. Then I'm also going to hide the header and the toolbar. You need not do this, but I'm just doing this so that we have a little more space to work with. So in this notebook, Exploratory Data Analysis Using Python, a case study, we will be analyzing responses from the Stack Overflow Annual Developer Survey. And we will apply all the things that we have learned so far about Python, Jupyter, Numpy, Pandas, Matplotlib, Seaborn together, and we'll bring everything together. Now you can run this code online just in the way that we have by using the run button that we just used to run this code on Binder, but you can also run this code on your computer locally. So you can follow the instructions given here under option 2. Now, as I mentioned, we'll be analyzing the Stack Overflow Developer Survey dataset for our analysis. And this is an annual survey conducted by Stack Overflow. And you can find the raw data and results on this page, insights.stackoverflow.com. In fact, we will be analyzing the results from 2020, but you can also see the survey from the past years. So the first thing that we would want to do is to download this dataset into Jupyter. And there are many ways to do this. We've seen many ways over time across different lectures. So the first thing that you could do is just download the CSV manually and upload it using Jupyter's graphical interface. So let's do that. Let's see how to do that. So you click download full dataset, and that points us to a Google Drive link. And then you can download the Google Drive link. And so here I'm downloading it to my desktop. And then you can unzip the Google Drive link. So once you unzip this link, you will see this folder, Developer Survey 2020. And if you open up this folder, you will see here that you have a PDF and then a bunch of CSV files and then a README file. So you can go through the README to learn more about the dataset. But probably the interesting files for us are going to be the CSV files. So we might need to upload these CSV files onto Jupyter. So the way to do that is to come back to the notebook, go File, Open, and then you will find an upload button here. So click upload and just select the file that you want to upload. So in this case, let's say as an example, let's try and upload survey results schema.csv. So one by one, you can upload each CSV file that you need. Okay, so that's one way to do it. You can click the upload button to complete the upload, but I won't do that right now. Then there's another way to do it. If you have a direct link to the raw CSV file. Okay, so this is very important. If you have a link which points directly to the CSV file, so a Google Drive link or some other link will not do. It has to point to the raw file. Then you can use the URL retrieve function from the URL lib.request module. So this is what we've used in our previous lectures. We've used this in the lecture on Numpy and Pandas. So you can review those lectures 3 and 4 to see how to use this, or just check the documentation. But today we are going to use a third method. We are going to use a helper library called Open Datasets. So this is a library that we have created for you to make it easier for you to do data analysis, where we are creating a curated collection of datasets for data analysis and machine learning. And these datasets can be downloaded into Jupyter with a single Python command. This is how it works. We have to install this library, pip install open datasets. So let's just come back to the Jupyter notebook and let us run pip install open datasets. So this is installed the open datasets library. Then we import open datasets as OD. So we just import open datasets as OD. And then all we need to do is run od.download and then pass in a dataset ID. So we have currently added about 6 datasets here, but we will be adding many more. We're trying to make sure that we have at least 100 datasets here by the end of this week. So you will see more here. And we simply need to pick up the ID of the dataset that we want to use. So here we have the Stack Overflow developer survey, and we need to paste that ID here. So we just do od.download, and under the hood, this is going to fetch the list of files in the dataset, and it is going to download all the files. So you can see that these URLs have been fetched and they have been downloaded into this folder, Stack Overflow Developer Survey 2020. Okay. So with that, we seem to have the dataset downloaded. Once again, you can go File, Open, and you can check that there is a folder here, Stack Overflow Developer Survey 2020, and this contains the README and then the public file and the schema file. Okay. So those are different ways to download the dataset. The important point is to have the files next to your Jupyter notebook, irrespective of how you get them. All right. So let's just import the OS module and verify once again that the dataset is actually downloaded. So when we run os.listdir on the Stack Overflow Developer Survey folder, we see a README, we see some survey results, and we see the survey results public, and we see a survey results schema. So there are 3 files, and you can go through these 3 files. So the README contains some information about the dataset, and then the survey results schema contains a list of questions. And so let's maybe just load up that file and view that file as well. And then there are the survey results public. So this contains the full list of responses to those questions. Okay. So we will load the CSV files using pandas, and let's import pandas as PD, and let's use the pd.read CSV function where we will pass in the path to the survey results public.csv file, which contains the survey responses, and we are going to call it survey raw.df. So the reason for calling it that is because this is going to be the raw dataset, the unprocessed dataset that we are loading up. And then we are going to do some modifications to create a prepared dataset for analysis. So here we create a survey raw.df by calling pd.read CSV, and let's take a look at this. So this is what the data frame looks like. It looks like it has a whole bunch of columns. In fact, in total, there are about 61 columns. So 60 of them are each column corresponds to one question from the survey. And here what is not the full question, but just a short form. And then there is also one column which contains a respondent ID. So these survey results are anonymized. So there is no personally identifiable information like first name, last name, phone number, email, etc. So results have been anonymized, and every respondent has been given an ID, which is not really useful for us. There's one column if you want to use the respondent ID, and then there are 60 columns, one for each question. Now, if you want to know what the actual question was, this is where you can use the other file, which is survey results schema.csv, and we'll see that in just a moment. But you can see at the bottom here that there are over 64,000 responses, and as we said, 61 columns. And let's just see a list of columns in the data frame. So we can use survey raw.df.columns to see a full list of columns from the data frame. A lot of these may not make sense, so this is where we need to use the schema file to understand what these columns represent. So here we have this file. Let me just put it on a separate line. So here we have this file schema, survey results schema.csv, and maybe let's load up the entire file first. So we can just do pd.read csv and schema file name. So this file is a CSV file that contains 2 columns. One of the columns, the first column, is titled column. So this corresponds to the names of all these columns except respondent. So main, branch, hobbyist, etc., etc. Actually, it contains the respondent ID as well. So for each of these columns, you can see the actual question here. So for instance, main branch means this question was which of the following options best describes you, etc., etc. Hobbyist means do you code as a hobby? So that's what the correspondence is. Now it's okay to have it in this format, but the schema data frame is primarily going to be used to access the question for each column. So what we might first want to do is we might just want to set the index while loading the file. and set the index call argument to this column, so that when we read it, now we just have one proper column, and then the column itself is just the index. So now we have the respondent, and then we have this one column question text. So now we can access the question text using the respondent as a key, right? So you can, for example, imagine doing .loc and then passing in the respondent key here to access the question text for the respondent. Okay. So now let's simplify it a little bit further. Since we only have one column, we don't really need a data frame. Data frames are required when we want to go over multiple columns of data. So we can simply get the question text out of this, and that will give us a series. Okay, looks like this is stuck. Yeah, so we can just read the CSV file, the data frame, and from it just get the question text column out of it. So that will give us a series, and that is all we need really. The series has an index, which is the column name in the main data frame, and then the series has a value. Each value corresponds to the full text of the question. Okay, so that is what we have done here. We've created a schema raw, which is where we read in the schema file with the index column as column, and we just create a series question text. So here is a schema raw, and we can now use schema raw to retrieve the full question text for any column in survey raw df. So now we can check, for example, the years code pro column. So you can see here that years code pro column in the survey data frame corresponds to the question, not including education. How many years have you coded professionally as a part of your work? All right. So with that, we have loaded up our data set, and we have converted them into data frames. We have it in a way that we can now work with it using the tools that we know and understand. So we are now ready to move on to the next step of pre-processing and cleaning the data for our analysis. And before we do that, it's always a good idea to keep saving your work from time to time, because we're running this on an online service binder. So we simply select a project name. So here I'm selecting a project name, Python EDA Stack Overflow Survey. We install the Jovian library, and then we import Jovian and run jovian.commit. And this is going to ask us, the first time this is going to ask us for an API key, which we can get from our profile, and just paste it in here. And that is going to then commit this notebook to our profile. Yeah, so now this notebook has been committed. So you can view this notebook on your Jovian profile whenever you want to. Wherever you commit from, whether you commit from binder or you commit from your local computer, everything gets saved on your Jovian profile. And then you can take this and run it on binder whenever you need it to continue your work. All right, so moving ahead, now we have our data as data frames. And while this survey contains a wealth of information, it contains about 65,000 responses to 60 questions, we will limit our analysis to a few areas. And this is what you might want to do for your projects as well. Just pick a theme for your project and do not try to do a lot of different things with the dataset. So we will limit our analysis to 3 areas. The first would be understanding the demographics of the survey respondents, who it is that has taken the survey, and the global programming community in general, and understand if the survey responses are representative of the global community. We will also try and understand the distribution of different programming skills, experiences, and preferences. So specifically like things like programming languages, which programming languages do people like, which one do they not? And we will also understand some employment related information, professional and information, preferences, and opinions. So something related to the kind of roles people are holding in data science and programming fields. Okay. So to do that, let us select a subset of the columns. So here are some columns for demographics, and then here are some columns for the programming experience, and then here are some columns for the employment, so that you can use the schema that we had created to check the questions. So do check out the full questions for each of these before moving forward. And let us just check how many columns you have selected. So we have selected about 20 columns. Okay. Now what we will do is we'll take our survey raw data frame, and then if we simply pass in a list of columns to it as an index, that is simply going to select a subset of columns. And then we are going to take that data and just create a copy of it and call that survey data frame. So we are creating a copy so that we can modify this without affecting the original data frame, so that if we make a mistake, we can always recreate this from the original data frame. So we create the survey data frame, and we've just taken the selected columns and created a copy. And then we have created, here we are now going to just pick out the same selected columns out of the schema as well, so that our schema also contains just the columns that we need. So we can look at it right now. So here we have the survey data frame. This now has only 20 columns, the columns that we have selected. It still has all the rows. And then we can check the schema as well. So here we see the schema. So you can see here that the schema has each questions for each of the 20 columns. So you can see in total it has if you check the shape, you will see that it has 20 entries. And the survey data frame has about 64,000 rows and 20 columns. Now we can use the info method of survey data frame to see the list of columns and different data types. So these are all the different columns that we had just selected. And you can see that out of the 64,000 plus entries, not all of the entries are non-empty. So for each of the columns, you see some null values, some values that are empty in the CSV file. So pandas replaces empty values in the CSV file with np.nan, which is a token. It uses for empty values. And because there are so many empty values, and because a lot of rows contain many different types of data, the data type that you see here is detected as object for most of the rows. Now the object data type is okay while we are working with strings. It's not really a problem. But when we are working with numbers and we want to perform some numeric computations and draw some graphs which involve some kind of number processing, then we might need to convert some of these rows, some of these columns into numeric data types. Okay. So far we have just the age and the work week hours as the numeric data types. If you see age here, it has a data type float 64, and then work week hours has a data type float 64. But there are a few more columns which can also have a numeric data type. So we have the age first code, we have the years code pro, and we have the years code column. All three of these are also numeric, but for some reason they have gotten classified as object. So let's investigate that a little bit. Now if we just look at surveydf.age first code, and let us look at the unique values for this. So it turns out that most of the values are numbers, and the question, if you're wondering what the question is, let's just check schema.age first code. So the question is, at what age did you write your first line of code or program? And the answers to that are mostly numbers, but there is also an option younger than 5 years and older than 85, which are strings. And we might want to just somehow convert these into numbers or ignore them, because that will keeping them as strings will prevent our analysis. So what you can do, what we will choose to do here is we will choose to replace these with empty values. Okay, and we will choose to convert the rest of these into strings. And the way to do that is to use the pd.toNumeric function. So the pd.toNumeric function, and you can check the documentation, it takes a series or a column and it converts that series into a numeric data, right? So it's going to take all of these and convert these into floats, and wherever it encounters a string, it will throw an error. But what we want to do is we want to ignore the errors and simply replace any non-numeric values with the nan value or the empty placeholder value. So that's why we are passing in errors equals scores. Okay. So this is one thing that we're doing for the age first code. Similarly, we have years code and years code pro. So let's just take a quick look at years code, and years code pro is going to be similar. So years code is including any education. How many years have you been coding in total? And if we take that and we check the unique values of that. So once again, here we have these options like less than 1 year and more than 50 years. Once again, what we are going to do is we are going to ignore those values. We are going to convert these into empty values, and the rest we are going to convert into numbers. So once again, we use pd.toNumeric, and we assign the result back to surveydf years code. So this way we are replacing the columns with a new version of the same column where all the elements are numbers or empty. And then similarly, we have this for the years code pro column. Okay. So go through the other columns and see if there are any other columns that are numeric. But for the time being, we will convert these three into numeric columns. Now, we had 2 columns earlier, age and work week hours, and then we have 3 more columns. So in total we have 5 numeric columns, and we can start seeing some basic statistics about the numeric columns using the describe function. So here we have called surveydf.describe, and you can see that for age, the average age is about 30 of the survey respondents, but the average age of first coding, so the age at which they wrote their first line of code, is around 15. The years of coding is about 12 on average, and so on. Work weeks are around 40. But you will start to notice some problems here. It seems like that the minimum age mentioned is 1, which seems quite unlikely that a 1-year-old infant has filled out this survey. And the maximum age appears to be 279, which once again is quite unlikely. And this is a common issue with real world data in general and with surveys in particular. You have to understand that surveys are filled by people, and people are not, there is no obligation to enter the right information. So sometimes people may intentionally putting the wrong information, while other times there might be accidental errors while filling in. Like maybe somebody was looking to type 17, but they did not press the 7, and so it ended up being 1. Or maybe somebody was trying to type 27 and they accidentally pressed 9 as well, and that ended up at 279. So we should try and solve for these. For each column, you should go through it and try to figure out if the values in the column make sense. And a simple fix in this case would be to simply delete the rows where the value in the age column is higher than 100 years or lower than 10 years. So we are basically saying that those entire responses are invalid. Maybe they're invalid unintentionally, or maybe that was intentional. And to delete the rows, we can use the drop method of the data frame. So we just call surveydf.drop, and then you can just go try and understand the syntax here. What's happening is that we are first checking the list of values surveydf.age where the age is less than 10. So that's going to give us a Boolean series of true and false for each row on whether the age is less than 10 or not. We then use that to select the rows. We then use that to select only those rows where the age is less than 10. And then to drop to surveydf.drop, we need to pass an index. So if you just call .index on this, so we are basically passing all the IDs of all the rows that need to be dropped. And then we are saying that we are doing this in place. So that is going to remove the rows from this same surveydf data frame and not create a new data frame with the removed rows. There's a lot to unpack here, and the way to solve it would be to just take each expression and run it on a different line, on a different code cell, and see the results and build it step by step. Or you can also follow this link here, which explains this entire line of code, or you can just check the documentation of surveydf.drop. Okay. So with that, we've done this for age less than 10. We've removed those rows. Age greater than 100. We've removed those rows as well. And the same holds true for work week hours. So here, if you check the work week hours, it seems like the minimum is 1, which seems reasonable. Some people might be just working for 1 hour a week, but the maximum seems to be 475. And that's probably wrong because the number of hours in a week is about 168. All right. So we can take another approximation here, that let us remove all the rows where the value for the column of work week hours is higher than 140 hours, which is about 20 hours per day. So now you have surveydf.drop, and here we are dropping the rows where the work week hours are more than 140. The gender column also allows picking. So there's the gender column. So if you see, there's a column called gender. If we just check schema.gender. So here the question was, which of the following genders describe you? And please check all that apply. So this gender question about gender allows picking multiple options. So here we have man, woman, non-binary, genderqueer, or gender non-conforming. So these are the 3 options, but there are cases where people have picked multiple options too. So for instance, there are around 121 people have picked man and non-binary, genderqueer, or gender non-conforming. Now, while this is acceptable in general, it is going to make our analysis a little bit difficult. So we are just going to do a small simplification here. We are just going to take all of these values where none of the values have been selected, or where multiple values have been selected, or all the values have been selected, and simply replace these with empty values. So the reason we're doing this is that it's going to simplify our analysis just a little bit. So let us simply, so what we're going to do is we're going to replace all of these with the empty value. So that's going to simplify our analysis to just looking at one category at a time. Okay. So I'm just going to do this. You can follow this line of code. So we're calling surveydf.where, and surveydf.where takes a condition, and then based on the condition, wherever the condition is satisfied, it replaces the value with a specific value that we are providing here, and you can do it in place. Okay. So I will leave this as an exercise for you to figure out on what exactly this does, but the end result of this is to take surveydf gender, and now when we check the value counts, we only have a single option being selected: man, woman, or non-binary. Okay. And that's just for simplification, not to say that any of these options are invalid. So with that, we have now cleaned up the dataset and prepared it for our analysis. We've made a few assumptions, we've made a few simplifications, we've removed certain rows, we've replaced certain values with empty values, and this is a typical process that you will follow for any dataset, any real world dataset that you do. The lesson here is not to jump immediately into analysis. Just first go through these values, see where the missing values are, see if you need to do something about the missing values. So for strings, not really, but sometimes for numbers, you may want to do some kind of a replacement for the missing values. Sometimes you may want to simply remove those rows altogether. We've not done that in this case. Deal with any invalid values, any values that you feel are outside any normal range. You should maybe get rid of those rows entirely, or maybe simply clear out those values with just the empty value, and a lot of things like that. And then finally, we've now cleaned up our data frame, so we can just check a sample. So I'm just calling surveydf.sample with 10. So just to see a random sample of 10 rows. And this is again a very good exercise to do. Just go through some sample data from your data set, just to get a sense of what the values in each column and different rows look like. Okay. So here we can see that the countries, it looks like they're strings, and then the age seems to be a number. There are also places where people have not filled the age. Then we have the gender. Remember, we've done a simplification here where we've reduced it to just one answer. And then we have the education level. Then there is the undergraduate major, and so on. So just going through each columns is going to help you make better inferences on the data. And with that, our data pre-processing and cleaning is complete. So let's just commit our work once again. So moving forward, now before we can ask any interesting questions about the survey responses, it would be helpful for us to understand what the demographics, which is things like the country, age, gender, anything that you can use to pick out groups from the responses, any such information, what the demographics of the respondents look like. And it's important to explore these variables mainly in order to understand how representative the survey is of the worldwide programming community and of the worldwide population in general. And this is again, the reason this is important is because a survey of this scale generally tends to have some bias. So in the world, there are a certain number of people who are programmers. Out of those programmers, a certain fraction use Stack Overflow. And that's not a randomly uniformly selected fraction. So there's already definitely some selection happening there. Out of those who use Stack Overflow, a certain number of people have taken the survey. So once again, that is not a uniform selection from the entire user base of Stack Overflow. There's probably some selection bias here. People who are more likely to take a survey are probably also people who are, let's say, have 3 or 4 other qualities. So it's not a random sample, completely random sample. And then there's also how Stack Overflow publicized the survey, what was the outreach process, and all that decides who saw the survey and who filled the survey. And also like the language of the survey, the kind of questions that were asked, the length of the survey, all of these things make a big difference in terms of who has actually filled the survey. And all this is called selection bias, where the respondents of a survey do not come from a randomly picked sample of the overall of the overall population that you want to study. So do keep that in mind. And that's why it's important to first look at the demographics. Okay. So we are going to do what is called exploratory analysis and visualization, where we don't really have a question in mind. We are simply looking at different rows, columns, comparing things, plotting graphs. And since we will be plotting graphs, we will be using matplotlib and seaborn. So here what I'm doing is I am importing matplotlib and seaborn, and I've set some basic styles. Like I've used the dark grid style from seaborn. I have increased the font size and the figure size for matplotlib so that we can see the figures a little more easily. Now, if you want to understand what all of these mean, I will refer you back to the previous lecture on data visualization with matplotlib and seaborn. Okay, so with the imports out of the way, so let's first look at the number of countries from which there are responses in the survey, and maybe plot the 10 countries with the highest number of responses. So there was a question, where do you live? And so the column name for that was country. So we just see that from the schema, country corresponds to where do you live. And from the survey data frame, if we just get the country column and then call .n unique on it, so that's going to give us the number of countries that are there in this data set. So respondents from 183 countries have answered questions, and that's pretty good. It's quite wide, but it might be better to look at what the distribution of responses across countries looks like. Now we cannot plot the entire distribution for 183 countries. So maybe what we'll do is we will simply look at the top 15 countries from where we had the maximum responses. And the way to do that is to take the survey df dot country, the column, and then use dot value counts on it. So dot value counts is going to, well, let's see what that does. So you can see here dot value counts, that's going to take each distinct value on country. So each unique value inside country, and then take that and count the number of values for each one. So here you can see that these are the different value counts. So for each country, we now get back a count, and this is a series essentially. And then from that, and this is going to be sorted. So you can also decide whether you want this to be sorted. So you can set sort equals true, and you can set ascending equals false. By the way, if you want to show this documentation inline for any function that you're using, all you need to do is press Shift plus Tab. So here I'm pressing Shift plus Tab, and that shows me the documentation. Okay, so we have the value counts, and then we pick the top 15 countries out of it. So those are the top countries. You can see here United States at the top, then India, then UK. And it's good to look at it this way as a table, but you cannot really grasp what is the difference visually, what is the distribution looking like, and that is where a bar chart will probably help. So we can use the index of the series as the x-axis, and then we can use the values in this series as the y-axis. So we are going to create a figure here. So I'm just going to set a plt.figure fig size just to make this a big figure. We're going to set a title for it. So we are going to set the title as the question that was asked. And then we are going to use seaborn.barplot. So seaborn has been imported as SNS, and we use the bar plot. And for the bar plot, we give an x-axis and a y-axis. So the x-axis, we are going to use the index, the names of the countries. And for the y-axis, we are going to use the values, which is the number of respondents from each of these countries. So there you go. Now you have the graph. Now, before we analyze this, I just want to say by default, these labels are printed horizontally. And if we do print them horizontally, there will be a lot of overlap. What we've done here is we've called the plt.xsticks function, and we've set rotation to 75. So that has taken these labels and then rotated it 75 degrees. And because of this, now you can see that they're slightly slanted and we can all read them. Okay, so now we have the graph. So looking at the graph, it seems like a disproportionately high number of responses came from United States and India, right? So the United States has 12,000 responses, and then India has 8,000, which is about only about 75% of the number of responses from the US. And then next is United Kingdom, which is less than half of India. And that already tells you that probably this survey is not really representative of programmers around the world. Maybe a large 12,000 plus 8,000 plus 4,000. So that's about 24,000 out of 65. So that's about more than 1/3, more than 40% of the responses have come from these 3 or 4 countries. And you might, if you think about this a little bit, it makes sense because one, this survey is in English, so it was only conducted in English. So therefore, the programmers from non-English speaking countries probably did not get to hear of it. Second, Stack Overflow's user base is, Stack Overflow is also a platform that is completely in English. So its user base is primarily from countries where English is spoken in different professions. And those happen to be the top 3 countries: United States, India, and United Kingdom, where we speak English on a day-to-day basis in our professional lives. Okay. So that's something to consider, that the survey may not be representative of the entire programming community, especially the non-English speaking countries. And it's something for Stack Overflow to consider. Maybe they should try translating their question and answers into different languages. And maybe they should also translate their survey into different languages so that they can get a more representative result. Okay. Now there's an exercise for you here. What you can do is you can try finding the percentage of responses from English speaking versus non-English speaking countries. So here I've linked to a list, a CSV file, which contains the list of languages spoken in different countries. See if you can combine that data with this data to create a new column that says English speaking, and maybe it contains yes or no or true or false for the English speaking column. And then see if you can see how many responses are from English speaking and how many are not. Okay, so that was about the different countries the data came from. Probably the next thing that we can study is the distribution of the age of the respondents. So the age is another important factor to look at, and this time, because age is numeric, we can probably use a histogram to visualize it. So we are going to use plt.hist, and let's check what the question about age was. So the question was, what is your age in years? And a lot of people may have preferred not to answer this question. Fortunately, what happens is when we use these matplotlib and cbound functions, any empty values are automatically ignored. So now we are calling plt.hist, and then to it we are passing the surveydf.age. So this is the column containing the age values, and these are all numeric, remember. So then we are also going to set a number of bins. So what we want is, we want to take the ages starting from 10, because we've removed everything below age 10. So we want to start from 10 and we want to go up to 80. You could also go up to 100 if you wish. Let's maybe change that to 100. And we are going to split this entire range of 10 to 100 years into ranges of 5 years. You could split this into ranges of 10 years as well, but we'll split it into 10 years. And then we will count the number of responses in each age group. Okay, so this is what the chart looks like. So it seems like that there are very few responses below 15 years of age, and a little over 2000 above 15 years of age. But the maximum bulk of the responses seem to be in the range of 20 to 45 years. Maybe you could say 15 to 50 years. So that seems to be the sort of the professional lifespan of a programmer to a large extent. But on the other hand, you can still see thousands of responses beyond the age of 45 and 50. It's common that a lot of people tend to fall into this age range of 20 to 50, but on the other hand, you have people from all over, all the way going up to close to even 80 years of age. Okay, so that's good. Now we understand the distribution of age, and roughly this is representative of the programming community in general. Especially since a lot of young people have taken up computer science as a field of study or a profession in the last 20 years, right? Colleges now have computer science degrees. The number of jobs in computer science have increased, and most new jobs tend to be taken by younger people, and most new degrees as well. So that's why it is slightly representative, and you can do some research on how exactly representative it is and which age groups are left out. And here's an exercise for you. You may also want to just create specific age groups like 10 to 18 years, 18 to 30 years, 30 to 45, 45 to 60, and so on. And you may want to create a column called age group, which will contain, based on the age, it will contain one of these values. And then what you can do is you can repeat the analysis in the rest of this notebook for each age group. If you just want to pick out your age group, let's say you're in the 30 to 45 age group, and you just want to know what programmers in your age group think, then you can just do this analysis for your age group, and that'll be an interesting thing to try out. That's a project idea right there. Then let's look at the distribution of gender. We've already done a small simplification here where we've excluded multiple responses. And now it's a well-known fact that women and non-binary genders are underrepresented in the programming community. So we might expect to see a skewed distribution here. If we do schema.gender, here it looks like the question that was asked was, which of the following describe you, if any? So people were open to leaving it blank. And then we have the gender counts. So now we are taking surveydf.gender and then using value counts here. And already you can see that there is a huge drop. There are 45,000 responses from where people have selected man as the gender, and there are about 3,800, only 3,800 values where people have selected woman. And let's also include in value counts, you can also include drop any equal to false. What that does is that also tells you how many people have picked nothing, no value. So now what we can do is we can use a pie chart to visualize this distribution. So once again, we take these gender counts and we use plt.py, and we can then give it an index. We can give them some labels as well, and we can give the chart a title. So here you go. Now it seems like around 71% people have picked man, only about 6% have picked woman, and only about 0.6% have picked non-binary, genderqueer or gender non-conforming. And if we exclude the nan values, so if we exclude the no answers, so among the people who have answered, it seems like 92%, close over 91% are men. And this number is actually, so that means only about 8% are women or non-binary. And this number is actually a far more skewed than the overall percentage. So the overall percentage of women and non-binary genders in the programming community is estimated to be about 12%. So this number still has some skew. And what this number tells us in general, and even the overall figure, is that there is a diversity problem in the programming community that we definitely, if 50% of all people are women, and then there is a larger number, I'm not sure about the number, but a larger percentage of people also identify as one of the non-binary genders. So we definitely need to have more representation in the programming community, and we should support people from underrepresented communities and encourage them to be part of the programming community. Okay. And an interesting exercise for you now to do would be to compare the survey responses and preferences across genders and repeat this analysis with those breakdowns. So for each graph, maybe instead of for each bar chart, try to show side by side men versus women and see how things differ. So for instance, you could try and figure out how do the relative education levels differ across genders. Do women hold similar degrees in terms of percentage, or do they hold higher degrees? And you may be surprised. How do the salaries differ? That is another thing to figure out. We definitely know that there is a gender pay divide, there is a gender pay gap. So maybe you can discover that, and there's a column which talks about salaries. And then you may find there's this analysis on gender divide in data science, and you may find that useful. That is also an exploratory data analysis project if you want to explore that a little bit. So that was about gender. Now let's talk about the education level. Now, formal education in computer science is often considered an important requirement of becoming a programmer. Computer science is one of the most sought after degrees, and both in bachelor's and in master's. Let's see if this is indeed the case, because on the other hand, a lot of you may have learned programming on your own, and there are many free resources and tutorials available online to learn programming. So what we'll do is we will use a horizontal bar chart to compare the education levels of different respondents. So you can just check here schema.education level. So there's a ed level column. The question was, which of the following describes the highest level of formal education that you've completed? So keep that in mind. This is the highest level. So what we are going to use now is a count plot. So what's a count plot? We can check the documentation. So the count plot shows the counts of observation in each categorical bin using bars. So what that means is, if you check the different values that education level contains, so if we just check if we just check surveydf.ed level let's say what are the unique values. So these are all the unique values. And the count plot is going to tell us for each of these values, how many observations are there, like how many times was this particular option picked, or how many times does this particular value show up in that column. Okay. So we pass to count plot surveydf.education level, and you can just do this, but that is going to make vertical bars. And if you just want horizontal bars, you can just pass y equals surveydf.education level. So this is what the graph looks like. Maybe we should increase the size of the figure a little bit. So let's just set plt.figure fig size. Okay, this is a lot better. So the question is, which of the following describes the highest level of formal education you've completed? And now you can see here that it seems like out of the 65,000 respondents, about 25,000, over 25,000 hold a bachelor's degree, and then another close to 12,000 hold a master's degree, and then there are a few more which hold a doctoral degree, probably about 1,500 or so. So all of these three combined, it seems over half of the respondents hold a bachelor's or master's degree. So most programmers definitely seem to have some college education, definitely maybe some STEM education, what is called some kind of a STEM education. But it's not clear from just this graph alone whether they hold a degree in computer science. Okay, so let's dig a little bit deeper into that. And one problem with this graph is that here we are showing the absolute numbers, and probably what we really want to understand is percentages. So one exercise for you is to convert this graph to just show percentages instead of the full numbers. Okay, and that will probably give a clearer idea, because we probably want to know, out of the number of people who have responded to this question, what percentage have mentioned that the bachelor's degree is the highest degree that they hold. And that is probably the more relevant question to ask. So you can try and modify this code to just show percentages. Okay. But keeping that aside, we could tell that over half of the respondents hold a master's or a bachelor's degree. All right. So now let us then take and plot the undergraduate majors. So this time we will look at schema.undergrad major, which was what was your primary field of study. And we will then convert these numbers into percentages. So to convert these into percentages, we take the value counts for each of the values. So here we say surveydf.undergrad major.value counts. So for each major, like computer science major, you have 31,000 responses and so on. So what we can do is we can divide that by the total number of responses given for undergraduate majors. So let's just take the surveydf.undergraduate major and call .count on it. So .count is going to count the total number of null values. So if we do that, then you can see that now we get back a fraction. So for each major that was provided here, we get back a fraction, 0.61 and so on. And if we multiply that by 100, we are going to get back a number, or we're going to get back a percentage. All right. So now we have a 61% have computer science, and another 9.3% have picked another engineering discipline, and so on. All right. But it's probably better to look at that using a graph. So we just put this result into a variable called undergraduate percent, and then use sns.barplot to plot it. Okay. So now here we have it. So in terms of the primary field of study, it seems like out of the people who have responded, over 60% say that computer science or software engineering or computer engineering was their major. Now, the one way to know, this is like a glass half full, half empty kind of a situation. The way I would interpret this is that close to 40% of programmers holding a college degree have a field of study other than computer science, which is very encouraging. A lot of people after college feel that you cannot switch your field. That is definitely not true for computer science. If you want to get into computer science and you have some sort of formal education, some sort of STEM education, you can absolutely pursue it. There are so many online resources, like close to 40% of people who are in the domain are from streams other than computer science. So I think this is a very encouraging sign, and I think this number is only going to go higher because there are better and better resources available, and programming is proliferating into pretty much every domain now. So you do a little bit of programming no matter what you study, and that equips you to become a programmer as well. Even data science, for example, is primarily a lot of programming. So what we understand in general is that while college education is helpful in general, you do not need to pursue a major in computer science to become a successful programmer. And one trend that you might have noticed here while we are doing exploratory analysis is that first, every time we plot some graph, there is some background to it. There is a reason why we are exploring a particular column. And this is something that we've explained here, that we want to understand, like the reason we are looking at education level is to understand whether formal education is important or not. So have some background, have something in mind when you are exploring a particular column. And then once you have explored that column, once you have plotted a graph, try to gain some insight from it, try to make some kind of an inference or an observation or a hypothesis based on it. Sometimes you may need to then go do more research to identify if your hypothesis is correct. And in other cases, the inferences can become pretty clear. For instance, in this case, it is pretty clear that a lot of people do not have a computer science degree. All right. And that is the best part of exploratory analysis, is that you get to form all of these interesting inferences. Each time you draw a graph, you learn something new. Each time you look at a column, you learn something new. And then there's an exercise here for you. There's a column called new ed IMPT. Let's see what that column is. So that's, let's see, schema.new ed. Okay, so that column is the question in the column is, how important is a formal education such as a university degree in computer science to your career? So now what you can do is you can take this column and analyze the responses, the distribution of responses for people who hold some college degree for people who hold a computer science degree versus those who do not. Okay, try and analyze these results. So what percentage of people who hold a computer science degree have selected that formal education in computer science is important to the career, and what percentage of people who do not hold a computer science degree have selected that formal education is important for their career? And see if you notice any difference in opinion. My guess is somebody who holds a college degree may value it highly, but somebody who does not hold a college degree but still become a programmer will probably say that it's probably not that important. So do check it out, do discover there are more insights to be gained here. And then one last area that we will look at is employment. Now, especially among programmers, freelancing, contract work and part-time work is slowly becoming a more popular choice. So it would be interesting to see the breakdown between full-time, part-time and freelance work. So maybe let's visualize the data from the employment column. So the employment column was, which of the following best describes your current employment status? And what we've taken here is, once again, we are going to plot a simple horizontal bar chart. And one of the things that I want you to take away from this is also that simple charts are often good enough for a good analysis. You do not have to come up with a lot of fancy charts, although it's good if you can find the best chart for the best kind of graph for every statement, for every situation. But even simple bar charts, line graphs, scatter plots can give you a lot of information, right? And so you are very well equipped at this point if you've worked through this course. So now we look at the surveydf.employment.value counts, and we are just setting normalize equals true. So when we set normalize equals true, that also gives percentages. And then we're also going to convert sorted in ascending order and convert that, multiply by 100 to get percentages. So normalize gives fractions, and then we convert that into percentages. And then we use the pandas plotting function. So dot plot, and this, so it's just to show you a variation of different ways of plotting. And we are going to plot a horizontal bar chart with the green color. So now you see that among the people who have replied to this question, employed full-time seems to be about 70%. So 70% people are employed full-time among the respondents, but there are a fair number of students as well. So there are about 12% of students. What you might want to do is you might want to break down, and then there are people who are not employed but are looking for work. And then there are people who are freelancers, part-timers, and then there are people who are just, maybe their hobbies, they're not really looking for work, they're not employed, or they're retired. So you might want to create a new column, employment type, that contains values like enthusiast, which could mean students or people who are not employed but are looking for work. And then professional, which is people who are employed full-time, part-time, or are freelancing. And then other, which is people who are not employed or retired. And then what you can do is you can see for each of these graphs, how do the preferences differ between students and professionals, between enthusiasts and professionals, right? Especially some of the things that we'll do after this, which is analyzing programming language preferences and things like that. So that's a good exercise to do. In any survey, in any analysis, all of these breakdowns offer a lot of insights, and the best way to do it is identify which group you lie in. Let's say you are parsing by gender or by age or by your employment status, and then do the analysis just for yourself and people like yourself, and that is going to give you a lot more insight. Okay. Now, one interesting observation here is that if you take away students, then among people who are employed, it seems like at least 10% of the people are working independently as contractors or freelancers or self-employed. For instance, startup people who are doing startups or running their own companies. And that is pretty encouraging. That's a pretty high number for a technical field like this, to be able to work on your own without being formally associated with any company. So that's a great thing. That it's also a way for you to try and break into the field. If you are looking to become a programmer or looking to break into data science, maybe initially you can try some freelance work, you can try maybe an internship, some part-time work, and that can help you transition into a full-time role. So that's something to consider as well. Now, in terms of what are the actual roles held by the respondents, we can look at the dev type field. So you can see here there's a dev type, which of the following describes you, and there are a bunch of different values for the roles that are provided. Now, the problem here is that this allows selection of multiple values. So if you just check the dev type.value counts, or let's just do dev type.unique, you will see here that there are a lot of different possibilities. So you can see here that there is a developer, desktop, or okay, let's just try value counts. That's probably a little bit easier. Yeah. So you can see here that there are some simple options that were picked, like developer full stack, just that, and then developer backend. But then there is also, you can select multiple options. So you can select developer backend, and the semicolon indicates that multiple options were picked. So about 3,000 people have picked 3 options: developer backend, developer frontend, and developer full stack. And about 2,000 have picked developer backend and developer full stack. And then there are a lot of people who have picked many different combinations. So it's not really clear even from the data how many options were available, but it seems like this person has picked a whole bunch of different options, and so is this person, and so on. So this is where we might need to do some more processing. Now we might need to take this column, which contains a list of values separated by semicolons, and maybe split it out into multiple columns. Okay, and for that, what we are going to do is we are going to define a helper function called split multi-column, that is going to take a series or a column of data which contains list-like values, lists of values. So a column like survey.devType, and split the values of that column into multiple columns. Okay. Now I will not go over the code here, and you can try this. You can try to run each line one by one, and you can try to understand the code. So by this point, I hope that you are well equipped to understand this code. Just run each line on a different cell. If you're not, you can also ask on the forum, and you can have a discussion where you can share where you're stuck or which part you don't understand, and you can have a discussion to figure it out. But let us look at the output. So we know what the input into this looks like. So the input into this split multi-column function is going to be a series where people have picked either none, or one or more than one options for their employment type, for their job role. So we can call split multi-columns on survey.devType, and passing this column returns a data frame. So we get back a data frame dev type df, and if we just check this data frame, it seems like this data frame now has one column for each of the options that were provided for the question. So now we have one column for developer, desktop, or enterprise applications. Then we have developer full stack, developer mobile, designer, and so on. So there are in total 23 columns. So there are about 23 options that were given for your job role. And what we have is, for each respondent, we have either true or false. So for instance, for This respondent has not selected developer desktop or enterprise, but this respondent has selected developer full stack, and this respondent has selected developer mobile, and they have not selected developer frontend or backend. All right. So this is how sometimes we might need to do a little more processing of our data. We might need to break one column into an entire data frame so that we can do our analysis. And now that we have this data frame, the dev type df, we can now use this to identify what were the most common roles. Okay. And a simple way to do that would be to simply count the number of trues in each column. And you know that true when it is converted to an integer becomes 1, and false when it is converted to a number becomes 0. So what we can do is we can simply take the column wise sums. So we can just take dev type dot sum. So now we get a column wise sum, and then we can sort those values in a descending order. So that's going to give us these dev type totals. So now you see that we have developer backend, developer full stack, developer frontend, and so on. So those seem to be the most common roles. And it's not surprising that the Stack Overflow is primarily a tool used by developers and professional developers for finding answers to small questions on writing code. So it's not uncommon that the developer role that you see is the most common one. But one interesting thing for you to figure out would be what percentage of respondents work in roles related to data science. And then you can probably also try and figure out which role has the highest percentage of women. So what you can do is you can just filter. Now that you have this data frame, you can then merge it back into the original data frame. So you can create a new merged data frame which contains the columns from survey df, but also contains these columns for each role. And then you can try and find out which role has the maximum percentage of women. Okay, that's an interesting thing to figure out. So with that, we end our exploratory analysis, and we've only explored a handful of columns from the 20 columns that we selected. We've only explored about 5 or 6. So you can explore and visualize the remaining columns. Here is, you have some empty cells, and you can always add new cells using insert cell below. So please do that. The more you explore, the more you learn. It's possible that while you work through this notebook, you find 5 or 10 interesting columns, and you just want to do a project using those columns. And that's perfectly acceptable. You can use this data set for your project. Just do not repeat the same analysis that is done here. Do something a little more interesting. And before we continue, let us upload our work. So from time to time, keep running jovian.commit so that you do not lose your work. All right, so now we come to a slightly more interesting part, although I think the exploratory analysis was pretty interesting as well. But now we can ask some questions and then answer them. So we've already gained several insights about the respondents and about the programming community in general, simply by exploring individual columns. But let's ask some specific questions and try to answer them using the data frame operations and using interesting visualizations. Okay. So the first question that we'll ask is, what were the most popular programming languages in 2020? So this survey was conducted in February of 2020. So this is technically 2019's data. But see, so we see schema.languages worked with. So the question asked was, which programming, scripting and markup language have you done extensive development work over the past year, right? So which languages have you used in the past year? But this is a two-part question, and the second part is, and which do you want to work in over the next year? So here the respondents were presented with a list of options, and then for each option they had 2 checkboxes. So the first checkbox they would tick for this part, whether they've worked with it in the past year, and the next checkbox they would tick for this part, whether they want to work on it over the next year. And the responses were then taken and they were broken into two columns. So here we have the language worked with, which contains the answer to the first part, which language have you worked with in the past year. But then we also have the language desired next year, which has the exact same question, but this contains responses to the second part. So I'm showing you this because this is something interesting that, you know, with real world data, and especially with how surveys are conducted, you might often have this, and without the context, you might not understand what's the difference here, because it seems like languages worked with and languages desired next year have the exact same question. So you may want to just go through the README, or you may want to take the survey yourself to understand that, okay, there are 2 parts and the first part is covered in the first column and the second part is covered in the second. Okay. So putting that aside, let's just look at what some values in the languages worked with column look like. So it looks like, once again, people could select multiple options, multiple languages. So you can see that the first person has selected C# and then HTML, CSS, and then JavaScript. So they are separated by a semicolon. So this is similar to the dev type field. So the first thing that we might want to do is just split this into a multi-column. So we just call split multi-column on surveydf.languages worked with. And then we can see the languages worked df. So this is now the data frame where we have 25 columns. So it seems like 25 languages were presented to the respondents. And now for each of those, for each respondent, we can see true, false. So true indicating whether that respondent has used the language, and false indicating whether they have not. Okay. So now going back to the question, what were the most popular programming languages in 2020? So what we can do is we can try and identify percentages, what percentage of people have selected JavaScript, and then what percentage of people have selected Swift and Python and so on, and then plot that as a bar chart. Okay. So once again, to get these percentages, we simply say languages worked df.mean. So this is another way to do it, because true becomes 1 and false becomes 0. So if we take the mean of this entire column, if we take a column wise mean, we get back the percent or the fraction of true values in the column. So the mean is simply sum of all the values divided by the total number of values. So since the zeros or the falses go away, that is basically the number of true values divided by the total number of values. And that is essentially the percentage of true, right? So we take or the fraction of true. So to convert the fraction into a percentage, we multiply by 100, and then we sort values in descending order. So that gives us the percentages of each language. So it seems like JavaScript is the most popular language, followed by HTML, CSS, and SQL, and so on. And let's visualize this once again using a horizontal bar chart. So now it seems like the languages used in the past year, once again, JavaScript was the most popular language, followed by HTML, CSS. And this is no surprise, because today a lot of software has moved onto the web. Like you probably spend most of your time in the browser. Even the Jupyter Notebook platform that we're using is actually running in the browser. And the only way to write code in the browser is, one, you have to write HTML, CSS, and second, you have to write JavaScript for interactivity. Now JavaScript might be higher than HTML, CSS because you can also use JavaScript on the server side using a framework called Node.js. And because of all these reasons, JavaScript is the most popular language, because it is the de facto language of the web. And then we have, so again, now we have plotted this chart, and based on this chart, we can make some inferences, right? Then we have SQL. Now, once again, today, all applications need some kind of a database. And the most popular form of database is what's called a relational database, or what is called a tabular database. So a lot of the data, let's say the data of your Facebook accounts, the data of your Twitter, the data of your Instagram, or any platform that you use, the data that you put into Jovian, a lot of the data is saved in SQL databases. And the way to interact with these databases is using the SQL language. And that is why SQL is probably pretty popular as well. But beyond that, if you take away web development and take away database access, the actual application development, like any backend application development or data science, a lot of these other areas, any non-web related development, seems like Python is the most popular language. And this is again no surprise, because Python is a general purpose language, and it has beaten out Java. So Java was the de facto language for all development pretty much for about 20 years, but it seems like Python has now beaten out Java. So it's a good thing that you're learning Python. It is definitely an in-demand language. Okay. And there is a whole wealth of information that you can gather just from exploring a little bit deeper into this question. For example, what are the most common languages used by students? And how does the list compare with the most common languages used by professional developers? So is there a gap between what students learn and what professional developers use? You might want to answer, what are the most common languages among respondents who do not describe themselves as front-end developers? Because front-end development, you don't really have a choice. You have to use JavaScript. TypeScript is a choice, but it's a small choice. So if you just exclude front-end developers, can you then answer what are the most common languages people use? Can you try and find out what are the most common languages used by respondents who are working in a field related to data science? And maybe also see in terms of age, developers who are older than 35 years of age, or maybe developers who have more than 10 years of programming experience, what are the most common languages used by them? And what are the most common languages used by people who are younger? Do you see a shifting trend? And what are the most common languages used in your home country? That is something that you can try and find out, because there are responses from over 180 countries here. Is there a difference between, let's say, US and India and China and different countries? Then moving ahead, another similar question we could ask is, which languages are people most interested to learn over the next year? So for this, we can use the language desire next year column, which will have pretty much identical processing. So we take the language desire next year and we split it into multi-columns. Then we get percentages for each language once again by taking the mean and sorting the values and multiplying by 100. So you can see here the language interested percentages. These are the values. And let us just jump into visualization directly. The visualization is once again pretty much identical. And it seems like that Python is the language that most people are interested in learning. So we have Python, JavaScript, HTML, CSS. Again, they seem to be close by, and followed by SQL and TypeScript. And it's no surprise that Python is the most sought after language, because it's an easy to learn general purpose programming language, and it is very well suited for a variety of domains like application development, numerical computing, data analysis, and so on. And in fact, we are using Python for this very analysis. So you are in good company. If you're learning Python, you can apply it to a whole host of different domains. What you can do is now you can repeat the same exercises that we discussed for the most common languages. Just replace all of these questions with the languages people are most interested in. So those are some exercises. And you can also, the next question, what we'll do is we'll combine these two things. So the question here is, which are the most loved languages? That is, where do you see a higher percentage of people who have used the language and want to continue learning it over the next year? Okay. So this may seem like a somewhat complicated question to ask. Okay, people who have used the language in the past year and they also want to continue learning it, how am I going to figure that out? It may seem a little bit tricky, but it's actually really easy to solve using Pandas data frame operations. So here's what we'll do. We will create a new data frame, languages loved df, which has the same structure as languages work df and languages interested df. So again, for every language, it has a column, and then for every respondent, there is a row, and there's a true value only if the corresponding value in both languages work df and languages interested df are both true, right? If somebody has worked in that language in the past year and wants to continue using that language, then we are going to put in a true there. And the way to do that, it's really simple. All you do is you take the languages work df and then you put in an ampersand, and then you pass languages interested df. What this will do is this will do a element wise AND, right? A Boolean AND. So if two values are true, two respective values, then you will get 2. And if you have a true and a false, or a false and a true, or a false and a false, you will get back false. All right, except that this is going to happen on a per element or a per value level. So now we take languages loved df, and then we look at it. So for example, this respondent has true set for C# because this person has worked in C# and they are interested in continuing to work in C#. So that's we are saying that this is a proxy for saying that they love this language. Okay, so let's convert that into percentages. Now we want to take these numbers, and for each language we want to identify how many people love it out of the number of people who have used it in the past year. So we take language loved.sum, and then so that's a column wise sum, and we divide each of the column wise sums by languages worked.sum. So for the column C#, we will count how many people love the language, so how many trues there are in this column, divided by how many people have used the language. And then we are also going to multiply it by 100 to convert it into a percentage, and we are going to sort it in a descending order. And let's take a look at that. So you can see here that we have languages loved percentages. You can see that for each language we now have percentages, and you can see who the winner is here. So the winner seems to be a language called Rust, and let us look at it in a plot. So the winner seems to be this language called Rust. You may not have heard of it, but it is a low-level language for doing systems programming, and it provides the performance of languages like C++, but it provides many conveniences and a type system of some of the best languages, things like Scala and Java and so on. So it's a pretty useful language. A lot of people enjoy using it, and it's interesting to see that a small language with a growing community is one of the most loved languages. And in fact, you can see the hints here. Now, if you see this graph, Rust seems to be used in a very small fraction. So you see Rust here, it's a small fraction of people who use it. It's far smaller than, let's say, JavaScript. But if you look at this graph in terms of people interested in using or learning Rust, it is way up ahead, somewhere at the top, almost close to about a third or maybe higher than a third of JavaScript. So it definitely seems to be a language that's gaining a lot of popularity and a lot of interest. So maybe if you're looking for a new language to learn, Rust may be a good choice. And this metric that we just calculated is something Stack Overflow calculates every year based on their survey results. And Rust has been Stack Overflow's most loved languages for 4 years in a row, followed by TypeScript. And TypeScript again is a language that offers an alternative for web development. So these are things that you should do. That once you get an answer, once you get a graph, maybe just search online on why the result might be such. So you can learn a little more about Rust and TypeScript. Now, what I find probably even more interesting is that Python features at number 3, despite already being such a widely used language. And that's generally not true for widely used languages. If you see JavaScript, in terms of the love score, it's fairly low and Java is far lower, whereas Python has remained at number 3, right? So it seems like people who use Python enjoy Python, and that is because the language has a solid foundation and it is really easy to learn and use. I hope you've been able to learn Python. You can now say that you're comfortable with Python in just these 6 weeks. And then it has a strong ecosystem of libraries for various domains, and it has a massive worldwide community of developers, and that now includes you and me, so who enjoy using it. So I've been using Python for the last 12 years. I definitely want to continue using it for the next 12 as well. And I hope you feel the same way. So that's about the most loved languages. We now have some insights about that. The next a simple exercise that you can try here is to identify the most dreaded languages, which is languages which people have used in the past year, but do not want to learn or use over the next year. There's a small hint here. What you can do is you can simply invert the language's interested data frame. So and the way to invert it is using this tilde operator. So just invert that data frame and then do the same thing that we did here. So you should be able to answer the most dreaded language, and then see if your results, you get the same result as what the Stack Overflow results present. So you can always refer to them. So moving further along, next question here is, in which countries do developers work the highest number of hours per week? Okay. Now, to do this question, we will need to use the group by function of a data frame, the group by method. And there's a small caveat here. We only want to consider countries with more than 250 responses, because otherwise it's not really representing an average, because there are definitely lots of countries with thousands of responses, and we are setting a threshold of 250 so that if there's a country where only 10 people have responded, we are not going to consider it in terms of to get the average number of hours per week. So we take survey DF and we group it by country. So what this does is it takes for each value of country, and there are 184 values. We take all the rows which have that country related to that country and then separate them out into groups. And so far we've not performed any operation, so you don't see any result here. Now for each of these rows, the column that we are interested in is work week hours. So we select the column work week hours, just as we select the columns of our data frame. And just as an example, let's select the age column as well. So now once again, for each of the groups, we have all the rows, and from these rows, we've only selected the work week and age columns. And now we need to aggregate them. So one way to aggregate them could be using a mean. So if we use a mean, then we can see here that work week hours and age. So we will get back a new data frame where now the index is the name of the countries, all the different unique values in countries. And then the values for work week hour and age are the averages from those groups. So all the rows from Afghanistan, we've taken an average of the work week hours and put that value here. Similarly, all the groups from Afghanistan, we've taken the age and all the rows from Afghanistan, we've taken the age and we've put in the average value here. Okay. So this is how you group by, and you can learn more about this in the Pandas lecture, which is lesson 4. Now what we want to do though, is we want to only look at countries which have more than 250 responses. So the way we're going to do that is first we're going to create a countries data frame. And this is exactly what we just did, group by country, but just keep the work week hours and take the mean and then sort to aggregate and then sort by work week hours in a descending order. So that's a country DF. Okay, so you can see that these are the countries with the highest, these are countries with the lowest, but it's possible that a lot of these countries, probably the number of responses is really low. So what we will do is we will create a new data frame called high countries DF, where we will take these, where we will only select the rows where the value counts are greater than 250. So we are getting surveydf.country and we are trying to find the value counts of each country, the number of responses from each country, and then we are filtering out those only where the responses are greater than 250. And then we use the .loc.loc function to pick values from the countries DF with only value counts greater than 250, and then we pick the top 15 out of those. So let's see now. So now we have the top 15 countries. Okay. And once again, if you do not understand this, there are a couple of things you can do. Revise the Pandas lecture. That's one thing you could do. Look at the documentation of countries of .loc, and split this into small parts. So first take this surveydf.country.value counts, run it in a cell. Take that and compare that with 250 and see what the result of that is. And then put that into countries df.loc and see what the result of that is. And then add in the head. So with all of these things, it's a question of breaking them down step by step. And then the more you break them down, the more you understand and the more you will be able to use them. So now we have the high response countries. And these are the 15 countries with the highest number of working hours. It seems like some South Asian countries, some Asian countries like Iran, Israel and China have the highest working hours, which is followed by United States. So that's interesting. And then we have Greece. So people are probably working a lot, programmers are working a lot in Greece. And once again, we see a bunch of Asian countries all the way till, actually a majority of these seem to be Asian countries. And then there are a few European countries and then there is United States. But overall, there isn't too much variation. If you see 44 is the highest value. If you just take the first three as outliers, then here you have 41 to 40. So on average, there are only about people are working at about 40 hours per week. There's no variation where there's a country with an average of 60 hours or a country with an average of 20 hours. At least it seems like so from the top 15. So now a few exercises that you can try is try to compare how the average working hours compare across different continents. So you may find this list of countries in each continent useful. Try and find out which role has the average number of has the highest average number of hours worked per week out of all the developer or out of all the roles that we looked at. So you may need to merge with the dev type data frame that we created, which had one column for each role, and try to find out maybe how the hours work compare between freelancers and developers working full-time. Well, full-time developers, it's possible that you might find that the average is around 40. But freelancers, one of the reasons people take up freelance or even part-time work is because they want free time to work on other things. So let's try and verify if this is true. Do freelancers work less or more? And that could help you maybe even decide if you want to choose between a freelance or a full-time role. Okay. And then let's ask one more question. How important is it to start young to build a career in programming? Okay. And this is again something that is a question that a lot of people wonder, not just about programming, probably about data science and in general about any field. Can you enter this field let's say beyond, if you've not done it in college, and I think we've established that even if you've not taken it in college, you can still enter the field. But can you enter the field if you've worked in a different domain for a few years? Can you enter this field in your 30s, in your 40s, and so on? Okay. So what we'll do to answer this question is we will create a scatter plot of age versus the years of coding experience. So there is years code pro is asking, not including education, how many years have you coded professionally as a part of your work? Okay. So what we'll do is we'll plot age on one axis, on the x-axis, and then we'll plot the years of professional coding experience on the y-axis, and that should maybe give us a hint. So here is a chart, and this is what it looks like. Now, if you look at this, it seems, let's look at some values and let's try to understand this chart. And we've also put in colors here, and we'll touch that in just a moment. But if you see here in the, let's say you're looking at age 40. So at age 40, there are several people who have less than 10 years of programming experience. And there are even, so at every age, all the way from around 15 to even close to 50, there are people who have just started working as programmers. So what that means is that you can start programming professionally at any age. There's no restriction that you have to start early. People are starting in their 20s, in their 30s, in their 40s, and everybody is welcome. And this is professional experience. This is not just programming experience in general. So you can, if you put in the work, if you learn, if you're open to learning, if you're excited about it, then you can definitely get into the domain. And then we have also added a color for each of these dots. So each dot represents one response. So we've added colors. So the color we've added is, if a person is a hobbyist, then we represent them with blue, and if not, we represent them with orange. And once again, it turns out that a lot of the people who are programmers also say that programming is a hobby for them, and especially so in the initial years. So in the initial years, to get through the initial years, it will really help for you to just have programming as a hobby, something that you do just to, build things, just to solve problems, just something that you do on the weekend. And if you do that, then you will probably also have a long and fulfilling career in programming. So these are some inferences that we can draw from the scatter plot. We can also look at the distribution of the age first code column. So just to see when people have tried programming for the first time. And as you might suspect, a lot of people have some exposure to programming. Maybe they've written a first line of code, maybe a simple HTML page, or maybe just a hello world program. And Python's hello world is just this, right? So you can just type Python into a terminal and you just say print hello world, and that's your first program. But that by itself tells you what programming is. So it seems like a lot of people have been exposed to programming in their teens, and it depends on pretty much every field. You end up writing some code. So in Excel, you write formulas. In different streams of engineering, you probably use MATLAB or maybe some kind of a numerical computing package. Of course, in computer science, you write programs. If you're doing right now, in pretty much every field, there is some code that you're writing. So it's not surprising that people get some exposure to programming at an early age. But then there are also people who have experienced this after a certain age. Like you can see a lot of people doing so after the age of 30 and after the age of 40. And there is like a small number of people who have even become exposed to it all the way up to the age of 80. So there are people from all ages and walks of life who are learning to code. Okay. Now, here are a few questions that you can try and answer. How does the experience change opinions and preferences? So maybe what you can do is you can repeat the entire analysis while comparing the responses of people who have more than 10 years of professional programming experience. Like which languages do they use? Which languages do they want to learn? With those who do not have that, and this is going back to like students versus professionals. Now you can have three categories: students, professionals, and experienced professionals. And do you see any interesting trends? Do you see what one might call a generation gap in terms of the coders from the old days versus people who are learning it right now? What kind of roles do they occupy? What kind of languages do they prefer? And maybe you can also try and compare the years of professional coding experience across different genders, just to see if, and my guess is you might see that, although minorities are underrepresented right now, there are very few women, but my guess is you will see that there are more women now than there used to be earlier. So it's definitely, things are improving, and you can try and validate that. So that's one way, if you can try and compare the years of professional coding experience across different genders. So with that, we have barely scratched the surface here. We have almost been talking for about 90 minutes, and we've already gotten a huge load of insights, and hopefully you're thinking of many more questions that you would like to ask and answer using the data. Now, we've not even used all the 20 columns, only about 12 or 13 columns have been used, and then there are another 45 columns to pick from. So you can use these empty cells below to ask and answer more questions. So I'll let you try out, and you can try out all of these exercises. So there's really no end to this. The more you do, the more you experiment, the more you exercise these skills, the better you get at it. Now I've used fairly simple charts. I've not done many breakdowns. I wanted to leave that as an exercise for you, but try and replace each chart. So each chart or each graph that we have, try to use a different kind of graph, and maybe go through the Matplotlib gallery, go through the Seaborn gallery, and try and pick which might be an interesting graph to draw there. So these are all different exercises for you to try. Data analysis by itself is, there's a lot of depth in the field, and you can probably spend at least a few months just exploring different ways to slice and dice and analyze and visualize the data. So please do that. Okay, the best way to learn is by doing. Now, what we'll do is we'll just summarize some of our inferences and conclusions, and this is always a good thing to do at the end of your analysis. So here's some of the summaries. Like, based on the demographic data, we can infer that the survey is somewhat representative of the overall programming community, although it definitely has fewer responses from programmers in non-English speaking countries and from women and non-binary genders. We have also learned that the programming community is probably not as diverse as it can be in terms of gender, in terms of age, maybe in terms of the different languages or the different countries that are there. So we should probably take more efforts and support and encourage members of underrepresented communities. And race is another thing that we've not looked at, but that's another factor where there's a lot of disparity. And we've learned that most programmers hold a college degree, and although a fairly large percentage of them did not have computer science as their major in college. So a computer science degree isn't compulsory to learn to code or to build a career in programming, but some STEM education definitely helps. And a significant percentage of programmers either work part-time or as freelancers. 10% is actually a pretty good number. And this can be a great way for you to break into the field, not just in programming, but also in data science, which are very closely related fields. We learned that JavaScript and HTML are the most popular programming languages used in 2020. And then we learned that Python is the language most people are interested in learning. And we've learned that Rust and TypeScript are the most loved languages, both of which have small but fast growing communities. And finally, it seems like programmers around the world seem to be working on 40 hours on average, but there are slight variations by country. And finally, we learned that you can learn and start programming professionally at any age, and you're likely to have a long and fulfilling career if you also enjoy programming as a hobby. And especially it's going to help you during the first few years. All right, so that's our analysis. And as I said, there's a wealth of information to be discovered, and we've barely scratched the surface. So there are a few more ideas that I wanted to share with you. You can repeat the analysis for different age groups and genders and compare the results. Specifically, try and pick a slice of responses that represents you, right? So maybe the country you're from, the gender, the age group that you're in, and try and see what the preferences of people are and see if that reflects your opinions too. Try and choose a different set of columns. We've chosen 20 out of 65 and we've used about 12 of them. So you can look at a lot of the other columns, go through the README, go through the survey. Prepare an analysis focusing on diversity. So identify the areas where underrepresented communities are at par with the majority. So you might see that in education, actually, there's probably not a big difference in terms of the percentages of degrees that are different degrees held by people. But then there are places where there are differences like salaries. You will see that there is definitely a pay gap. and you can try and validate that and try to compare the results of this year's survey with the previous year and identify some interesting trends, because this is data that you get every year. And once again, you can go back to this link, stackoverflow.com, insights.stackoverflow.com, and you can download the raw data for every year. Now, one interesting exercise for you to do is to see the survey results. So you can see that this is a pretty long analysis that they've done a whole bunch of analysis on pretty much the similar questions that we have answered. So see the survey results and try to replicate the survey results graph for graph. This could be a great way for you to just see if you are doing the same kind of data cleaning and analysis and simplifications, and see how that affects your results. Now, if you can replicate all of these results, now that's a great sign that this is real world data and this is a large data set and this is a real analysis. So that's a real sign that you've done something significant in data analysis, and you can proudly then showcase that on your professional profile. Then we have this, I just want to share a few references. Now, we've used Pandas, Matplotlib, and Seaborn. So you can refer to the previous lectures. We've linked, you just go to 0topandas.com and you can find the lectures there. You can watch those lectures, or you can also just go through the documentation and the user guides. So you have the Pandas, Matplotlib, and Seaborn user guides. Also go through galleries on Matplotlib websites. So these galleries will show you all the different types of charts that you can create using these libraries. And finally, as I told you, we are creating this open datasets library Python package, which is a curated collection of datasets for data analysis and machine learning. So far we have about 6-7 datasets, but we are planning to add about 100 datasets here. So over the next few days, and we've released this library just yesterday. It's something that we worked up quickly to make sure that it's easy for you to download these datasets. So we are going to add about 100 datasets here. So you can use these 100 datasets for your course project as well. Okay. And that is the next step that I want to talk to you about. Now we've looked at this, what we saw today, the exploratory data analysis is basically what you need to do on your course project. So you simply need to repeat this. You can repeat it with the same dataset and ask different questions, do different analysis, pick different columns, or you can pick a different dataset. So let's open up the course project page. And then the objective of the course project is exactly similar to what we did today. You find a real world dataset of your choice. You use Numpy and Pandas to parse and clean and analyze the data. And you use Matplotlib and Seaborn to create visualizations. And then you ask and answer interesting questions about the data. And an optional but highly recommended step, because you've put in so much work, and if you can just consolidate all of your learning into a blog post to showcase your work, that is something that you can do as well. So I just want to give you a quick overview of the course project. And then we have a few exciting things to close out. So now the course project, this is a starter notebook. And by the way, we've done a walkthrough of the course project as well. So you can just check that out too. So on the course project, you can take the starter notebook and just run the starter notebook on Binder. And you can also run this starter notebook on your local computer. So you do not have to run it on Binder. So I just want to show you how to run it on your computer. So here I have a terminal. Let me just zoom in a bit. Yeah, so here I have a terminal, and this would be a terminal or a command prompt or an Anaconda prompt that you would need. And if you want to download this to your local computer and run it locally, then what you need to do is click on the clone button. So click on the clone button and just paste that command. Now you will need to run this command, but then to run this command, you need the Jovian command line tool installed. So actually I'm just going to skip that command, and I'm just first going to run pip install Jovian upgrade. So that's going to upgrade the Jovian Python library for me. And once the Jovian library is installed, you can see that we now have this command line tool called Jovian that you can use. So now once again, I can copy this clone command, come back here, run Jovian clone, and just simply the title of the project. So username / the name of the project, and press enter. Now that is going to download the files. So you can see that these files got downloaded to my desktop, the 0topandas course starter. If you wish, you can change the name of this folder. So let me just, let's say I'm going to analyze the state of JavaScript survey. So I'm just going to call this state of JavaScript 2019. This is the data that I'm going to analyze for my project. So then I go into this folder, state of JavaScript 2019. Now here you need to install all the different libraries, and we suggest installing these libraries inside an Anaconda environment. What you can do is you can manually create an environment. So conda create -n, and then simply give it a name. So let's say course project, and you can set a Python version for it. So these are the same instructions that are provided in each lecture notebook. So let's just create a, so let's create a Conda environment here. So we've called Conda create -n course project. So that's going to create a Python environment where we can install all our libraries. Okay, so now the environment has been installed. Then we are going to activate the environment. So here we now run conda activate course project. So now the environment has been activated. Inside this environment, we might want to install all the libraries that we want to use. So we're going to use Jovian, we're going to use Jupyter. Let's say we'll use open data sets, or you don't have to, but you might. We are going to use pandas, we are going to use Numpy, and we are going to use Seaborn, and we're going to use matplotlib. So we just install all the libraries after activating the environment. And once these libraries are installed, let's just give that a second. Yeah, sometimes this might take a while for you to install, and this is one of the reasons we recommend using Binder, because all of these steps are taken care of for you. So once these libraries are installed, we can now start a Jupyter notebook by typing Jupyter notebook. Okay. So once again, a quick recap of what we did. The first thing that we did was we installed the Jovian Python library. Let me just come back here. I'll open this once again. So once you run Jupyter notebook, this will print out a URL for you, which you can open up on your browser. But a quick recap, the step one was to install the Jovian Python library. And of course, you also need to have Anaconda installed. So make sure that you have the Anaconda distribution of Python installed too. Step two is to then clone the notebook using the Jovian clone command. Step 3 is to enter the directory and create a Conda environment. So that is done using Conda create. Step 4 is to activate the environment and install all the libraries. So you say Conda activate the environment name, and then you install libraries using pip install. And then step 5 is to just open up the Jupyter notebook. So by typing Jupyter space notebook. So that's going to print this URL. So you just take this URL here and open it in your browser. And now you can see here we have the 0 to pandas course project.ipynb file. So now at this point, it is pretty similar to the place that we get to when we click the run button and click run on Binder. So run on Binder is a one-click experience. That's why we recommend it, but with a few more steps. And I think now you are familiar with these steps. Now you are I think you're comfortable enough that you can figure these things out. If not, you can always ask on the forum. So with a few more steps, you can run it on your local computer. Okay, so now we have this 0 to course pandas course project file, and the first cell is a text cell, the markdown cell, and you can remove this cell before submission. Now this cell describes what you need to do. It gives you the guidelines. So the first step is to select a real world data set. So you have to find and download an interesting real world data set, and we have given some recommendations for data sets here. If you see this forum topic on the recommended datasets for the course project. So we have given you links to many places from where you can download datasets. For example, there is Kaggle, there is the UCI machine learning repository, there is a GitHub, there is this GitHub repository which has a list of datasets. And now of course we are sharing this open datasets library with you. We will be adding more datasets there. So there are a lot of places from where you can get datasets. And we've also picked out some interesting datasets for you that you can download and use. So today we've used the Stack Overflow developer survey, but there's also the COVID-19 data. This is updated on a daily basis. There's the state of JavaScript survey, and then there is stocks data, and then there is countrywide COVID data. There is some agriculture data. There is data science job data. There is sports data. There is games data, video game data. So there's a lot of interesting data to analyze. And then of course, there are a lot of places where you can download your own personal information as well and analyze it. So please go through this list and try and identify something that you find interesting. So anyway, you take these data sets, and then you have to make sure that this data set contains tabular data, preferably CSV, JSON or Excel files, that it can be read using pandas. Then you perform some data preparation and cleaning, just as we did. So you load up the data frame, you look at the number of rows and columns, you decide which columns you want to use, you decide how you are going to handle any missing or invalid data. Maybe you might want to parse some dates, like we parse some numbers. You might want to create additional columns. You might want to merge multiple data sets. Then you need to perform exploratory analysis and visualization. So this is exploring the distributions of numerical columns using histograms, using bar charts to visualize categorical columns, using his scatter plots to see distributions across multiple columns, and take note of interesting insights from this analysis. And then also ask and answer questions about the data. So you have to ask at least 5 interesting questions and answer those questions by either computing the results using Numpy Pandas or by plotting graphs using Matplotlib or Seaborn. And wherever you're using any library function, just explain briefly what it does. It's always helpful for the reader. And then finally, take your inferences and summarize them and write a conclusion. So this is a really important part of consolidating everything you've learned into a single paragraph or a single section. And also share ideas for future work on the same topic using the same dataset or maybe other relevant datasets. And make sure to share links to any resources that might be helpful for people reading your analysis. So definitely share links to documentation, maybe share the link to the course page so that people who are not familiar with Pandas or Numpy can use that. And then the last step is to make a submission and share your work. So whether you're using Binder or you're running on your local computer, from time to time you need to run jovian.commit. So you just set a project name. So for instance, my project name would be, let's say, state of JS survey 20 analysis. Set a project name and then use the Jovian library to run jovian.commit and commit the project. And that's going to take this either from Binder or from your local computer and put this onto your Jovian profile. So you simply take this link then, and then you need to take this link and go back to the course project page. And on this page, you need to put in the link and click submit. So once you do that, you will see it showing up in your submission history. So make sure that this is a jovian.ml link. So this should not be a local link. Don't put a localhost link. Don't put a Binder link. Don't put a Kaggle or Colab link. Please commit to Jovian and put up a jovian.ml link, and make sure that that link is to a notebook hosted on your own profile. Otherwise the submission will be rejected. Okay. And what we will do is then we will evaluate your project. So what does the evaluation look like? So here we have shared the evaluation criteria as well. So we will evaluate that your dataset contains at least 3 columns and 150 rows of data. You must ask and answer at least 5 questions about the dataset. Your submission should also include at least 5 visualizations, and your submission should include explanations using markdown cells apart from just code, right? So just code is not good enough. Please write explanations, and that helps you understand your data, that helps you gather insights from your data, and it is also going to help others. Like tomorrow, if you want to showcase this project on your public profile, or you want to share it on LinkedIn or wherever, or you want to link to it from your resume, you want to make it nice. You want to show that you've put in work, you are presenting it well, because presentation, believe it or not, is a very important part of data science. So do not skip that. It's not just about writing code. It's about gathering inferences and presenting them and making interesting observations and maybe making hypotheses and digging deeper. So the data tells you just some facts, but you have to analyze it and really come up with what those facts mean and infer them, right? In the context of either the dataset itself or for your company or whatever you're working on. And finally, your work should not be plagiarized. So do not copy paste from somewhere else. Of course, you can borrow functions, and every dataset has been analyzed by many different people. So you can do this analysis, which people have already done. You can even look at those notebooks. You can look at notebooks by other people, but do not plagiarize. And I think you will be able to tell best if you are plagiarizing. So as such, the entire project should not be a copy paste. And the biggest loser in that case will be you yourself if you're basically copy pasting stuff. So please don't do that. Now, apart from doing that, do share your work online. So this is a lot of effort that you've put into this project. So please share it on your social media. You can just share the jovian.ml link. Once you've committed it, to Jovian, you can simply, where is it? Yeah, once you've committed it to Jovian, you can simply use the share button and share it on any of these platforms. Share your work on the forum as well, because there are tens of thousands of course participants. So we would love to see thousands of projects being shared on this thread. So do share your work on the forum and browse through projects by other participants and maybe give feedback. And that will also be a great way for you to learn. When you see other people creating visualizations, similar or different visualizations, you will get to learn from their code, you will get to learn from their analysis and so on. So please do that. And one highly recommended step is to write a blog post. And a blog post is a great way to present and showcase your work. So you can sign up on medium.com to write a blog post for your project. It's really simple. You just sign up and then you click new story and you can just start typing. And you can simply, as a starting point, you can simply copy over the explanations from your Jupyter notebook into your blog post. And in terms of the code and the graphs, you can actually embed them. So you can take your code and graphs from your Jovian, the notebook submitted to Jovian, and you can embed them within your blog post. So you just watch this video for a quick tutorial or just follow this guide. So you can see here that this is a blog post on Medium, and inside it is embedded a code cell, or you can even embed an entire, you can embed even like some code and the outputs, like things like graphs, or you can only embed just the graphs if you want to see it. So the benefit of writing a blog post is that it, with Jupyter, it contains a lot of code and contains a lot of pre-processing steps, but on your blog post, you can decide the narrative and you can simply use the right code blocks, and you can use the right write graphs from your Jupyter notebook, and you can embed them within your blog post to tell the story that you want. It doesn't have to follow the same structure as the Jupyter notebook. And it will be a great thing to showcase on your profile. It will be a great thing to share on your social media, put up on your resume, or just mention while you're applying for an internship or things like that. And you can check out our Medium publication. We've linked to it for how to write a good blog post. There are many good examples. All of these have been written by people from the community, and this was during a previous course. And in fact, all of these are, in a lot of these cases, these were the first or the second blog post written by people. So please do check it out, and don't be afraid, you can write it too. It just takes a little more effort, maybe a few more hours after you do your project. Okay, but do write it as far as possible. And as I mentioned, we've shared some recommended data sets, and we've shared some example projects. So you can go through these projects, and you can keep revising this video as well to just get a sense of how you should analyze your data. And you can either use this notebook as a starting point. We've created this template for you where you can put in the project title, write some introduction, and then there are sections for each step. And remember to commit your work at each step so that you do not lose your work. Or you can also start from a blank notebook. That is perfectly all right. It's all a question of what you feel most comfortable with. And do remember to just remove this cell before your submission so that the instructions are not included in your final submission. Okay, so with that, we've just revised the course project as well, and you have time till the 3rd of October. That should be sufficient time. So please do put in the work. If you've come this far, you should definitely do a course project while you have all of these things in your head, and it will really reinforce all the ideas that we've learned. Now, I just want to do a quick recap of the course for a couple of minutes. And a lot of you started out without even Python programming experience. So we started out with an introduction to programming with Python. We just looked at the first steps with Python and with Jupyter notebooks, using it like a calculator. We explored data types and variables. We saw branching with conditional statements and loops. And then in the second lecture, we looked at writing reusable code with functions, working with the OS and the file system. And then you solved the first assignment where we solved some word problems using variables and arithmetic operations. We manipulated data types using methods and operators, and we used branching and iterations to translate ideas into code. And we also learned how to explore the documentation, how to get help from the community. So after learning Python, we looked at NumPy. So we saw how to go from Python lists to NumPy arrays. We saw how to work with multi-dimensional arrays, and we saw what were the different array operations, matrix operations that you can do. We learned about slicing, we learned about broadcasting, and NumPy by itself is a very powerful library. And we also saw how to work with CSV data files. Then we did an assignment on NumPy array operations, where you explored the NumPy documentation and demonstrated the usage of 5 array functions. And you created a Jupyter notebook with explanations about 5 functions on how to use them and how not to use them. And we shared hundreds of notebooks with the community and probably learned a lot from each other. Then we learned how to analyze tabular data with pandas, which was reading and writing CSV data with pandas. We learned how to query and filter and sort data frames. And pandas data frames are really powerful. And even today we've seen a lot of different functions which we probably did not explore earlier. Then we also looked at grouping and aggregation for summarizing the data. We looked at merging and joining data from multiple sources. And then we did an assignment on pandas where we applied all of these things that we learned. Finally, we had one lecture on visualization with Matplotlib and Seaborn, where we learned how to do basic visualizations with Matplotlib and advanced visualization with Seaborn. So things like line charts, scatter plots, bar charts, heat maps, and histograms. And then we also saw how to customize and style charts, how to make them beautiful. And we also saw how to plot images and how to plot multiple charts in a grid. So all of these things then we tied together into our today's lecture on exploratory data analysis, where we found a real world data set, the Stack Overflow developer survey with 65,000 responses. We loaded the data, cleaned it, pre-processed it, did exploratory analysis and visualization. Then we asked and answered questions, and we made a bunch of inferences. And now you're working on the course project, where you will repeat this process on a real world data set of your choice. So that was a quick recap of the course. Now what should you do next? Try out the notebooks yourself. You can revise any of the previous lectures. You can watch the videos. You can run the notebooks. It's a one click away at any point. Definitely try out the Stack Overflow survey results and some of the exercises there. And if you have any questions, you can always ask questions on the forum. I've been saying this from the start, people who are active on the forum are the most likely to complete. So if till now you've not checked out the forum, just go to zerotopandas.com and there is a link to open up the forum. So here you can see there's a course community discussion forum. Any question you have, we have topics for each lecture. So any question that you have, just go to that topic and first search through that topic. It's likely that your question has already been answered. And if not, you can always post a new post on that topic. Just reply to that topic and somebody will answer it. Like, we have an amazing course community, and we've been seeing huge contributions from people spending hours just answering questions from other people. So I just want to give a big thank you to them. So please do participate into the forum. Now, if you complete all the assignments and the course project, then once we evaluate all of that and you get a pass grade in all of them, then you will be issued a certificate of accomplishment. This will be a verified link hosted on jovian.ml. So it will be a page on jovian.ml, a part of your profile where it can be displayed. And this will be available for download as a PDF as well. So if you want to download it, print it out, you can do that too. And you will be able to add it on LinkedIn onto your LinkedIn profile, so that anybody who visits your profile will see that you have completed a certification on data analysis with Python. And you will also be able to share it online on Twitter, Facebook, or wherever. So we've all put in a lot of effort. So we can definitely celebrate it once we earn the certificate of accomplishment. Do share it and even encourage your friends to take the course in future sessions. This is what the certificate looks like, but this will be embedded into a web page from where you will be able to download it and share this page as well. The thing you should not do is immediately do not jump to another course. Work on a project. Make your project as large and as interesting as possible, because it's not enough to say that you've done a course, and it's not enough to say that you have a certification. It's not enough to just say that you've done a small project. You should have a significant data analysis project under your belt, and it should be something that you have documented and presented well, and it should be something that you have put on your public profiles, right? So do something that you feel proud of, and then put it up on your public profile. Improve your professional profile, and write blog posts, write tutorials, and write guides. You can do this on Medium. You can do this on GitHub pages. There are a lot of platforms where you can write blogs. You can use Jovian to share your Jupyter notebooks, and I'll talk about that a little bit as well. But do write any guides that can help people who came before you. So look back at yourself and try to write maybe a small tutorial for that person to encourage them to demystify data science for them, or maybe just to tell them that pandas is not as scary as it might seem, or maybe just point them to this course and say that you can learn about it here. So there are a lot of resources available online for you that you now know. And so you can now curate them and share them with your community, right? So if you're a student, share them with your classmates. If you're a professional, share them with your colleagues, share them within your company. The more you share your knowledge, the better you get at it as well. Okay. And then improve your professional profile. So showcase your certificate, showcase your project on your LinkedIn profile, on your GitHub profile, on your resume. So do that. And then once you feel like you've really done a lot of work on this topic, that is the point at which you should then take more data science and machine learning courses. So do not fall into the trap of just doing a bunch of courses without any real output out of them. The best way to learn is by doing good projects. Now you can use Jovian.l to build your professional data science profile. And we are working on some very interesting improvements to the profile, a lot of which we've already added. So if you go back to just open Jovian.ml and log in. So if you just go to my profile, if you're logged in, so you can see here that on your profile, you will be able to add more information. So on your profile, you will see an edit button where you can add your current designation, you can add your current university or your company. And you can also link your GitHub profile. And here you can see a collection of all the notebooks that you have created so far. So any Jupyter notebook that you create anytime, any interesting analysis that you do, just upload it to Jovian. So just run jovian.commit inside it and it will get added to your profile. You can also upload notebooks directly. If you have a Jupyter notebook somewhere on, let's say you have somewhere on GitHub, or you have somewhere on your computer, you can upload that too. Or you can import it from a URL. So you can do that. You can also create collections. So you can create collections where you see interesting notebooks joined together into a single collection. For instance, I have this collection on deep learning with PyTorch. I have this collection on data analysis with Python Pandas, where I'm going to add a few more notebooks. So that's an interesting way to organize your notebooks. And you also get access to the forum as part of the profile. So try to answer questions on the forum, because that is then going to also reflect on your professional profile. The more questions you've answered, the more knowledgeable you are. That's what it is to use Jovian. And all these projects that are hosted on Jovian, by default, you have this really nice, beautiful, optimized view of the Jupyter notebook. You can these are mobile friendly views. So if you even open these on mobile, you will still be able to, they will load up really fast. We spend a lot of time just tuning the performance of these pages. If you're sharing a link to a Jupyter notebook, a lot of people are probably going to open it on mobile, and on mobile, this might not render well on different platforms. So please do use Jovian. It's a great way to share this. And it's also a great way to just show all the work that you've done, because the version history of a notebook shows how much work you've put in. So if you have a notebook with some 20 or 30 or 50 versions, and then you share that with somebody, then they can go through it and they can see that you've really put in a lot of effort into this. So a lot of this about your professional profile, a lot of it is about just showing what you've done, making it visible for people to discover and learn more about. Okay. And you can follow us on Twitter. So we are JovianML at Twitter. We keep tweeting interesting notebooks. We keep tweeting interesting resources for data science. In fact, if you tag us, if you share your notebook online and tag us, then we will definitely try and retweet interesting notebooks. We try and retweet 4 or 5 interesting notebooks every week at the very least. So we hope you find Jovian useful. And just on behalf of the entire course team, I just want to say a big thank you to you for being so active on the forum, for doing all the assignments and working on the project, going through all the lectures, and just being awesome overall. We were really excited to run this course, and this is really not the end. We are hoping that we will continue to have a long association with you. We have a lot of interesting things planned for you. So I will see you in the forums. This is the end of our lectures, but we will be able to interact with you via the forums. You can follow FreeCodeCamp, follow Jovian.ml, on Twitter or follow me. With that, we come to the end of data analysis with Python. Thanks a lot for joining, and all the best for those of you who are still working on the assignments on the course project. And I hope to see you soon in a future course. Thank you and goodbye.